Just confirm if my voice is audible. You can hear me. You can see the screen. All these three things. Okay. Thank you so much. So, good morning or evening, everyone, depending on where you are. And let's get started with session 5. So, in the last week, we discussed about 6 layers of context. We discussed about what is the system prompt constituting. We discussed about RAG in detail and also MCP, Model Context Protocol. Today, we'll be primarily looking at 2 things. One is the compress part of the WSIC or WSCI architecture. W is a write, then isolate, select, compress. So these are the 4 parts. Select part is RAG. Write is creating the memory, persistent memory or short-term memory. Also creating scratch pads using task.md. And compress is something where you have a context window which is getting populated as you keep using the large language model. And then you want to retain certain information and you want to remove noise. So compress is an operation which can basically do that. And in Cloud Code, for example, the way it is done is using the /compact command. And isolate is something which you will be very interested to learn about, because here we will discuss about sub-agents. So if you have ever used Cloud Code or any other agentic coding platform, you will see that sometimes it will automatically spin sub-agents for different tasks. Sometimes the tasks are in series, they are serial tasks, and sometimes they are parallel tasks. And you know that it speeds up the execution by a lot. So we will discuss how exactly is context window constructed in these cases. What happens to the context window when you compress? Is there loss of information? If yes, how do you mitigate it? Or do you even want to mitigate it? And if you are isolating the context, what does that mean in terms of what happens to sub-agents? So sub-agents have isolated context, and some part of the context is also shared. So we will see how from the perspective of context window, how these concepts work. So just to reiterate, a write part is something where we decide or we tell the model that if you are working on a subtask, create individual task.md files, and these task.md files will have to-do nodes, and those to-do nodes will make sure that for each task, the model is at any given point of time focusing on the subtask. So if the model is at the same time building front end and back end separately, or let's say you are working on a research agent where one agent is running certain experiments, another agent is running some literature review or finding the gaps in literature or something like that, then they can have their own short-term memory. They can have their own subtasks, and then those tasks will be finished separately, independently. And select layer is selecting what you need into the context window from outside the context window. So from outside meaning it can be from a database, vector database. It can be from just a file system. And retrieval augmented generation selects things out of the context window to be considered to the context window. And in the WSCI framework, compress and isolate is what we will be looking at today. Okay. And this isolate part is where we will discuss about sub-agents. And this is something that we have discussed many times. The reason why we want to compress is twofold. One is when you are compressing in the next round of iteration, the agent is getting smaller number of tokens in the API call. And oh, the screen is blank. Do you all of you are seeing the blank screen? Can anyone confirm if you see the screen or if you're okay? Okay, thanks. So what I was saying was the reason why you want to compress the context is because you need to reduce the number of tokens that are going into each LLM API call. So let's say I have a question. Okay, this we will discuss in detail after a little bit. But basically, say we have one agent, and let me stop some background processes. My computer is becoming a bit slow. Just give me a second. All right. So I hope everyone should be able to see the screen now. So you have one agent, and let's say this agent is making a API call. Can you tell me the cost of your large language model usage? What is it dependent on? Is it dependent on the number of API calls you make, or is it dependent on the number of tokens which you consume? Let's say to one LLM, you make 300 API calls. To another one, you make 20 API calls. All right. In the first case, you consume, let's say, 10,000 tokens. In the second case, you consume 200K tokens. In which case do you think you end up paying more? You're basically build based on token consumption for input as well as output. So it doesn't matter if an agent is spinning sub agents who can make their own separate API calls, as long as you're managing your total token consumption in the form of an optimized context window really well. So it doesn't matter that you give your sub agents ability to make its own API calls, as long as the context window for that sub agent is very minimized. It's minimum number of tokens. So for two reasons, you need to compress. One is, of course, to minimize cost. Second is to minimize the rot of the context. Because imagine you have only one agent for doing every single task. That agent will basically, let me just allow certain people into the meeting room. Yeah. So if there was only one agent doing all the tasks for a project, what will essentially happen is that agent will eventually experience context rot. So beyond certain point, there is too much information in the context window to process, right? This we have discussed a lot of times. So there are largely four types of compression. First type of compression is the most obvious one, or probably the most powerful one. Not necessarily the most cost optimized one, but it is summarizing the context window using a large language model itself. So what you could do is, so one of the most popular context compacting or context summarization methods that is used in cloud code is LLM based summarization itself. So you make another API call to which you pass the context, but ask the model to summarize the context into certain number of tokens. So if the context window size is 200K tokens, and you have reached, let's say, 80K or 100K tokens already, you could ask /compact. You could run the operation /compact, and then the context can be compacted to much smaller size. Often these coding agents also have 80% context window limit, where if the context window reaches more than 80% of its total limit, it will start an auto compacting operation, and which will be based on LLM and which will be much efficient. But sometimes, if let's say in the next output, in the next iteration of API call, the output created is so big that context window exceeds 95% of its capacity, even more aggressive trimming will happen, meaning some parts of the context window will be aggressively deleted. All right. So we will discuss this also in an interactive way when we are getting into the lab exercise. Do we have any easy way to calculate tokens for large context? Yes. So at the end of the day, context will be having two types of things: structured inputs from JSON files or other file formats, and natural language inputs. On an average, one word is equal to one token. So that is one way to see. I mean, for hand calculating, if you want to hand calculate how many tokens have you consumed, just count the number of words. Otherwise, ChatGPT itself has a context um, um, token size calculator. You can just Google ChatGPT or OpenAI token length calculator. They provide a window into which you can paste whatever input you have, or whatever text or whatever your context window looks like, that you can copy paste, and it will tell you exactly how many tokens are you at right now. And in cloud, usually the context window size is 200K tokens, which means if you are at around 160K tokens, you are in some sort of not yet in the danger zone, but you are at a zone where you would want to perform some compaction. So the way I work is, in cloud code, the auto compaction happens whenever the tokens have reached 80%, meaning if it reaches around 160K tokens, you will see that auto compaction automatically starts, which is based on LLM. So it will make another API call and that API call will semantically compress the current context into much smaller section. I will show you the details of what are we compressing. There are tool results, there are system prompts. What exactly do we compress and what exactly do we not compress? And what are the after effects of this that we will see. But often in my execution, what I do is I do two things. One is if I'm completely switching from task A to task B, where I don't want any relation with, I don't want to be any memory from task A to be carried forwarded to task B. I just put the operation /clear. And I have noticed in many type of tasks, this provides significant improvement in the output quality. Especially if your quality you observed is to be degrading, you have to do a /clear operation if there is a clear distinction between two tasks and they are not sharing anything in common. However, if the task is slightly distinct and you think that a lot of the things that are accumulated in the context window so far is because you have been carrying out a lot like a long operation and the context window is having a lot of tool results. Let's say you were running paper banana to generate images and you are having 17 images to generate, and then in these images basically you have provided the descriptions of images, but then by the time you are reaching for 15th or 16th image, your context is so bad that the sort of images that are generated are very bad. Then at that point you can decide, okay, I don't want to lose the overall context, just do /compact and then continue generating, and you will see a significant step function, like a step function, the improvement in quality of the output. So first type of compression is summarization. Second is called tool result clearing. Can anyone tell me what is tool result clearing and why can we simply clear the results of a tool call? Why is it not problematic, or is it problematic? If yes, why? If not, why not? So and in simple terms, first of all, okay, let's go step by step. What exactly is tool result? You can refer to the discussion we had in the last lecture, right? So a simple example is, let's say the MCP server is sending some sort of structured result as a result of invoking of a function. So a tool you can imagine to be a function, or it can be an API call which executes certain function or fetches something from the database. At the end of the day, there is some input going into the tool. Tool is providing you some output. Output might be in a structured JSON format or in any other format. Now, you might notice that in many cases, this output will have so many things. It will have just-in-time instructions. It may or may not have verbose results, like which is like very detailed, because often LLM, for it to use the tool results, it need description of the structure of the result, plus the result itself. So it will be very big document. Now think about this. Is the result of a tool execution, is it stochastic or is it deterministic? Like if you run a function with a certain arguments, okay, do you expect the same result with if the arguments are the same? Typically, functions are such that the result of the function is dependent on only one thing, which is the input or arguments going in, which means there is great deal of deterministic nature when it comes to tool results. So, of course, it depends on the functions, whether function itself has a stochastic nature, but in general, the functions, if you want to mimic the results of the function which you got earlier, and if you are in such a dire situation that your LLM context window really needs the result from a particular tool, it can simply run the tool call once again, right? So there is no need of storing the last previous tool call results in the context window continuously. You could simply entirely delete the tool result, or you can simply compact it into few sentences. The tool result, which may be in multiple lines, maybe in JSON format, can be compacted into simple natural language 2 or 3 sentence summary. In some cases, if you are aggressively trimming, which is what happens in a concept called priority based trimming, the tool results have it's of one of the lowest priorities, which means tool results will be aggressively trimmed. Trim meaning entirely cut away. It will not be part of the context. But Cloud Code does not use this that often. The most common two compression methods used by Cloud Code is LLM-based compaction and tool result clearing. We will see this with an example, how it visually looks like, how the context window visually changes when we clear the tool result. And the last one is, so in priority-based trimming, we just assign levels of priority, P0, P1, P2, P3, etc. P3 is something with the lowest priority, and P0 is something with highest priority. Highest priority meaning it will be the one to go last. It will be trimmed the last. Now, based on all the things you know, what could be P0? So P0 is, let's say you have examples, a conversation history, system prompt, then tool result, then maybe some custom instructions for the agent. What could be P0? So one of the highest priority items by default is system prompt. System prompt is the last to go. System prompt will often have rules, right? So system prompt is definitely not P3. What could be an example of P3 other than tool results? So tool results, yes, it can be of low priority. What else could be P3? So we can define P3 in the following way. For example, let's say we had a conversation history from many context windows, not context window, many conversation windows before. So if we define one conversation window to have X number of back and forths, a conversation which happened much before can be significantly summarized or completely trimmed away to preserve the context. If it comes to trimming, by the way, trimming does not happen in Cloud Code unless you are at 95% of your context window filling. If context window has filled 95%, this will happen. Otherwise, trimming is not done. Okay. Can you give me one more example of something other than system prompt, which you may not trim? That I will come to in this hierarchical compression. So in hierarchical compression, using semantics, you will decide what has the highest priority and what has the lowest priority. And whatever is the highest priority will not be removed. Whatever is the lowest priority will be removed. So in hierarchical compression, to decide the hierarchy, you are using semantic meanings. Here in priority-based trimming, you are using rules to decide what comes in P0, P1, P2, P3, etc. So can you tell me something that can be at the highest level of hierarchy, meaning something that will be removed last, which is not system prompt? Okay, many people are saying user prompt. Okay, for sure, user prompt is something valid. You cannot delete user prompt just like that. But my question is, let's say user gave a prompt, LLM gave an output, for example, and that output is now output tokens are now added to the context window. What type of output might come at the highest level of hierarchy? Something which you should not delete or something like that. It could be something like an output where after this output, the user is supposed to give a preference based on the output, right? So for example, let's say you're building a website and your phase one is being executed. In phase one, you have explicitly told the coding agent that at any point, if you feel like you need my input on the user interface or user experience, or the way you have to arrange your cards in the front end or something like that. And let's say the LLM is supposed to receive an input from the user after it produced its latest output. So LLM might have produced let's say, a skeletal structure. Now to add meat to it, a user instruction needs to be provided. And for user instruction to be provided, it is very important that the LLM retains the immediate previous output, right? So that immediate previous output, which the user has not yet seen, or the user is supposed to comment something on, should be kept while doing compression. And how does the LLM know whether something is of such high relevance or something is of not high relevance? Simply by making another LLM call and another API call. In that another API call, semantic meaning can be associated to different parts of the current context window. Based on the semantic meaning, You decide the hierarchy. And what you do is, if you are at the top of the hierarchy, 100% of the items are retained. If you are in the next level of hierarchy, 70% of the items are retained. If you are in the next level, 50% are retained. If you are in the last level, only 10% is retained. So if only 10% is retained, this could be most likely tool called results. So if you are compressing your tool called results into 10%, it simply means your tool result will become a 1 or 2 sentence summary. All right, so this we discussed already. So in LLM summarization, if you have a long conversation history between the user and the assistant, you simply convert it into natural language summary. So structure might be lost. Some nuances may or may not be captured. But the goal here is most of the information or most of the facts which are there in this conversation should be ideally captured. And there is something called IRR, information retention ratio, which is if you decide that if you can say out in this initial context, there are 30 information which can be mentioned in bullet points, which should not be removed. If all the 30 can be recovered even after compression, then the IRR ratio is 100%. If only 90% can be retained, so is the IRR. So then basically it's a lossy compression, right? Compression is always lossy. Sometimes the loss that happens is something that is not relevant. Many times you want to make sure that the facts which are quantitative things are retained. In tool result clearance, this is what I showed. Tool result will take you from large number of tokens being consumed to very, very few number of tokens being consumed. This we can visualize when we come to the implementation part. And this is the most common thing, which even if you are not using cloud code, even if you are constructing a coding agent yourself, one thing you should define is how tool results are cleared or compacted. This we already discussed, when to remove which are of highest priority. So system prompt is of highest priority, never removed. Core instructions to your, let's say, which is there in the root folder agent.md file for the agent orchestrator, or core instructions for the which are defined in the cloud.md file, they are not removed. Tool definitions, which may be part of cloud.md file if the number of tools are less, or tool definitions that are currently living because RAG fetched the tool definitions from your database, are also again not removed. There is a question. We are not counting thinking tokens at all because thinking tokens are not at all included in the context. Like they are just part of test times scaling, but not really included in the context. You mean in reasoning models, right? So one thing we can do is, yeah. So yes. So typically thinking tokens, to my understanding, it is also included in this context window, because at the end of the day, if it is a chain of thought, for chain of thought to propagate, you have to have the previous output which was produced as part of chain of thought to be added in the context. But one more thing you can do is, in the last week, we had a brief discussion last lecture or last to last lecture, we had a discussion about should you always have reasoning based large language models for React to be implemented. There, it's not really necessary that you need reasoning based large language models. You can invoke behavior similar to reasoning with non-reasoning LLMs also, just by relaying its output in the form of reasoning. So you force the LLM to come up with a reason, then coming up with an output, coming up with a user output, and then go 3 or 4 loops of that before giving the final output. Is there any lecture around it? You mean a lecture around reasoning is itself? We don't have a specific lecture around reasoning, but the basic idea is that the tokens that are consumed during reasoning, tokens that are generated in the output as part of reasoning, is also consuming the context window for sure. Then, yeah, so the current, okay, first of all, let's see this. Older history, this could be part of conversation or part of, let's say, summary of the tasks that are completed you don't need. Tool results, stale tool results mean tool results which were produced earlier, which is not useful anymore, not needed. This compress if needed is, this is this is not done always. This is only in extreme urgent cases where you actually have to trim some recent conversation also. So you will clear the recent conversation and recent tool results only if you absolutely have no space in the context window, right? Older conversation history and older tool results are cleared first. Then current task context, current user query, and current action plan. These things are again having very high priority, which means this will not be removed. System prompt is always kept. Then in hierarchical compression, this is what I said. Hierarchy is decided based on semantics. So if hierarchy is of the highest, 100% is preserved. If it is important, 50%. And if it is in the lower part of hierarchy, 10% or only 0% is kept. This I have already discussed. Okay, is this how coding agents are designed today, like Cloud Code? Yes, exactly. So in coding agents, you don't have to define how compression works because these principles are already inbuilt inside the coding agents. However, coding agents are at the end of the day, these instructions wrapped around an already existing LLM, right? So already existing LLM is Opus 4.6, for example. Around that, these things are built. And that is how Cloud Code is built. However, if you are using OpenClaw, you might have noticed that when you install OpenClaw, they give a long set of available LLM options. So in OpenClaw, when Pete Steinberger was building the OpenClaw framework, he has followed many things that are mentioned over here. However, the only difference is there it's not primarily a coding agent. It's primarily a agent which can act as a personalized assistant. Yeah. So hierarchy-based assistance trimming is basically this. Inside the context window, instead of saying, hey, tool results have lowest priority, system prompt has highest priority, or old conversations have low priority, new conversations have high priority. Instead of explicitly saying that, you let an LLM figure out based on the semantics of what is there in the current context, decide which part of the context is highly relevant, which part of the context is highly not relevant. In the previous one, which was trimming based on priority, there is no LLM involved in deciding what is recent, what is relevant, etc. Relevancy is decided based on the structure itself. So in the structure, if there are tool results, which has a timestamp which is more recent, you can decide a cutoff. Tool results from the last 10 invokings of the tool are not part of the are part of the context window. Everything before that is thrown out of the context window. So you are deciding a cutoff based on just some logic which is predefined. However, in hierarchy-based compression, it's not trimming, by the way, it's compression. So you are not entirely removing nothing much, but you decide that this is the hierarchy of different sections of context. If something is at the highest part of hierarchy, you don't trim it, you keep it 100%. As you go down in hierarchy, you assign lesser and lesser importance, which means you summarize it more and more. So higher and higher compressions are applied. So finally, when it comes to the lowest level of hierarchy, you may compress it to 5% or 0%, so that almost nothing is kept. Maybe a one sentence summary is remaining. And as you go up the hierarchy, you will see everything is retained pretty much as such. So one more thing is when we are performing compression, it is expensive because you can't keep on compressing. See, if you want a clean context window, you could ask, then why can't I keep on compressing every single time? Why do you not do that? Why do you not compress the moment, let's say you feel like your context is growing? Why do you wait for 80% cutoff to happen or 95% to happen? Why not always compact? Or why not always clear the tool results? Always compacting is anyways not good. You will compaction all by definition, it means you are losing some information. But at the same time, you have to call the LLM, you have to call some sort of LLM for most common type of compaction, which is LLM based summarization. And that is expensive, right? So now imagine it will be double as expensive because your context window is 200K tokens. You are then calling the LLM for compaction, which means another 200K tokens are consumed. And that LLM will provide you some output. Maybe that is like 10K tokens. That 10K tokens are now used to represent your original context. So apart from your original 200K tokens, which were part of the context, let me just draw it. So let's say this is your original context. And maybe, so this is 200K. and only 100K is consumed so far. Now you make another API call to the same LLM or to a different LLM, depending on how your structure is. Into that LLM, you will pass the same context and provide instruction. So instruction will be maybe this much on how to summarize. And then that LLM will produce the summarized version of this, right? Summarized version of this may be only these many tokens. Now look at the cost associated with this. To compress this much, you are consuming so many tokens. And then what you will do is this compressed context window will replace this 200K. Now this, if 200K out of this 100K is consumed, now this compressed section, this will replace our context window right now. So yes, you compressed by 90%. You went from 100K tokens to 10K tokens, but at a cost. The cost is you ended up consuming these many tokens in a separate API call. Plus you will introduce, of course, as somebody mentioned in the chat, latency, because each time you make this API call, you're waiting for the results to come so that you can replace the results with this in this compacted context window. So you don't use this very, very often. Okay, very good question about how do you choose the best model for compression. So typically for compression, you don't need a proper coding based model. You just need a model that is good at language in general, because LLM based compression is basically compressing most of the things into summary sentences. So it needs to be really good at natural language. So even if you are using Claude code, I don't know how it internally does this compression, whether the model is different or not, that I have to check. But if you were to implement something like this manually, you can use your best model for dealing with your original context window. And for compression, you can use a lightweight large language model so that at least API call you can minimize. Latency will still be there. Sometimes you can also compress based on some sort of keyword based extraction. So you can, from this context, based on keyword, you could extract the required portions, and that required portions to be converted into a meaningful format. You can pass it into a separate API call, which means you are not consuming like 120K tokens or something like that. You may consume like 30K tokens, and then that can be compressed into 10K. So this is the idea of compaction. But there is one more concept that we need to discuss apart from compacting the context, which is splitting the context across different agents who are performing different functions. Let me just check if anybody is waiting in the waiting room. All right. So in Cloud Code, we don't have to mention explicitly what the compression technique is. By default, it will be using LLM-based compaction and tool result clearing-based compaction. Those are the most commonly used. You don't have to explicitly say. However, for whatever reason, if you want Cloud Code to use different type of compaction, because you would say, hey, you are an auto research large language model. Actually, why don't I show you something? Let me open my Visual Studio Code. Just give me a second. I'll stop sharing the screen for a moment. All right. So do you see my Visual Studio Code right now? Just if you can confirm with yes, that'll be great. Are you seeing Miro board or Visual Studio Code? Okay, thanks. So basically what you're seeing right now is one of my workspaces where I am using a continuous research agent to explore one problem statements that we are working on at the moment on vision language action models. Okay. So this agent, I will just show you this agent. It was released by Andre Karpathy in last week. It's called Auto Research. So basically what this agent does is, and this has blown up, by the way, in terms of number of stars and all. Last time it was 30K. In one day, it has gained 6K, 7K more stars. Basically what this agent does is, so he shows in this graph, agent will conduct research and it will figure out what kind of experiments to done, what kind of model architecture changes to bring to better your results. So I just wanted to see if we are running some experiments, if we ask this auto research agent to conduct our own research, or conduct its own set of experiments, will the accuracy, or will the metrics that we are tracing, will it keep on improving, and what will happen to the expenses, etc. So here one comment which I had provided explicitly to Cloud Code while defining the its purpose was, I am worried that my context window might rot because you are working on so many different tasks one after the other sequentially in the process of running these experiments and writing the paper. And because of that, I'm worried that you may even hallucinate some results or hallucinate some experiments. So then what I did was this, I explicitly mentioned, like whenever you decide to do a new set of experiments where you feel like the previous set of experiments are in a completely different sandbox, and the new experiment can be considered to be a different sandbox, even if your context window is not bloated yet to 80%, just make sure that you are doing an auto compaction. So with this, because of this, in none of the sessions, although this was running 24/7 for last, so I started this experiment on sometime on Saturday around 2 p.m. or something like that. Although this was running 24/7 for the last almost 2 days, never ever it ran out of the session limit. So as you know, if you have used Cloud Code, it has a session based usage limit, and then after the session it will refresh. But that never happened with this, and I was keeping on, and I had asked it to push it to my GitHub. So it was keeping on pushing the experimental results to GitHub, and I was tracking the experimental results on GitHub, and not even once it stopped. One way in which this could have stopped is I had given it my runpod access through runpod API, this access token, I think API, not access token. And then I had around $100 in the runpod. I had recharged runpod credits. Only if the $100 ran out for whatever reason, it would have stopped. Otherwise, due to context issue, it would never stop or it would never rot. So yes, I am on a $200 cloud plan because I use it very much extensively for building products and running different experiments. Plus, multiple people in my team use the same account. So we have total 3 accounts, which are maybe used by 7 or 8 different people. So if my credits run out for a session, I just switch the account. So that's what I do. It's not ideal, but that's the only option right now available. So what is done is, if you have a big task, a big project, there will be a lot of files which are actually relevant. All those files, obviously, you cannot fit in the context. And this is where you define sub-agents by giving isolated context to these agents. Yeah. So how did you ensure context did not blow up? I simply gave an explicit instruction. The explicit instruction was that whenever you are switching task, whenever you are going from one experiments to another set of experiments, even if the context has not reached 80%, you compress the context or run/compact operation. So this will ensure that when I'm running from one experiment to another, all the baggage from the previous experiments are not carried forward. This will significantly keep my context clean. Plus, it will also keep my price a little bit low, price or token consumption a little bit low. I mean, there are many different ways to do this, by the way, but this is what I tried because I was so worried that this may not run 24/7 simply because session usage might exceed, because that has happened many times. But not even once it did exceed the session, although it was continuously running experiments. One thing might be because the experiments are actually run on runpod GPU and not by Cloud Code itself locally. That is one reason, of course, why too much consumption is not there. On the other hand, if you are building a website or something, all the files, node modules, packages, you are literally defining locally. So lot more tokens might be constructed in, let's say, web development compared to in actual research. Because in actual research, you almost never run your code in local Python. So the Visual Studio screen which you saw is not my computer. It is an AWS EC2 instance with some 32 GB RAM or something which I purchased because I needed RAM because I need to run multiple agents on that same computer. So the computer should not slow down. But at the same time, many agents do not run the experiments like building website or running Python script on EC2 itself. So I have connected the EC2 with runpod. So all such heavy experiments are running on runpod GPUs. So because of that reason, one, my Amazon my AWS EC2 instance does not slow down. Second, my token consumption of Cloud Code is also not that high. But that's an artifact of what type of experiments I am running. But if you are running some experiments where you are running Python script locally in EC2 instance or your Mac Mini or whatever device you use or your computer, I'm 100% sure after some time if you are running 24/7 experiments, your session memory will run out. I forgot what is the total usage, total number of tokens that you can very easily see by typing /usage. In /usage, they will show a bar whenever usage is about to exceed the session limit. Then, okay, let me ask you a question. This, I think many of you may have doubt about. If we, okay, I'll answer one more question. Did Cloud Code figure out how to use Runpod API so that you can steer it from your EC2 project? No, Cloud Code did not figure out automatically. I mean, API key, of course, I gave Cloud Code, but other than that, Cloud Code, it's very basic. Cloud Code already figuring out how to run Runpod using its API is a very trivial thing. I don't know if it has MCP or just API calling is enough. I don't think it's MCP, it's just API key based. So that part was very easy. You can just give the Cloud Code access to your Runpod and ask it to execute the code, store the results, and keep the inference. Those things, keep it on EC2 instance. Runpod, you initiate the pod on Runpod, run the experiment. Once the experiment is done, once no immediate experiments are planned, just close it, terminate the pod so that you are not accumulating cost. One day it so happened that I was not using Cloud Code and I was manually running Runpod instances. And then what I forgot to terminate it. Then in 2 days, we had some, I think, $150 or $200 bill for nothing. I mean, we were not running any experiments at all because there is some idling cost also for storage. So if it goes for certain number of hours, by default, I think it's $0.8 per hour or something like that for most of the pods. But for expensive pods, for more storage, it will be higher. So even if you are not running any GPU instances at any given point, you will still accumulate some cost. So if you are not running anything, you have to terminate it or pause it. So what I have done these days is I initiate the pod as and when I need. For new experiments, I tell Cloud Code, one of your tasks is to minimize my run pod bill. So for that, but at the same time, it should not impact the quality of your experimental results, because if you need to use the same pod again, you can use that, but make sure that you are minimizing my bill. But if you don't have to keep a pod in idle state for 1 hour or 2 hours, if that is what is needed, in that case, you terminate the pod, you restart a new pod when your new experiment has to start. But whatever results you have from pod number 1, store it in the EC2 instance so that it can be passed if needed into the run pod instance number 2. So these are some instructions I have given. I don't think such extensive instructions are needed. I just gave this as a safety. But if you want to just run the run pod with minimum cost, you can just say that in simple, plain English, and Cloud will most likely take care of it. Last week, I remember one question was, if you have two agents, agent number 1 and agent number 2, okay? Let's say Cloud Code is spinning two sub-agents, agent 1 and 2. According to your current understanding, what happens? Do these agents access the same LLM and same context window, or do they make separate API calls, and they have separate context windows? Plus, one more question is, do they share anything in the context window? Is some part of the context window of agent 1 also accessible to agent 2 directly? Like, is there some way of sharing the exact same tokens which agent 1 is using and agent 2 can also use? So ultimately, all the sharing happens through agent orchestrator. The individual agents do not share context window directly. Why? Because they are completely separate API calls. So context window of agent number 1 and context window of agent number 2 are two different things. However, if, for example, system prompt needs to be provided to both agents, which means the tokens corresponding to the system prompt, which are stored in agent 1, and tokens corresponding to system prompt, which are stored in agent 2, may look very much the same, because a tokenizer that is converting system prompt into LLM's tokens will be applied similarly. So let's say the cloud.md file is to be entirely present in agent 1's LLM API call as well as agent 2's API call. Then the way in which that cloud.md is tokenized will be the same, because you are using the same LLM, same tokenizer. So the tokens that represent the system prompt in the agent 1's context window will sort of mimic the tokens that represent the system prompt in agents 2 context window. However, just because they are mimicking each other, it does not mean that these two agents are sharing it. It may appear like that, but there is no direct sharing. If at all something needs to be shared, what happens is this agent orchestrator will decide what to be fed into the context window of both agent 1 and agent 2 apart from system prompt. So if agent 1 has bunch of results which are given stored back into cloud into the orchestrator's memory, and then orchestrator decides that actually that needs to be part of agent 2's context also, then orchestrator can share it to agent 2. So I'll just show you one figure which you should remember, this one. So these agents directly do not communicate via a shared memory, but rather an orchestrator. In this case, you can imagine orchestrator to be Cloud Code itself, agent A and agent B to be sub-agents spun by the Cloud Code. And Cloud Code should decide what files or what database is shared between agent A and agent B. They don't directly do it. So just please understand this. Now, coming back to why do we need sub-agents? The need for sub-agent is very clear. You have different tasks. So if you are working on a research, you could have an agent that is whose sole purpose is executing some code, Python or JavaScript or some type of code, which may consume a large number of tokens. But this code agent need not, let's say, review the results of the code which it wrote. Maybe a code agent can write the code, a testing agent can execute the code and test it for various use cases. A review agent can review the results and the code, and then this review agent can, its only purpose will be, it will be provided a code, it will be provided the test case results, and then the review agent has to provide a detailed summary which consumes maybe 2000 tokens. So orchestrator agent will also have same context window size, 200k tokens, but it will not consume 200k tokens. It will consume only 10k tokens. Then it will delegate a task to this research agent. The research agent will consume maybe 40k tokens. This 40k tokens plus 60k plus 30k. So then 100k plus 130k plus 155k, 165k. So roughly 165k tokens are consumed, but they are not consumed within the individual orchestrator agents API call. They are consumed overall. Now this 160k tokens, 165k tokens could have been consumed within one single agent. Okay, but then the problem that would have happened is if the same agent is looking at every single thing, there is heavy context rot. Here that is not there because this 10k is now part of 200k. This 60k, this 40k is now part of another 200k. There is no chance of context rot. Code agent another 60k as part of another 200k. And the LLM does not penalize you for making new context windows. LLM only care about how many tokens are consumed through its input and output. So it's always better to consume these tokens in a modular way by making multiple API calls if that is what your application demands. So these delegates are basically sub-agents. And if you really notice what the cloud code is often echoing, it provides an echo, right? As it is performing some operations. Especially in this auto research, I have seen many times it is spinning its own sub-agents. It will say 4 parallel tasks are running right now, if it is working on 4 different figures or something. And then it will say 4 tasks are running. I will give a summary once the task is done, when all 4 agents are done executing the task. So, but the total token consumption is again not very significantly high. So this I have noticed, I have already mentioned. Then what the orchestrator decides, this I will show you in a folder structure rather than in the text format. Okay, so let's see this folder structure when there are sub agents. Claude.md, all the agents ideally will have access to. Not that it will not pass the entire Claude.md into the context. It will pass whatever sections of Claude.md from using RAG or using keyword matching. Then what's the difference between this agents.md and this agents.md and this agents.md? What's the difference between these three? First, let's talk about this one. What is this agents.md? What could this be called as? Can you compare cloud.md and this agents.md? They are different. This agents.md is present in the root of your directory. Your root directory is my project. This agents.md is present in that. Now, maybe the purpose of this agents.md is to help your cloud code decide when you need to spawn new sub-agents. Now, let's say there is a sub-agent whose only purpose is to build the website. Now, this agents.md, which is one level below in hierarchy, will decide that, okay, I am an agent who's supposed to manage this entire website development task, for which there are front-end tasks and back-end tasks. Then this agent will decide, okay, I need to now create front-end tasks. So this front-end folder is there, inside which there is another agents.md. Now, this agents.md is the lowest level in hierarchy, meaning it has only instructions related to maybe the front-end schema or whatever, the components inside the front-end. So now the question is, let's say for whatever accidental reason, you had given some front-end related information over here. You say, I prefer a modern front-end. You mentioned here, okay? You should not mention, but let's say you ended up mentioning. But here you give some other instruction. Here you say the front end should look like monospaced, some sort of legacy style should be followed or something like that. What will be followed? Will this be followed or will this be followed? Will the root level agents.md's instruction be followed, or will the sub agents instruction will be followed? So whenever there is a conflicting instruction, always the instruction provided by the child is used. The reason is simple. The child has more proximity towards the task that is being implemented at the moment. So if front-end is being developed at the moment, this agents.md is more close to the front-end related task, whereas the agents.md on the root level of your working directory is not a front-end specific agent. So it may have mentioned a few things, but it would not have been specific enough, or it would not have been deep enough into one particular task. However, does it mean that the root level agents.md is replaced by the child level agents.md? Is some sort of replacement happening? If not replacement, what may happen? This we had discussed 2 lectures before. If it is not replacement, what is happening? What is happening, you can sort of imagine to be some sort of concatenation. Conflicts are replaced, but otherwise, the system prompts which are there in cloud.md are concatenated with sub-agent level instructions. And that whole thing is passed into the context window of the particular front-end agent. So here, effectively, 4 agents will be there. 1 agent at the root level, 1 agent at the web development level, 1 agent at the test level, Then under the web development, there will be two more sub agents, one at the front end level and one at the back end level. This is how the folder structure will look like. So each of these agents will make its own API calls. Now, the frequency with which the agents may make API call might differ. So in most of the implementation steps, whichever agent is implementing that particular task, so if front end is being built at the moment, the frequency of API call of this child level agent will be higher compared to frequency of API call made by the root level agent. So you're saying that if we are placing the code for the agent, they will find agents.md at these respective levels. Exactly. In Claude Code, however, you don't necessarily have to define this. The reason why I'm showing this to you is so that in case somebody is not planning to use Claude Code for whatever reason, let's say your company is not allowing to use Claude Code, but you want to construct agentic framework, because agents.md is universal. All LLMs understand what agents.md is. Claude.md is, by the way, not universal. That you will have to explicitly define for the LLM unless you are using Anthropic's models. But agents.md is a universal framework. So if you are defining it like this, then it knows that, okay, there are four sub agents, four agents here, out of which two are child agents, one is a root agent, etc. What is the replacement for Claude.md in Codex? I forgot the name. Codex I have been not used in the last many months. But however, if you refer to lecture number, I think 1 or 2, I had shown a table where you show the equivalent version of Claude.md is shown for Codex. But at the end of the day, even if you are having the folder file name as Claude.md, it is not an issue. If you explicitly mention to the agent that my system prompt level instructions are primarily mentioned in Claude.md file, that if you explicitly mention, it will refer to it. If not, you have to use the default format. Yeah, in Copilot, it's called Copilot instructions.md. In many agents, there is a file called soul.md, S-O-U-L. So this is how it works. So if root agents.md is there, and in that, if there is one instruction, this will be taken. So use TypeScript, strict mode. Then inside of src folder, which is for web development, if there is an instruction like follow the coding standards in style.md, that will be taken. Then if there is a front-end specific agent inside the front-end folder, and if it mentions React, use React 19, no class components, it will be mentioned. And within the front-end, let's say you are building components like cards or modals or something, it will have its own sub-agent, and that sub-agent may have another instruction. Now, the context which this sub-agent will use will include this, plus this, plus this, plus this, provided there are no conflicts. There are no conflicting instructions. So what it may look like, the context may look like something like this. It will have all these four instructions embedded in the context. In the context of which agent? In the context of this child of child, or rather, yeah, sort of like child of child of child, because there are four levels of hierarchy here. So this is root, this is the coding agent, this is the front-end agent, and this is the component level agent. So this component level agent will have all these four instructions inside its context. Now, there is one question you may naturally have. I think one person had already asked this in 2 lectures back. What's the primary difference between Claude.md and agents.md? Claude.md is the primary document which you will refer to for your system prompt. And this parts of Claude.md will always be used irrespective of what API call you are making within that project, whether it's a sub-agent level API call, whether it's a root agent level API call, or whether it's not even a orchestrator API call. At all levels, system prompt, parts of Claude.md, which are part of system prompt, will be used. Agents.md at the root level is used by the agent orchestrator, meaning there are tasks which are outside of the agent orchestrator's job. Maybe the Claude.md, the Claude code has to utilize the agent orchestrator for making sure that the front-end agent, back-end agent, sub-agents, all of them are performing its task. But there may be other tasks which are outside of that, maybe to make sure that the overall folder structure is correct, maybe to make sure that the phases that are being implemented, which may include tasks which are not just web development tasks. Maybe there are other tasks for summarization or whatnot. For that, Claude.md will be always referred to. So agents.md, please note, the orchestrator will be primarily using the agent. And under the orchestrator, there will be sub-agents. Under the sub-agents, there will be even lower level hierarchy agents. And all of them will refer to agents.md. And all of them will naturally will also get access to parts of Claude.md or entire Claude.md depending on the context. Why do I keep saying parts of Claude.md? Because sometimes Claude.md can be a huge file and you are not passing the entire file into the context. That will bloat the context. So you are using keyword matching or RAG. You will fetch only required parts from the Claude.md. Now I want to show you a few things, but before that, let me take you through some exercise and then we will come back to this. So I'll share a link with you. Just open this. Just a second. Okay, I just shared the link. I just want to make sure it's not shared in the waiting room. It's shared in the main. Yeah, it's shared in the main room only. Just open this and put your OpenAI or Gemini API key. Then, yeah, collab link also let me share in a moment. So collab is very long, by the way. So you will end up spending at least 30 minutes on collab. So I will share the collab and please use your API key from the environment. But for the exercise purpose today, I will be going through the interactive website. Yeah, so if we give a prompt saying build this particular component level feature, then automatically Orchestrator will know which sub-agent to trigger. Because Orchestrator, the role of the Orchestrator is never to run the code or build things directly. It is to make sure that the people who are supposed to build is building. So I'll give you one more example of my recent workflow, which I have started. So for those of you who have not used Cloud Code or any agentic coding framework, know that often the execution will stop unless you very strongly explicitly suggest otherwise, and then it will ask you for your opinion. And sometimes you want to make sure that it's not blindly executing the task all the way. You want to give your opinion, you want to give your review comments and stuff like that. So one of the better workflows that I have recently tried and it's working very nicely is on top of Cloud Code, use OpenClaw. So OpenClaw is like a very nice assistant. So I will tell my OpenClaw to use a very cheap language model like Gemini 2.5 Flash or something like that. Oh, by the way, OpenClaw was so expensive. I tried it with 3.1 preview. It was like crazy level expense. Like for 10 minutes of my OpenClaw usage, I ended up, the bill ended up being like $7, $8 or something. It was like crazy. But if you use a cheaper model, Gemini, I mean, any model, by the way. So I switched down to cheaper model in Gemini. The expense was 100th or 150th, something like that. Then I will tell my OpenClaw personal agent as my assistant to take care of Cloud Code. So I told him OpenClaw Gemini should never be used for running any sort of experiment. So OpenClaw's only purpose is to be an orchestrator. Orchestrator for whom? Orchestrator so that it ensures that Cloud Code is building the project and Cloud Code is actually doing what it is supposed to do. So whatever output you have, make sure that OpenClaw checks the output Cloud Code produced, and if it's going in the wrong direction, course correct it. So there is a question, yes, is it safe to use OpenClaw? So what I did is, for my safety, I did not install it on my personal computer. I installed it on my EC2 instance. On EC2, there is no personal data, nothing. The only thing which OpenClaw is probably getting exposure to is my API key. But API key, I have pretty good control over. So there is no issue. Plus, I have not connected OpenClaw to any of my like calendar or Gmail or Slack or anything. I only connected it to my Telegram. And Telegram, I have never ever used to text anyone, like in the sense like I don't use it at all. So now I'm using Telegram as just a tool for communicating to OpenClaw. So on my phone right now, if I switch on Telegram, I can just text OpenClaw as if I'm texting, my personal assistant. Then OpenClaw will plan things accordingly, and it will ask Claude Code to execute the task. So my Gemini API will not experience a lot of cost accumulation, but rather Claude, which anyway I have a pro plan, there the price will accumulate. But yeah, please be be very careful with OpenClaw, especially with respect to price. Price is it's so expensive, especially if you are not careful with which model you use. You should see the number of tokens it accumulates. It's like for each conversation, after like 10 seconds worth of conversation, you will see that the number of tokens have bloated up. So something is wrong with OpenClaw. Maybe Cloud Code is not that terrible, but OpenClaw with respect to token consumption is so bad. At least from my experience, I don't know if it is universally true. So yeah, but that is a good workflow. That way, OpenClaw acts as if there is any issue, like let's say your session limit ran out on Cloud Code. How do you know? Cloud Code cannot tell you once once the limit of token usage has ran out, it simply stops. But if OpenClaw is kind of supervising that work, it can automatically switch the account. It can take care of that. So, and it can notify me through Telegram if there is any issue in the execution. So I find that kind of workflow to be very fascinating, because everything is running on my EC2 instance. I can switch off my laptop and go home. And if any issue is there, I'll be notified on my phone on Telegram, and I can fix the issue. I can ask it to take the next step. Did you face any breaking point with OpenClaw, like context rot or forgotten memories? The thing is, OpenClaw's context is anyway very short. It's never executing anything. It's only orchestrating Claude Code's execution. So all the context that is loaded is into the Opus 4.6 context. Opus 4.6 context is anyway not managed by OpenClaw directly. It is managed by Claude Code. OpenClaw is only affecting the context that is there in my Gemini API. But Gemini's context is not that precious to me. I just need it so that orchestration can happen very nicely. Plus, if any issues happen, it can relay that information to me, and I can take some measures in a timely manner. Even if I don't have my laptop with me, I can do it. But the context rot, if at all it happens in OpenClaw, in Gemini, it's not so important to me, because first of all, I don't think it will happen, because the Gemini context window is big enough, and OpenClaw, if I'm using such that I don't pass any heavy tasks to it, I haven't noticed any issue in task breaking or anything like that. Yeah. So in my case, OpenClaw's work is very lightweight. It simply ensures that Cloud Code is keeping on working. It's never stopping or terminating, or if it's not detracking from its original task. Anyways, let's come back to this. So here I will show you a few examples based on LLM summarization, tool result clearing, priority trimming, and hierarchical compression. So let me show you first full transcript and what the situation is. The kind of hypothetical scenario is there is a ByteBridge company. That company is like a food delivery company, and there is some sort of rush on a particular day. There is a dinner rush where there are a lot of customers who are not receiving orders on time, etc. And we need to check the logs, check what has happened. And there is a ByteBridge API, ByteBridge AI chatbot also. So now if you look at the context, there are a lot of conversations that have happened, and there are a lot of tool results. So if I scroll down here, can you tell me which one resembles tool result? So order dashboard, this looks like a tool result, right? And as we discussed last time, tools, the way it looks like is the noun plus verb, or here maybe it should be a slightly different way. Order dashboard fetching or something like that should have been a better name, but whatever, does not matter. So this is one example of a structured tool result. Here is another one, driver analytics, the delivery person who is delivering. These are the analytics of that. Config audit, this is also the log of a particular tool result. Then this ByteBridge AI is basically the tokens consumed in the observation process or reasoning process of the AI model. Then these are user instructions, or operations manager Priya is sort of giving some sort of instruction. So in the full token that consume the context, it's like 1.9K tokens. And let's say for this time being, the token size, window size is 1.9K. Now, in LLM summarization, what we want to see is how many of key facts that are there in this is retained. So if there are 20 facts in this thing, in this whole context window, how much are retained when we do LLM summarization, and how much compression it results, right? So apply LLM summarization. So here an actual API call is being made to OpenAI. I gave OpenAI API key. And then OpenAI will, the GPT-4 or Mini, I think that's the model that I'm using, that will summarize. And let's look at the auto compaction result. So auto compaction result looks sort of like this. Sort of like this. And look at what has happened to the tool results especially. So one of the tool results was ByteBridge AI order dashboard. Do you see much about order dashboard here? There is not much about order dashboard at all, because those tool results are extremely compacted into natural language format. And from 1907 tokens, you went down to 257 tokens. And you can see that most of the parts here, ByteBridge AI is its own communications, or the summary of when the crisis began, which are present in these timestamps probably. All of those things are very nicely captured in this natural language, unstructured compaction, which can be later passed into the next API call. And what I have done here is I have asked the LLM also to separately capture the key 20 facts from this original document. So this original document is 1900 tokens long. From that, it has identified 20 facts, which ideally should be captured even after compaction. And then look at this, 18 facts are retained, 2 facts are not retained. So sort of like instruction retained ratio, IRR, is 18 out of 20, which is roughly 90%. But the compression is very, very effective. You went down from 1900 tokens to 257 tokens. Now, let me ask you a question. If I apply tool result clearing, what parts of this initial context do you think will be affected? Like, will order dashboard be affected? So order dashboard will definitely be affected. It's part of the tool result. Will, do you think this, let's say, operations manager Priya's conversation, do you think that will be affected by default? It will not be affected because it's not a tool result. So I will show you after implementing tool result, how the result looks before and after, and how many facts are retained. So tool result in this particular case has not resulted in significant compaction. Only roughly 550 tokens have been reduced. But that's also because out of my entire context right now, tool results are not overwhelmingly high. Tool results are consuming some number of tokens. And if you look at what has happened to tool results, so order dashboard, this tool result was roughly 200 to 300 tokens. And now look at it. It's roughly maybe 2 sentences, with each sentences having maybe 10 words. So it has been compressed to like 30, 40, maybe 50 tokens, right? So this order dashboard was very big, and that has been compressed so much. Similarly, there was one more section where there was another tool result, delivery metrics. See, this is again structured data coming from the result of tool results. And delivery metrics, again, you can see that will be compacted to just 2 or 3 sentences. But if you look at the other sections of the context, so what this operations manager Priya has mentioned, there is absolutely no change in this section because this is not a tool result. The ByteBridge AI's own communication, nothing has happened to it. So this is the advantage of tool result. And look at the facts that are retained. 100% of the facts are retained, 20 out of 20 facts. However, compression is only 1347. Compression happened to is 1347 tokens. So if you were to kind of score the technique based on retention rate versus score for compression, LLM scores better in compression because it has compressed to 200 tokens, 250 tokens, but the information retention rate is like a bit poor in LLM summarization. That's also because we are aggressively summarizing. We can also ask LLM to, pay more attention to key facts that we could have done. So can we combine tool results and LLM summaries? Yes, absolutely. So what you can do is, yeah, very good question. I really like the question. So that is exactly what we are seeing in the 80% threshold. So what is initially done is, initially do not summarize using LLM. Initially clear the tool results. Why is that? because tool results clearing is very non-risky. Because if you really want a tool result again, you can just call the tool again. Once the tool result is cleared, and let's say you did not compress good enough. So right now compression has happened only 1347 tokens. Then the remaining items you compress using an LLM, so that you are not immediately applying LLM compression. You see what happens to your compression after tool results are cleared. Maybe most of the facts will be still retained, but if compression is not good enough, only then apply an LLM summarization. Then priority trimming. So here, if you apply priority trimming, these are the 4 priority levels: P0, P1, P2, P3. So P3 is the routine conversation. You can see one P3 over here. So operation manager Priya has mentioned something like, great summary. I'll create tickets for all follow-up items, marking this incident as resolved. The driver distance spike was the key signal. So something which this manager has mentioned. It's a routine conversation which need not be retained. So this is entirely removed. And as a result, the number of tokens have reduced. And let's see what else has been removed. I don't think anything else is removed yet. How about tools? No, tool is kept. All of these are entirely kept. One thing I'm not so sure is 1686 tokens. So around 220-ish tokens have been removed. But was this Priya's conversation actually 220-ish tokens? I can see this to be 58 tokens, but it should ideally be 200 tokens. So yeah, there is another one here, 48 tokens. Then there is another one here, maybe 30 tokens. Yeah. So if you add up all the conversations this operations manager has made, yes, probably they will add up to roughly 200. So you can see that what the LLM has figured that is a very low impact or low risky thing to remove is all the conversations made by Priya, this operations manager. In fact, not all the conversations, some are kept. And then the total result is around 220 tokens being removed. Is the decision based on some kind of rule? It's based on rule. It's not based on semantics. Here it is purely rules. Tools have the lowest priority. Then even lower priority is routine items. Then if a task is being implemented at the moment, that will be at P1, and P0 will be system prompt. So here only P2 is removed, P1 is not removed. I think these tool results will come in P1. So yeah, so if more level of compaction is needed, next what will be removed is these tool results from P1. They will be removed. They will be trimmed aggressively. But here again, compression is very minimal. And because of that reason, it's not very surprising to see there is 100% fact or information retaining. This is not very surprising. Oh, I think I wanted to show you one more thing. Hierarchical compression, just to show you how the semantic based compression works. So this is hierarchical compression. And here what happens is, if something is in P0, the P0 will be found to be the 100% of whatever is there in P0 will be retained. If something is there in routine, P3, it's 0% retained. If something is in P2, 10% will be retained. And if something is 50%, if something is in P1, 50% is retained. So P1 is the tool results. So tool result will be summarized ideally. So here, this order dashboard, this is part of a tool result and it's compressed. Yeah, I will share the prompt that are passed into LLM. Yeah, I'll share with you guys. Right now, it is masked behind the this website front end. You mentioned it's earlier. Earlier, it's not necessary to use top model for compression. In Cloud Code, do you have to keep toggling the models for building any compression? Is this what you do typically? I personally have never explicitly mentioned the model to toggle between, explicitly mentioned the Cloud Code to toggle between the models. So I don't know internally what Cloud Code does, whether it switched to Haiku or Cloud Sonnet or something like that instead of Opus 4.6, because Opus 4.6 is the most expensive model, right, by far. So in the compaction, I am not 100% sure whether there is a switching of the model happening internally or not. Explicitly, I have never mentioned it, but I have to check it. I'll check and let you know. So this is how hierarchical compression runs. Again, P0 to P4, P3 levels are defined, but in each level, there is no complete trimming. Complete trimming may happen in P3, but if P3 is not removing everything entirely, P2 is not entirely trimmed away. P2 is kept 10%. 10% of P2 is kept. Yes, prompt should be there in Google Colab. Yes, for sure. I just need to verify whether the prompts are exactly same in the website or Google Colab. That I have to check once, because I have made a few changes to the website recently. Then let's go into phase 2 just to see how all of this will appear visually. So here what we need to do is define a hard cutoff for when compaction is triggered and define a hard cutoff where the trimming is triggered. So can you tell me why do you need these two cutoffs? One is at 80% and one is at 95%. So if at 80% of the context window size, if compaction is already getting triggered, why do you need another emergency trimming of at 95%? What's the logic behind this? So the question is, why do you need two such thresholds at 80% and at 95%? So it can so happen that, let's say, first of all, after, let's say you are at the limit of 64%. And let's say you have 100,000 tokens in your token window. Now, 64,000 tokens are consumed. If the output of the LLM is another 30K tokens, directly your number of tokens will jump from, or let's say the output is not 30K, let's say the output is 20K. Let me just draw it here. So let's say this is 100K and you were here, for example, let's say at 50K. Now you call the LLM and LLM's output is 20K. Then LLM's output will fill this much more, sort of. Then you exceeded 80%, right? So maybe this will be at 85 or 90%, something like that. Then you will call compaction. And what is the first thing which you will compact? The first thing you will compact is probably tool results. And let's say your tool results are not that heavy. Your tool results are only occupying this much, right? So even after compaction, and even after compacting or even removing the tool results, you still are above 80%. Then what will you do? You will continue calling the LLM. And let's say in the next LLM call, your context window ended up filling up this much, where now this is 95%. So now what will happen is, this is an emergency situation because now you have barely any more tokens available to fill, which means your output LLM produces cannot fit in your context window. So now there is an aggressive trimming that happens where tool results are trimmed and P3 levels are trimmed, or even direct after tool results are trimmed, direct LLM summarization happens. And when direct LLM summarization happens, this thing will jump from 95 to roughly even 20 again. So I'll just let me erase all of this and let me show you visually how it will look like. This continuous compaction will look like. So just click this start simulation. So here you can see system prompt, user instructions, assistant instruction, which are maybe the sub agents, and then the tool, which are the results of tool call. And it keeps filling. The moment you reach, look at which part is getting trimmed the most aggressively. This purple part is getting trimmed or compacted the most aggressively, which are tool results. Tool results are compacted to very few tokens. Let me just play this once more by decreasing this compact at. So threshold I'm keeping to be 60%, and emergency, let's keep it at 95% only. Now, in first step, system prompt. Second step, user instructions. Third step, the assistant, maybe coding assistant, tool call. So tool call, there are results, okay? And then you get the results back. Then again, the assistant does something. Maybe it calls the tool. Then again, you get tool results. Then again, the tool results are passed to the assistant. Assistant consumes some token. Again, tool results. Maybe you inject a bit of user prompt here. So Priya has injected something. Then again, assistant works. tool call or maybe user instruction, then again tool call, again assistant, again tool call. So the moment tool call is increased beyond a certain point, not tool call, the entire context is increased beyond a certain point, compaction is triggered. And look at which part got triggered the most aggressively. This purple thing was compacted the most. Neither assistant nor user nor system prompt. System prompt is very rarely touched. See? So tool results are almost aggressively triggered. And we can also see one more thing. Let me put this at maybe 90% and emergency at 85%. Now what will happen according to you? There should be like a proper trimming that is happening. Let's see what all things are trimmed. So here actually one thing that may have happened in the logic is I don't see the entire tool result being removed. So in the backend logic, I have to make sure that entire tool result is removed. Right now, when you look at the difference between compact and emergency, it doesn't look like emergency is any different from compact. Emergency seems like it's also compacting the tool result. But ideally, emergency is supposed to, without any mercy, remove the tool results and remove anything else at P3 levels, P3, P2 levels. But right now, that does not seem to be happening. That's okay. In most of your usage cases, you will not come across this situation. You will most likely encounter the threshold where tool results are threshold 80% where tool results are bloating your context window. And the moment tool results are compacted along with the rest of the things, your context window will go back to maybe 36% or something like that. You might notice also in Cloud Code often when a new task is being implemented, Cloud Code will explicitly ask you, clear the context window and start execution. Sometimes it will ask you compact the context window and start execution. It itself will give you. And then in the recommended section, it will say recommended is clear the context window and start execution. Yeah, so P0, P1, P2. In this case, system prompt should be in P0 because that has the highest level of priority. P2 will be, P3 will be tool results because that is at the lowest level of hierarchy. Tool results which you already have available. You don't have to keep storing in context because in case if you ever need the tool result in the future, you can get it into the context window by calling the tool again. Then the assistants interaction and users interaction may or may not fall in P2 or P3 or P1 depending on the semantics, because sometimes the user instruction at that moment is very important. You should not be trimming it. Sometimes the latest interaction that assistant had is again important. So if I reset this back such that this is something like this and emergency is over here, and if you now keep looking at what happens to these colors, you will see that assistant's length is sometimes getting trimmed, but only after tool is getting trimmed. So tool has the lowest priority. So P0 is red color system. Purple color is definitely P3. The blue and green depends on what the context is right now. So there you will have to use some sort of semantics. And here, just look at this. The final tokens, final capacity of context window that has reached after this is 54%, meaning at the end of all of this, out of 2000 tokens, you are still at only 1087 tokens. On the other hand, if this trimming did not happen, by the time 28 messages are there between tool, system prompt, assistant, and user, you will definitely cross much above 2000. And here we are not really looking at how many key facts have been retained or anything. That we will not look at this in this exercise. One thing we should also look at is this multi-agent framework. So multi-agent framework, what we decided was for the same task, if there are different types of subtasks, multiple agents will be defined. So here this diff kind of file is showing you the difference between before creating a pull request and after creating a pull request. So plus is the new lines that are added, minus will be, plus is the new line added, minus is the new line or old line which is removed, just like when you make a pull request on GitHub. And here in this code file, there are three different things to take care of. And for that, three different agents can be utilized. One is the style of the code. So this will review the code style. What are the naming conventions for variables? Whether anything related to documentation needs to be looked at, and project coding standards. Security agent will scan for vulnerabilities in the actual code. Then performance agents will look at perhaps the execution speed of the code. So these three agents are there, and it has its own budget. And you can look at how the agent contract looks like. Okay, this is one topic which I did not discuss. This is where I exactly stopped. So coming to something like when you have two different agents, let's say there is one agent working on front end, another agent working on back end. There has to be some sort of commonality between between what the agents may produce. So if the agent working on backend is producing an output which is in a different format from what the front end agent is producing, there will be compatibility issues, right? So here there is a get request, get API slash v1 slash user, here slash API slash users, and so on. So front end agent may have a default way of behaving because front end calls and front end schema is usually different from backend. So they may have a default behavior. But unless you explicitly say that the output you guys produce should be adhering to certain format or certain structured format, you will not be able to integrate them. So there is an idea called contract first pattern. So contract simply means the orchestrator will define a schema which both of the agents should sort of follow. So if there is an API called related schema, API specifications.json file will be defined by the orchestrator. By the way, Claude Code does this automatically. You don't have to say explicitly that when you are spinning subagents, define sort of like the contract that these subagents should follow. You don't have to explicitly say that. It is implicit. However, if you are building your own coding agent outside of Codex or outside of Claude Code, this is something which you will have to define explicitly. You will have to tell the orchestrator that make sure that sub agents are following or building based on a certain predefined contract, so that when those two things are integrated, they will actually work. An example of this is I had talked to you about building my news aggregator agent, or even building a central brain for Visuara. So the central brain for Visuara is an agent orchestrator. And then there are many sub agents that we are building. Now, one schema that we are now forcing these agents to follow is a schema that will allow us to have a two-way MCP. So two-way MCP as in, it's not like one part can be client and one part can be server. It can switch the roles. So both ways it can act. And for this to happen, we had to explicitly mention it in the system prompt agents.md that the output that is produced by this should follow the MCP format, which are mentioned in the guidelines of my central orchestrating agents. Output of my email agent should follow the format mentioned by this agent. And same thing, when Visuara is acting as the client and this agent is acting as the server, there is a specific way of communication from this client to the server. So this was again an explicit instruction, not implicit. The reason why this had to be explicit is because we only defined the MCP ourselves, which means there is a certain structure that these sub-agents should follow. So that is what this section is about. Let me go back to the this section. So the style agent has its own input schema and output schema. Security agent contract defines its input schema and output schema, and so on. And when you run the multi-agent, this is just a simulation, by the way. When the multi-agent schema is run, the orchestrator will decide when to call the style agent, when to call security agent, when to call performance agent. Each agent, the token consumption is completely different, needless to say. All right. So this is just to visually show you how it will work. I want to show you a couple more things before we move on to the agents.md file structure. Okay, to this I will come last. I want to show you one more thing. Yeah. So the way in which sub-agents will communicate. So let's discuss a little bit about that. So there is a concept called fan in and fan out. So fan in, fan out is nothing but how does a fan work? If a fan is rotating, if something is released from the fan, things will go outside, right? I mean, it'll be in straight line, but it'll go outside in this way, right? So fan out is the idea where the central orchestrator will spin isolated agents, which have, and these agents have nothing to do with each other. Okay. And they barely share any, apart from system prompts, they don't share any base documents or anything like that. So this idea is in general called as fan out. But however, sometimes orchestrator can say, apart from system prompts, there are a few more things which I want to share with the agents. So a good way to visualize that is in this way. So this is the orchestrator. This is sub-agent number 1, sub-agent number 2, and sub-agent number 3. By default, the system prompt is passed directly to all the 3 sub-agents. So this is system prompt to agent number 1, sub-agent number 1. This is system prompt to sub-agent number 2. This is system prompt to sub-agent number 3. Anything else, let's say if there is a config audit which needs to be shared between all the agents, or if some other file needs to be shared across all the 3 agents, that is decided by the context curator. So now config audit may be, so these 2 green color lines show that config audit is shared between root cause analyst and remediation planner. So this file agent, the orchestrator has decided that these 2 files are sort of like base documents, shared base documents for sub-agent 1 and 3. And this is system prompt. The remaining file will completely depend on, the sharing of remaining files will completely depend on what the orchestrator seems fit to each sub-agent based on the sub-agent's task or sub-agent's talent, what it is supposed to do. So maybe architecture diagram, orchestrator will decide that it needs to be only shared with impact assessor. So impact assessor will now get access to system prompt. It may get access to metrics dashboard or error logs, and it will also get access to architecture diagram. So this is how the custom context is set up for each of the sub-agents separately. Now, if I go back, this full isolation is the idea where every single sub-agent is having completely different inputs into the context. So there will be some base instructions. This base instruction can be in the form of agents.md. Here we are not mentioning the cloud.md file, that is implicit. I don't have to mention it. But let's say there are 3 agents, one for triage, one for root cause analysis, one for recovery, for whatever event that has happened for this food delivery company. Now, the things which will go into the context of triage is its own base, meaning its own agents.md file, which is not shared. So please don't get confused. This is base with 200 tokens. This is base with 200 tokens, but this is different from this. This is the agents.md file for the triage agent. This is the agents.md file for root cause, and this is agents.md for recovery. Then there will be other documents, which are other documents or other tokens, which are passed into the context, which are relevant to those agents. And these are fully isolated agents. And in this case, for example, okay, let me show you 3 agents, then I'll ask you the question. Then there is another concept called shared base. So shared base, visually, you can see like this. So agent 4, 5, and 6, in this case, this green color shows that there is a common base that is shared between these 3 agents, meaning common documents, which the orchestrator decided to give. But apart from that, there are completely different agent level knowledge which is passed into the context. So security agent will just get information, will get, in addition to the shared base, will get information regarding security. Performance agent will get information regarding performance, and so does style. So this is the idea of shared base plus whatever is isolated between the agents. The last one is sequential subagents, where the input that goes into agent number B will depend also on the output coming from agent A. So this is sequential because unless agent A is fully implemented, agent B cannot work. A good example of this is, for example, let's say we are working on a research agent, and the implementation can happen only after literature review is done. Then literature review agent A may come only before agent B, and agent B can work only after literature review and gap identification is done. It cannot work before. So this is sequential pipeline. Now let's go back here and just look at shared base context, how it look like. So here, this is the shared context between the three: triage agent, root cause agent, and recovery. There is a common shared base. Then apart from that, there is agent specific instructions, and this will consume certain set of tokens. In sequential pipeline, the triage agent's output is summarized and passed into root cause. So in root cause, you will see there is the triage agent's findings. Then that findings plus findings from the root cause agent will be passed into the recovery agent. So recovery agent now has in the context summary from triage agent plus summary from whatever root cause agent has found. So recovery agent cannot function without these two things that are passed into the context. That's the reason why it's called sequential. How the pattern defined, how is it defined sequential and parallel? It is implicitly defined by the agent orchestrator itself. To give you a simple example, when you are, think about it, if you are building a website dashboard, you cannot run a components agent, or you cannot run an agents.md corresponding to the components before you, let's say, fix the overall architecture of your website. So if the folder structure looks something like this, md, and then the root level agents.md, and here you have the coding agent. So this is another agents.md. Then here you have front end, and within the front end you have components. And this front end agent might have said a few things in the component. In the component hierarchy, maybe there is a navigation bar. Then inside navigation bar, let's say there are buttons. Okay. Now, if there are agents for creating buttons, agents for creating navbar, agents for creating separate components, etc., the agents.md corresponding to this button section cannot run before agents.md corresponding to navbar has executed. Because agents.md corresponding to navbar says that, hey, we are currently building navbar in which 3 buttons are required: dashboard, login, logout, something else, home button. Only then the agents.md corresponding to this will execute. So here, the hierarchy of this folder structure is kind of implicitly giving the agents.md in the root an idea which agents will be executed at what time. But sometimes some things can be in parallel, because when you are building the navbar, you could also build your whole hero section. You could also build something else in your page. And while you are building the front end, you could also build some parts of the back end, right? So if you were to manually define in sequence which agent comes first and which agent comes next, I think it will cause more confusion to the model than bringing some sort of clarity. What is better is create a very nice folder structure in which the agents.md itself implicitly defines what the order in which the sub-agents are executed. If we have agents.md on top, what is the need for cloud.md? So cloud.md, so agents.md is only looking at maybe coding task and testing tasks. So let's say there are 2 tasks, coding and testing. But let's say at the project level, you have many other things to do apart from building website. Maybe you have to plan project roadmap, PRP, project roadmap planning. Maybe you have to assign tasks to your team members or something like that. Like once this is done, you have to, let's say, push something to Trello or Kanban, or you have to check the details of your project execution by the rest of your team members on GitHub. So at the central level, there are many other tasks which cloud.md can do, which let's say an orchestrator agent for coding cannot do, or orchestrator agent for coding plus testing cannot do. So agents.md is specific to what all tasks it is supposed to orchestrate. Claude.md is specific to everything that your entire project in your workspace is supposed to do. So Claude.md will be corresponding to your workspace. And then sometimes, so this agents.md, it might be confusing to you because right now I have shown you just one agents.md in the root file, right? The easiest way to remove this confusion is I can literally move this out of my root. So I'll move it here. And I will say that I don't have any agents.md at the root level. My two agents.md is one agents.md is at the coding level. Then I may have another agents.md at the maybe project roadmap planning level. And at the root level, there is no agents.md. But at the root level, I will still have claude.md. So whether you have an agents.md at root level or not, it's up to your project specification. But at the root level, you will always have a claude.md file if you are working in Claude Code. Okay, let's get back. So this is how the sequential pipeline will look like. Now just answer the simple question. There is a scenario, multi-domain restaurant onboarding. 3 specialist agents are needed to verify a new restaurant joining the platform. In this case, just read this and just tell me what type of agent would you do? Would you use full isolation, shared base context, or sequential pipeline? So there are 3 agents. They have to do few things. They are analyzing at the end of the day, it's the same restaurant. Same restaurant application data. Each agent applies domain specific expertise. So probably there has to be a shared base is what I'm thinking. Let's see. So there has to be a shared base, but there will be fan out. Fan out meaning there will be isolated context also. How about third scenario? Let's come back to second scenario after this. Parallel city expansion analysis. 3 agents each research a different aspect of potential new cities for expansion of your food delivery platform. Demand agent queries food ordering trends. Then completion agent maps this. Logistics agent delivers, evaluates the driver availability. So if it's a parallel city expansion analysis, it's a completely different city. And maybe the things that you need to do in one city and the other city are completely different, which means there is nothing to share, right? So it could be full fan out, like full isolation. Then the last thing is rush hour incident response. An active Friday rush hour crisis needs urgent resolution. First is triage incident identifies the severity of the incident. Root cause agent uses triage to find findings to pinpoint to the. So basically here itself, it says triage findings are needed for root cause agent to analyze the issue. And then the recovery agent uses both the triage results and the results from the root cause agent, which means it looks like a sequential pipeline because the output of one depends on the input of one depends on the output from the other. Then let me show you one more thing. This Windows, this part will be very interesting. So again, look at this folder structure. So this will answer some of the questions which you may have. Your workspace is ByteBridge incident. Okay, this is your project workspace in which there is Claude.md, but there is no agents.md. But inside the folder, inside this agents folder, you have an agents.md. Now this will be the orchestrator. Now inside this orchestrator, inside this agents folder, there are 3 subfolders, one for root cause analysis, one for impact assessment, one for recovery planning. It has its own agents. Now let's just run a simulation of how this looks like, which files will be passed into which agent. So orchestrator will have access to system prompt. System prompt says you are a specialist agent in ByteBridge incident response team, follow this thing, respond in JSON format and so on. Claude.md has bunch of things about the team, incident response conventions, terminology, etc. Then incident briefing document. Incident brief is this document is probably passed into this working directory directly because this ByteBridge incident is the folder to which some briefing might be there. So this incident briefing.md, you can imagine to be similar to the ideas v2.md or something which I discussed a few lectures ago, like a markdown document which kind of describes what the situation is. And Claude.md will be independent of all of this. Claude.md will take care of all the incidents broadly. Incident briefing.md will describe the specific incident that has occurred. And then there will be instructions provided to orchestrator. So orchestrator instructions are provided in the agents.md, this one, and orchestrator's delegation plan. So now this delegation plan will be a separate file, which is not shown here, but what that file will decide is what agents, what sub agents now to run. So orchestrator will decide in the first step, I need to run root cause analyst agent. So send the config audit plus driver analytics to root cause agent. Then after the root cause agent output is available, impact assessment. So for that, I need the impact assessing agent, to which I need to send the root cause summary, right? After that, have the recovery planner and then synthesize. So let me just run one step and see how the step proceeds. So the first step is root cause agent is called because in the orchestrator's delegation plan, first sub agent that is called is root cause analyst. So root cause analyst is also getting system prompt. So it's the same system prompt. It's also getting access to cloud.md, the same cloud.md. It's also getting access to incident briefing. Incident briefing is that markdown file at the root level. So this is getting accessible to root cause analyst. Apart from this, root cause analyst will have its own instruction in its own MD file, agents.md file. So it will say your role is to act as a root cause analyst, then analysis of the current incidents, and then the config audit trail and driver analytics snapshot is something which orchestrator ended up deciding to send. So orchestrator had sent config audit, send driver analysis or analytics. So these two things orchestrator decided to add into the context of root cause analyst agent, and which contributed to 150 tokens, 160 tokens. So totally 310 tokens. These 310 tokens came here because orchestrator decided to add it. This 100 tokens came because it is part of the agents.md file, this root cause analyst instruction. This 85 plus 140 plus 135 tokens came because it is part of there is a shared base plus system prompt is anyway part of all the agents. So incident briefing is sort of the shared base. It's shared between all the agents. And now when we run, now root cause analyst agent has executed. Its result are passed back as summary into the orchestrator. So now orchestrator has an additional 180 tokens. Ideally, these 180 tokens, some output tokens will be stored in the root cause analyst also. It's not being shown here. So please don't get confused because root cause analyst is calling its own API. That API will have its own results. Those results will be stored in this context window only. So the 770 should ideally increase to something. But then whatever the output is, the output can be summarized and will be stored in the orchestrator like this. Now, what is the next step? Next step is orchestrator already has a delegation plan. It has step 2 is impact assessor agent. So in the next step, orchestrator will call the impact assessor, which will get access to the same 3 files, system prompt, cloud.md and incident briefing.md. But there are now new files. This new file is the agents.md corresponding to impact assessor. This new file, root cause summary, is the result of the previous agent's execution, which is the same thing. This same 180 tokens are here. Then this order pipeline metrics and normal performance baseline was added by the orchestrator. So orchestrator had said, send root cause summary plus order metrics plus baseline into the impact assessor agent. So these two files of 130 tokens and 90 tokens came to the context of impact assessor because orchestrator had planned it. So total 870 tokens. Now impact assessor will run its step, which will produce its output. And that output is now stored as a new set of tokens in the orchestrator's context. So those new set of tokens are now 165 tokens. Now the third and last step should be orchestrator plan is called the recovery planner, to which these two things are sent along with some playbooks. So in the next step, recovery planner will get access to system prompt, cloud.md and incident briefing. Then this new file in yellow color is the recovery planner instructions in the form of agents.md. These two green color ones are the summary of the implementation of the previous two agents. And these two files, recovery metrics and customer recovery playbook, were passed by the delegation by the orchestrator when it delegated the task to recovery planner. And then finally, recovery planner's final summary will be over here. Recovery plan, immediately activate tier 2 and 3 refunds for all the affected orders, 24-hour push notification, so and so and so. And that's it. I think that's the last step. Yeah. So look at how the orchestrator, how many times it interacted. Orchestrator's context got filled after 3 interactions, 1 interaction with each agents, right? And finally, only the output that we need. I mean, the recovery plan, because this whole workspace is about when you have an incident, how do you recover from that incident? Incident could be large number of orders not getting delivered or whatever. So this is a brief overview of how it looks. And you can also see this here, how the context is getting full. So claude.md plus briefing is the 360 tokens that are part of all the or agents, orchestrator, as well as the 3 sub agents, claude.md plus briefing, claude.md plus briefing. Then this 205 tokens are contributed from agents.md of orchestrator, but then orchestrator will pass the config file plus audit. Those are the 310 tokens. This 100 tokens are in the agents.md. So this yellow color defines the agents.md file, number of tokens in the agents.md file. And these are these files, these 3, this agents.md, this agents.md, and this agents.md, 105-ish tokens each, 100, 110, and 105 tokens each. This one is the orchestrator agent, which has around 205 tokens. All right. So this is roughly how it looks. Now, what we can do is, I think there was one section which I wanted to show you. This I already, yeah. I think this will be covered anyways in the quiz part. Basically, what we need to do is there are 3 sub agents. So one sub agent will take care of order related items. One sub agent will take care of delivery related items into the items, meaning delivery related data into the context. One agent will take customer related data into the context. And each agents we have defined to have a context limit, 950 tokens, 900 tokens, and 1100 tokens. And these are apart from the system prompt and apart from the task briefing.md, which are already passed into all the 3 agents. You have these many these many 1, 2, 3, around 10 or 12 items to be passed into the sub agents. The question is, how would you decide that? So we don't have to spend time on this, but I will just show you the solution. We can spend time in the quiz part. So the solution is that you decide the context to be passed into the each agent based on what that agent's capability is. If one agent is really good at handling things related to order, pass things related to order to that agent's context. If another agent is supposed to handle things related to customer, pass only things related to that into the particular agent's context. Now let's go through a few questions that will make things a lot more first confusing and a lot more clear afterwards. Please answer your options in the chat. Some questions are actually very, very straightforward. So I'm expecting all of you to, give the correct answer. What is this information retention ratio? Fairly straightforward. What exactly is the definition of information retention ratio in context compression? Obviously, it is the ratio of what are the total number of facts existing in the document compared against the total number of facts that were preserved after compression happened, right? So ratio of key facts preserved to total key facts after compression. Fairly straightforward. What about this? Which compression is most effective for large with conversations with large embedded tool results? Fairly straightforward. There is nothing confusing here. Do you do LLM summarization or would you do tool result clearing? Probably these are the only 2 options coming to your mind, right? So the most effective one for large tool results, if tool results are definitely your biggest item which is consuming your context, tool result clearing should be the easiest one. But if tool results are equally proportional to other items in the context, maybe then you will first do tool result clearing and then do LLM summarization. So LLM summarization can result in a lot of loss of information also. A 15-turn operations debug session has 5,000 tokens. After LLM summarization, it is 400 tokens with 16 out of 20 key facts retained. What's the IRR? I mean, fairly trivial. 16 out of 20 means you multiply by 5. 16 multiplied by 10 is 160. Multiplied by 5 means it's 80. So 80% should be the IRR. Fairly straightforward. In hierarchical compression tiers, like critical 100% retention, important 50% retention, and so on. What determines which tier a message belongs to? This is one question many of you might have doubt about. So here the question is it D or C? That's the question. In hierarchical compression, do we decide the hierarchy based on some rules or based on LLM? Based on semantics. So in hierarchical compression, it should be based on semantics. But in trimming, it's based on, it's completely trimming, it's based on rules, right? But here it's based on semantics. Then why is priority trimming considered riskier than tool result clearing? What is the risk behind priority trimming? So this is a little bit confusing, right? Just think about it. I think people are typically, generally confused between B and D. Okay, first of all, let's eliminate. Priority trimming requires more compute power to execute than clearing. There is nothing like that. So A, we can eliminate for sure. Priority trimming can only done by an LLM, while tool clearing is rule-based and deterministic. Actually, priority trimming can, trimming can be done by a non-LLM, because in priority trimming, hierarchy is defined based on P0, P1, P2, P3. P1, P3 is the tool results and maybe earlier conversation history, which we can define based on rule. P2 might be things which are earlier in the later part of the conversation, like conversation that just happened recently. So we can define some rules. So here, necessary LLM is not really required. Tool result clearing uh, uh, Tool result clearing preserves reasoning context while trimming removes entire messages that may not be implicit. Tool results are always redundant, so clearing them is safe, while user messages always contain unique information. Let's go with one of them and let's see. So answer is B. Tool result clearing preserves reasoning context, but these two are very confusing, right? They pretty much almost feel like they are saying the similar thing. But tool result clearing preserves the reasoning context, while trimming removes entire message that may contain implicit dependency. Tool results are always redundant, so clearing them is safe, while user message always contain. Maybe the always word is not so true. It's not like always tool results are redundant. We can't say. And always user messages unique information also we cannot say. If this was reworded in a slightly different way, it would have been even more confusing whether B or D is correct, right? So maybe this always word is not the right thing to say. An operations transcript has 3 tool results averaging 250 tokens each. So 750 tokens. In B, it is saying, let me go back to fifth. Tool clearing preserves reasoning context, while trimming removes entire messages that may contain implicit. So basically, in tool result clearing, if you remember, LLMs can also clear tool results sometimes in the LLM summarization, but there it's not clearing the tool results, it's summarizing in 1 or 2 sentences. If it is complete tool result clearing, it is not LLM based, but in LLM based summarization, it can clear. In LLM based summarization also, tool results are cleared technically, right? Tool results are summarized into 1 or 2 sentences. But yeah, what this is saying is tool result clearing preserves reasoning context, while trimming removes entire messages that may contain implicit dependencies. So trimming means, in trimming, what may come in your P3 level can be tool results as well as your conversation history. So your conversation history, which is far from the most recent conversations, may get cleared. So it may affect the context. Conversation history or user inputs which are far away from the current user input may again get removed. That may affect the context. That is what this is saying. Okay, you have 3 tool results, each averaging 250 tokens. Then 12 conversational messages averaging 60 tokens each. So this is 12 multiplied by 60, which is what, 720, and this is 750. If you apply tool result clearing, replacing each tool result with a 30 token summary, what is the approximate compression ratio? It's fairly easy. You can So basically, tool results were originally 3 multiplied by 250, which was 750. Now tool result becomes 3 multiplied by 30, which is 90. So your tool results go from 750 to 90. So whatever that number is, that much compression is there. So about 78% of original tool result drop from 750 to 90 tokens. Let me check if first of all, yeah, this is not definitely 55%. This is 90 out of 750 is closer to 78%. Then in a 3-pass auto compaction system, why does tool result clearing happen before message summarization? This I think should be clear. We have discussed this in detail. Like, why is tool result clearing the first thing which you do in auto compaction? The reason is, as we discussed, tool results are kind of deterministic. Of course, depends on the tool, but in general, when you call the tools with a certain condition, it will always give you the same output. So tool results are sort of deterministic. It's low risk because if you ever need it again, you can simply call the tool again. So you can get maximum compression before resorting to LLM based summarization, which can be lossy. You saw that in the example which we discussed in the LLM based summarization, that was the most lossy summarization because 18 out of 20 facts were retained, 2 did not get retained. What is the recommended compact at threshold for production auto compact systems? This we have discussed fairly straightforward. You should know this. So there is compacted and there is emergency trimming, right? So compacted is typically 80%, trimming, emergency trimming at around 95%. Then what does context rot refer to? I think by now this is the only thing maybe you should be able to answer this in the sleep. It basically degradation of models, context over time and usage. Then during an auto compaction simulation, this question, auto compaction simulation, pass one fires, which is tool clearing fires, but the context is still at 88% capacity. Emergency threshold is 95%. What should happen next? First of all, is everyone clear why after tool clearing the context is still 88% capacity? Why is it not coming below 80%? Is everyone clear why? Because auto compaction triggers at 80%. If so, my question is, if it gets triggered at 80%, how come the capacity is still 88%? Wouldn't it bring it below 80% anyways? Why is this sensible? I'm just trying to recollect your memory. Why is even after auto compaction triggering, why does it stay at 88%? Simply because in the whole context, you don't know how much is the tool output. So when you clear the tool or compact the tool results, there is no guarantee that you may go from 94% to 79% or 88%. You might still stay at 88% or above 80%. So what happens? So what should happen now? Let me just check your answers. B, A, B, B. Most of you are saying B. Some of you are saying A. Okay, I'm not sure which one you're saying. What should be the next step? So nothing is between 88% compacted and emergency. So system waits for more messages. Is it that, or system retries pass one with more aggressive tool clearing? Okay, all of you are, it seems like many of you are saying A, some people are saying pass one, retry pass one. So what should happen is, there are different levels of clearing. First of all, in hierarchical clearing, first level of clearing is tools. And second level of clearing is let's say some things in P2 or some other things apart from tools in P3, which is like conversations that are very old, or user instructions, user prompts that are very, very old. Maybe you can clear that because rest of the things about user instructions are already captured in the rest of the context. So something should trigger, right? That's what ideally should happen, because if we don't do anything, we are guaranteed to reach this emergency threshold. When emergency threshold is used? Emergency threshold is used only when, imagine that your context window is right now at 79%. At 79%, there is no compaction. Okay. Now let's say your LLM produces an output, and that output is these many tokens, such that you jump directly from 79 to, let's say, 96%. At that point, auto compaction, which happens at 80%, will not get triggered. At that point, directly emergency threshold will get triggered. But anything before that, if auto compaction is not able, the pass one of tool clearing of auto compaction is not able to do anything, it will try pass two. So that is the next logical step should happen. If nothing being done is not a good thing, because then you are anyway, see, at 95% anyway, you are trimming without any care, because your context window is almost dead, so you have to trim, so there is no choice. But at 88%, you may have some choice to remove P4 and P3 only. Do not touch P2, right? So when you have more choices, you will execute that choice. So it should be firing pass 2 immediately. Pass 2 is compact at, run the compact at, but for maybe the next level of hierarchy. Okay, another one. Why is the emergency threshold, emergency at, is separate from compact? Why do we need these two things? So why do we need this? It's very aggressive. So emergency threshold compaction, trimming is very aggressive. It will literally remove entire portions, whereas compaction can be made using LLM. So if LLM compacts something from tool results, it can still compact whatever is remaining. But emergency trimming may completely remove tool results, so nothing will be available. Plus, it will remove anything else needed. In multi-agent code review system, why is contract first design critical? First of all, remember what is contract first. Why is it needed? So contract simply means defining a common schema for all the agents so that the results can be merged or combined together to build one single product. So if you have sub agent for front end, sub agent for back end, whatever they produce should be compatible with each other. Then what is the main advantage of fan out or fan in? So fan in simply means you have multiple sub agents, you compile their results into one single orchestrator. So why is this preferred over a single agent approach for code review? So I think this is a bit confusing, right? Okay, let's first of all look at what may not be the answer. Fan out is always faster because agent run in parallel. Uh, Not sure. It need not be fast. It depends on the particular project. So it's probably not A, right? Fan out uses fewer total tokens because the difference is split into smaller pieces. There is no guarantee of that. It may even end up using a slightly more tokens. Why? Because the system prompt is passed to all the individual agents. So maybe the total number of tokens consumed may be a bit higher. What about a D? Multiple agents can use different LLM providers simultaneously, reducing vendor lock-in. I mean, for sure, that is possible. For sure, you could do that, but that's not primarily the reason why we use fan out. The reason is um, you have specialist agents. Some agent is good at code review, some agent is good at security issues, some agent is good at perhaps testing. So you need the specialist to invoke their special skills. In a multi-agent system, the orchestrator sends the full PR, pull request diff, to all the three sub-agents. What's wrong with this? So earlier we saw the example where the PR diff was sent such that only the required parts were sent to the specialist agents. But what if we send the whole thing to all the three sub agents? What's wrong with it? Okay, first of all, let's think about it. Nothing wrong? No, it's not like there is nothing wrong. There is something wrong about it. So it's definitely not A. It violates the fan out pattern, which requires equal sized input to all agents. There is no such rule. We don't need equal size rule or anything. How about B and D? B versus D. It wastes tokens. Each agent should only receive the code sections relevant to its domain. That's the first thing. B. D is it causes agents to produce duplicate findings since they all see the same code. Is D true? See, D is not true. Just because all agents receive the same input does not mean they all will produce the same output, because their capabilities are different. Maybe these agents have different access to different tools, right? So there is no guarantee that they will all produce the same findings. But if the entire code is provided to sub-agents, the sub-agents can definitely see the relevant sections of the code corresponding to their expertise, and they can produce the findings which they are supposed to find. But the thing is, it will also receive a lot of tokens which it cannot do anything with, because if there is a, let's say, a agent which can do some testing on a function, maybe a code review agent looking for schematic of the code need not receive those tokens. So it wastes tokens basically. But there is no guarantee that providing the same input to all agents will provide the same output. There is no guarantee. Different agents have access to different tools. Then a security agent finds 5 critical SQL injection vulnerabilities, but its output schema only allows the maximum severity warning of maximum severity of warning. What design principle was violated? So output schema is not allowing it to produce an output which it's supposed to produce because of its restrictive nature. So that's the reason why it will not. This is not a good structure. What is the orchestrator's role in the fan-in phase of multi-agent code review? So fan out we discussed, from orchestrator you go to different agents. Fan-in is the opposite of that. So what is the role of orchestrator? So this is where the deduplication idea comes. So earlier we discussed, if we pass the same input to 3 agents, they all will produce the same output. They will not all produce the same output, but maybe some findings may be duplicated between the agents, because maybe 2 agents have similar, some capabilities of 2 agents might be similar. Maybe then because of that they can produce same findings. So those findings we deduplicate, and then merge the finding from all the agents and determine overall review verdict. So this central orchestrator agent basically collates the information coming from all the different agents. So in the WSCI framework, what does the C specifically address? Very trivial question. So it basically compresses, reduces what is already there in the context window while preserving critical information. So compress is basically compressing what is there in the context window already. Okay, this we have not discussed, so I will move to this. What is the relationship between compress and isolate in the WSCI framework? Fairly straightforward, nothing confusing at all. Compress will reduce the context within a single window. Isolate is like multi-agent framework. It will distribute the context so that different agents can have its own API calls. So they can work in different context windows. Then in the context pyramid, which layer has the highest preservation priority during compression? This also we have discussed many times, but which one has the highest priority? System instructions and persona, they define the agent's behavior and must never be removed. A production agent handles 50 turn customer support conversations. After 30 turns, the responses become increasingly confused and contradictory. What is the most likely cause? You know this already. It's the context rot. On Visuara's website now we have a calling agent. I urge you guys to try it if you really want to. Just go to our landing page, and there is like a phone icon. Sometimes it'll say like daily limit has reached, but basically you can just there is this ask AI option. So here what we have done is we have an agent with a specific context about our programs and stuff like that. And you will notice that after like 5 minutes or 6 minutes, its ability to communicate in a very nice way will significantly reduce, because we have not optimized the context or anything over there. And after some point, it will completely disconnect. So basically its context window will become full. So compaction and compression we have not yet implemented. So you will see a classic case of context rot if you just look at our current chatbot. But I think now we are making some implementations. Not sure if we have pushed it to production yet, but that was the case 3 days back. Then so here context rot will happen. Then your multi-agent system occasionally produces duplicate findings. The style agent and security agent both flag the same missing authentication decorator. How should you handle this? This we already discussed 3 questions ago in multi-agent framework. So think about this. Sometimes sub agents can give findings which are duplicate. The only place where you can analyze this is sort of in the orchestrator, because these findings are directly going into the orchestrator. So in orchestrator, there should be a step, a deduplication step, so that these similar findings are grouped, so that the context window is not unnecessarily bloated. You are designing an auto compaction system for a coding assistant. Which type of message should never be compressed or removed? Okay, this is an interesting question. So what should never be compressed? This we briefly discussed during the lecture also, if you remember, right? So if you read the structure, okay, let's read this. D, the user's initial request that started the conversation, it's already captured in the ongoing context. So user's initial request, okay, after the initial instructions, when you are building something, what you are building, why you are building, for what you are building, for what's the reason why you are building, all those things are kind of captured in the context. Although if it is part of a claude.md file, we should not delete the file directly, right? But if there are some initial instructions, it kind of is there in the context already. So if the very initial thing is removed, it's kind of okay. But look at this option A, the most recent code edit the assistant proposed that the user hasn't yet accepted or rejected. So when you use a code editing assistant, you will see that the diff is shown in the whichever IDE you use, right? And that diff you have to either accept or reject before moving to the next step. So if user has not gotten a chance to say whether I accept this change or reject this change, probably you should not delete that from the context yet, right? So you should keep this. This is like a very special case, right? So this is a special case where you should not be removing this. Then a multi-agent system for food delivery crisis has agents for order flow, dispatch, driver dispatch, customer support, and communications. The communications agent need access to findings from all other agents to draft the status update. How will this be architected? In what way this will be running? Give the communications agent access to full context window of all other agents. Include the communications agents in the initial fan out so it can observe the investigation in real time. Run communication after the others are complete and pass only the structured output. Then have each agent send their raw context to shared database. So this is classic example which we discussed earlier. If there are agents whose input depends on the other agent, it's like in a sequential way, right? Of course, sequential agents will also get other things in the context. They will get claude.md or other markdown files which are relevant. So there will be a shared base also, but the agent specific summary will be happening in sequence. When Cloud Code spans a sub-agent, how does the sub-agent receive its context? It shares the parent's context window via memory map IPC. It inherits full parent conversation history automatically. It receives a separate API call with a curated prompt containing only relevant context. It reads from a shared database that both parent and sub-agent can access. It's not like that. The relevant context is curated by the orchestrator. Here, the orchestrator is Cloud Code. So this sub-agent will have its own way to call separate LLM. I mean, its own ability to call Claude, whichever model you are using its own API. An orchestrator sends the entire 50,000 token conversation history to its 3 of the sub-agents. What is the primary problem? This is again clear. The primary problem is context rot of each subagent. So the whole point of creating the subagent itself is lost here if you are sending the same humongous 50,000 token history into these agents. So very, very straightforward. In the shared base context pattern, what is the base that all agents receive? So there is one minor issue in the wording here. I mean, answer should be B because a common foundation plus agent specialized context. So agent specialized context, which is agents.md, it is special to itself. Okay, by the way. So in this, from this option, maybe we should just delete whatever is written after this plus. Of course, it is plus something, but the common foundation will be system prompt, task description, and shared data, like in the food delivery incident report.md, cloud.md, and any other shared data. So that will be forming the common base. Then why does the sequential pipeline pattern produce higher quality findings than full isolation? So there is one point which I want to discuss here, which is, see, sequential pattern, pipeline pattern, it's like a double-edged sword, because for reasoning, it can do better job because you can validate what one agent has done using another agent. But at the same time, it can also cause error propagation. If one agent produces something erroneous, it is propagated to next agents also, right? So it's like a double-edged sword. So you will have to put some guardrails. Three agents have 1,000 token budget. The shared base is 300 tokens, and each agent needs 600 tokens of specialized context. What is the total context consumed across all the agents? This should be fairly straightforward. What is the total token consumption? So 600 is the specialized context plus each of them receive 300. So it is 600 multiplied 600 plus 300 multiplied by 3, which is 900 multiplied by 3. It is not 600 multiplied by 3 plus 300. That's not how it works. This 300 is taken three times. Shared base is, although it's a shared base, that same context is appearing as tokens in each API call. Okay, so this is common. So it's 600 plus 300 multiplied by 3, which is 2700. Then a coding assistant uses agents.md file in project subdirectories. How does this relate to context isolation? How does agents.md file in the subdirectory relate to context isolation? So agents.md, which is in a subdirectory, is agent specific. So it defines the context which each subagent receives, right? Agents.md can, of course, be for a specific agent can be modified by the orchestrator for sure. Then when is full isolation the best choice over shared base or sequential pipeline? When do you prefer that instead of shared base or instead of sequential pipeline? This is a classic case where you don't need the agents to know much about what the other agent is doing. They are completely, they're as if they are the only people who exist, like sort of independent contributors in teams. So they are literally in full isolation. Then what is the main risk of the sequential pipeline pattern? We discussed this like 2 minutes ago. So just like how if there is a reasoning, the remaining agents can verify the reasoning. Just like that, there could be a risk of error propagation. If first agent makes an error in sequential pattern, it could propagate into the remaining part of the pipeline. So this we have to put guardrails to make sure that there is an error and it's not getting propagated. So it may result in some extra token consumption to make sure that such a thing does not happen. In a multi-agent system, what is the orchestrator's most important responsibility regarding context? Obviously, the orchestrator's single biggest thing, or rather two things are, one is deciding what subagents you need. Second is once you decide these are the subagents you need, what should we feed to each subagent? So it's deciding what context to include in each subagent's window. Then last question, how do subagents typically share their findings with the orchestrator? So this we already discussed. There is a contract between agent and sub-agent and the orchestrator agent. Based on that contract, there is a schema that is defined, and that schema will be in JSON format or whatever, and then that will be shared. So this is the quiz. So I need, before we wind up the lecture, there is one more thing. Some people have asked me personally regarding an extension to the weekend assignment. I can already see some assignment submissions that are good. But if you need extension to submit the assignment on MCP, please take few more days if you want. Anyways, I plan to evaluate it after this course only. So I will anyway need some more days to go through your submissions properly. So if you need more time, just take more time. Just let me know, drop me a message. Then I can just take that into a note. So this will bring us to an end of today's lecture. So for the okay, there is a question. Most of the examples are focusing on coding agents. Do these concepts work similarly in non-coding agentic frameworks like LangGraph, Crew AI, Google ADK? Yeah. So the framework of agents.md, whatever we discussed today, is kind of universal. It works in almost all agentic coding platform as well as platforms like LangGraph. But I am not so sure about the same for the equivalent of Claude.md file, because Claude.md and similar equivalents are there for coding based agents, but for remaining frameworks, I am not sure how it actually works. My takeaway is, if you have access to a coding agent, which is the most modern, you should definitely give it a try. So in the last 3 days, I was talking to 3 separate friends of mine who are working in good positions. And one thing that they have been telling me is like, they have been wanting to use Cloud Code or similar agents, but then there are severe restrictions from their companies, because one of them is working on Amazon, another person is working in 3M. All of these are like $100 billion+ companies, and it's very difficult for them to come to decision of how to use, what to use. So it's very slow. So then what we thought was, okay, for at least to know what are the capabilities, so that they can propose something to their team, so that the team can form a policy which they can see how to implement in their at least in their team itself. What we discussed was, at least for some personal project which has got nothing to do with company, try some of the most modern coding agents. And if the results are like day and night different, at least try to make a proposal to your company about, okay, this is something that we should have. Many of you might have seen people posting on LinkedIn and x.com about their Cloud Code monthly budget. Like some teams are literally, some teams meaning like small companies, like 100 people team, $50,000 bill they are getting for like 1 month's usage. It's like crazy. And many people are literally stopping their operations whenever there is an outage in Cloud Code. But yeah, Sumit's question, how is the experience with auto research? Are the results of experiment improving? Yes, the results of the experiments are improving. But one thing which I noticed is like auto research, at least the way Karpathy has designed it, has a tendency to oversimplify everything. So it is going towards experiments that are too simple. I mean, that's deliberate. Karpath, you can literally see in the in one of the markdown files that he has written, go for simple experiments which can be executed fast. So because of that, one issue is that sometimes the model will not tend towards complex. So if something complex needs to be done, normally Cloud Code can do it, but in auto research, most of the experiments are like 10-minute, 15-minute, 20-minute experiments. But cumulatively, they of course they accumulate to something better. I can see that the results are improving. So one in the paper that we are working on right now, we are seeing that um, uh, they are proposing like from the embedding layer, find out the deviation from the original data and subtract a certain number, which sounds a bit trivial, but it's working. It's really working. So the results are improving, but then my fear is, okay, are we trying something trivial, or is there something logically amazing here, right? So that issue is there. But you should try auto research once. In all of us in our team are running different research problems now to optimize some of our models to see how good auto research can be. So the way you can set it up is take any Amazon EC2 instance. Slightly better RAM would be better. So the free version has, I think, 1 GB of RAM or something, which is too small. Get something with at least 8 or 16 gigabytes of RAM so that things are a little bit fast, at least on the computer side. Then if you have run pod, just recharge it for $10 or something, $10-15, and then connect it with your GitHub. And you don't need to have OpenClaw or anything in this case. Auto research instructions are very simple. Then whatever is your problem statement, whatever your data set or model you have at the moment, if you don't have any model, that's also fine. You just need to mention it. But whatever your problem statement is, mention that, and mention the direction you want to take. And yeah, in auto research, only train.py we can optimize on multiple files. So the by default way he has mentioned it is only train.py will be changed. But the way I have written it is in such a way that I did not directly clone auto research or anything. I gave the link of auto research to Cloud Code, and I gave my own specific instruction. I asked it to follow the philosophy of auto research, but not follow it exactly. Because in my case, I know that experiments, some of them are not 10-minute experiments, they are longer experiments. But I just wanted to follow the philosophy. The philosophy is continuous improvement and relentless experimentation, in the sense like never stop until a human says you stop. So that's the reason why it's 24/7 it's running. Just try that. I also had used one more GitHub repo for research. Forgot the name of that, starting with M. But I am primarily sticking to auto research for next at least few days. I just want to just see what are its limits, how much can it optimize models. But yeah, you guys should try it. Like at least try for some of your research. Try a modified version of auto research. Don't fork. I mean, don't clone the repo directly. Just give the link to Cloud Code or whichever coding agent you use. Then mention your instructions. Like you don't want to restrict to simple experiments alone. Whatever it is, just mention that, but follow the similar philosophy. I think that will give even better results. In any case, if I get something amazing, I'll share it with you guys in some days. I'm asking it to run a few more experiments today and tomorrow. All right, everyone, we can stop today's lecture here. Thank you so much for joining and staying back so long. Tomorrow we'll discuss about memory. On eighth session, we will. There are two projects option I'm thinking. I haven't yet finalized because both are equally exciting, but I don't have time to show you both. Maybe I'll record one video, one I'll show in the lecture live, and one I'll record a video or something. But let me finalize it and tell you my plan regarding that. So that will be on Thursday or Saturday. So the date I have not finalized. So the build session will be set on my build session will be on Thursday or Saturday. Raj's and Rajat's build session will be finalized. I'll talk with them and I'll let you guys know the date. Share the explanation of software next week, new course, what it will contain. So that I think Raj will be a better person to answer than me. All I know is like he'll show you some amazing practices for modern software development with AI agents. So I think it'll be a very, very powerful tool. Tool as in powerful framework, which anyone can learn from. So I know Raj's workflow in and out because we literally are working in the same office, right? But I think you guys will benefit a lot from learning the sort of workflow that we internally use at Visuara. So check it out. The link, I can just find the link. Just give me a second. Yeah, so this is the link. Yeah, thanks, Riyasha. Yeah, that's the link. Just go through that. You should understand the structure. It's starting on next Monday for continuously 5 days, Monday to Friday. So it'll also be again long lectures of building. You will build a lot of projects as part of it. So it'll be like a pure workflow setting up stuff, like how to set up your perfect workflow for building using coding agents. Because there are different things which you need to do for projects of different complexity levels. So for some simple projects, I never define like, oh, go with this project roadmap document with version 1, version 2. I don't say that. I just want things in one shot. But if it's a very complex project, I typically ask to go first be in development mode, develop the V1, iterate on V1. Once that is done, go to the production mode. Planning mode to development mode. And then if it is a good V1, then put it into production, then go back to planning to V2, then planning of V2 to development of V2, and so on. So I have a specific iterative process which I follow for complex, larger scale projects. For smaller scale projects, I don't follow any of that. It's more random. But anyways, you guys will learn all of that in detail on that bootcamp. So see you guys tomorrow. No, it's not self-paced. It is live. It is it's live happening, I think, from 9 a.m. to 11 p.m. I mean 11 a.m. Just let me just share my screen. So this is the modern. I think somebody had shared the link, right? Sriharsha, you had shared. Yeah, I myself had shared. Let me just open that. So this is the bootcamp link, and the goal here is like to have proper build sessions. So you will have to be ready with your laptop and whatever your coding agent platform is. It will not be a passive lecture where you can just listen. So it will be very, very intense, and you will have to spend a lot of actual brain cells to code. But anyways, just if you have any doubts, just drop an email to hello@visuara.com. We will get back to you. But it'll be a very, very nice course. I highly recommend it. Raj has spent a lot of time designing this. So thank you so much, everyone. Let's meet again tomorrow, same time, 9 a.m. And take care until then. Bye. Hello, everyone. Welcome to a new lecture. First of all, before we get started, I hope you can see my screen and hear me and see me all right. Thank you so much. So today we are on to the sixth session of the LLM Context Engineering Bootcamp, and today we'll be discussing about memory. And this is going to be very important because when you are actually building certain applications using coding agent, many items which enter into the context of the large language model will be coming from the memory. And there are different structures for storing the memory. There are different types of memory. We will learn all of that today. And this will also come handy when you are actually implementing during the implementation lectures. So first thing that all of us should understand is this. I hope everybody by now completely realize that is that LLM is stateless, meaning when you are making one API call and then you go ahead and make the second API call, by default, there is no connection between API call 1 and API call 2 of the LLM unless we explicitly pass something into the context. By default, two API calls are not at all related. The way ChatGPT remembers your preferences or remembers who you are, etc., when you are chatting continuously is because of the explicit definition of what goes into the context through memory. So we will be looking at first an example of the statelessness of LLM and how we can simulate just a simple example where if we explicitly do not pass the memory, how LLM behaves versus if we do that, how LLM behaves. So I'll just, in a moment, I'll share a Google Colab notebook. Let me just first admit a few students. So I want you to open this Google Colab notebook. I'm just sharing the link in the chat. Just keep your OpenAI or Gemini API key handy. So I have shown this to you in one of the lectures before. The way you can add API key in Google Colab is simply click this key button and then you can add it over here. So you can add bunch of API keys and that will persist when you even when you move from this Colab notebook to another one, and it will not get shared. So you can easily access the API key. So just open this Google Colab notebook. Let's do a quick experiment. This will not take any time. Just to see how the behavior of LLM changes when you explicitly define the memory. So first, you import Google.generative AI as GenAI package, then OpenAI. And this block of the code is simply to select which LLM provider are you going to use. Okay, so today's lecture is not necessarily about feedback. Today's lecture is about when there is a long history of communication between let's say user and the LLM, or let's say coding agent and the LLM, how does the LLM remember stuff, and what are the ways in which you store what the LLM should remember in the upcoming conversation. So that is what we are going to cover in today's class. So I have configured OpenAI API. So here in this drop down, you can select OpenAI or Gemini, one of the two options. If you really want Anthropic or any other API keys to be used, it's very easy to change the code. So you can even ask Gemini to change the code. That part is easy. So I'm not going to cover it. And then let's just load OpenAI GPT 3.5 Turbo. Please make sure that you are using some cheap LLM. No need to go with pro preview model or anything like that if you are using Gemini. For me, by default, it was like expensive LLM. I don't think that is needed at all. Now, what we are going to do here is we will just have one interaction. So here we are defining the user input. So user input one is, hello, my name is Alex. It is nice to meet you. So this will be passed into the LLM. So we are just printing the first interaction here. So this part I'll show you when it prints how it looks like. Maybe I can put this in a different block. So first interaction is, hello, my name is Alex. It's nice to meet you. Then we will be executing this else if condition because we are running OpenAI. And look at the OpenAI call. So OpenAI .chat .completions .create. And then to the model argument, we are passing the LLM model name, which is defined to be GPT 3.5 Turbo over here. So this is defined LLM. This defines the LLM model name. And then the messages is the role is user, and the content of the message is the user input one. User input one is defined in the previous block, this one. So this will be passed into the LLM as the message. So let me just put this in a different block. So now the LLM's response is to the question, hi Alex, nice to meet you too. How can I assist you today? Now the second interaction is, we are directly calling the LLM without passing anything extra other than the second user input. So the second interaction is this, what is my name? So right after you made the first API call, you're calling the same LLM using the next API call with user input 2 as the new input. Let me just admit a few more students. And then you repeat the same thing. This time you again call the LLM, and API provider is OpenAI, and the message is such that the content is user input number 2. User input 2 is this, what is my name? So now if we run this, LLM will say, I'm sorry, I'm an assistant and I do not have the capability to know your name unless you tell me. So basically, when we are calling an API, when we are using an API call to call any LLM, by default, it has no memory. You are just utilizing its weights, which are pre-trained. So those weights have certain numbers. And when you are when you are making any API call, what you pass into the context is the only thing that the LLM knows. And here in user input 2, which is now what is forming the context of the OpenAI API call, the only thing in the input is what is my name. There is nothing about Alex or anything like that. So yeah, there is a question when we are interacting with ChatGPT, it automatically adds previous conversation to the context while answering and applies compression whenever required. Exactly. So OpenAI in the chat in ChatGPT, I am not sure how much like in the latest version that we have available, I'm not sure how often or how much does it compress, because you might have seen this is probably a few months ago if you are continuously chatting in one same window, you will see that it has reached the message has reached its limit, right? You might have noticed such errors happening. I don't know whether they have changed it in the latest, not models, in the latest way in which ChatGPT is implemented or not. Yeah, I have made everyone enter into the room now. There is nobody in the waiting room. But in the latest models, I'm not sure. Okay, I have not used ChatGPT chat in some time. So these days, I'm mostly using it through my own terminal. So So anyway, I have to set my own context. But this is the issue. The LLM has no idea about the context. You are the one who is responsible to set the context. So now let's implement a simple memory. So we will make an empty variable called conversation history. In this variable only, we will store the past conversations. So we are defining a function called chat with memory. So inside this function, a few things are there, but let's go to the section where we are calling the function. So the function will be called over here. So I'll just cut this and put it here. Yeah, I'll share the notebook link. So just take a copy of the notebook and just make sure you put your API keys over here, Gemini or OpenAI. So this is the first interaction. Hello, my name is Alex. It's nice to meet you. And then instead of directly calling the LLM, we are calling the function chat with memory, into which we are passing the LLM model, and into which we are passing the user input, into which we are passing the conversation history and the API provider, whichever is our API provider. So conversation history at the beginning, it's an empty array because there is no conversation history at the beginning. User input 3 is nothing but the variable which defines the same user input which we gave earlier, but we are putting it in a new variable called input number 3. So the user input 3 is simply this sentence, and LLM model name is whichever we picked. So now let's look at the function chat with memory. So chat with memory has this variable called history. So history.append. So when we are appending the role user, and the parts is whatever user message we are getting into the function. So the user message in the initial part will be whatever the empty conversation array will be, whatever it will look like. So initial conversation history looks like this. So initial user message is nothing. There is nothing in the history, right? So even when we are adding history.append, nothing is getting added in the beginning. But in the second round, whatever was conversed before will get added. Then our provider right now is OpenAI. So let's go here. So OpenAI messages is equal to an empty array. Then role equal to user if turned in role, else the role is assistant. Because when we are using an LLM, the role can be that of the user or that of assistant. If it's assistant, it's relaying the output to us. If it's a user, we are providing the input. Then content equal to an empty string dot join. So this will then concatenate different strings, part for part in turn of parts. So turn is nothing but you are looping through your history. So in your history, previous conversations will be appended one after the other. So each conversation turn will be picked in this for loop. And then in that for loop, you will be looking at whether the role is that of user or whether the role is that of assistant. And then the content that we are passing into the LLM is the concatenated full context. So concatenated context, which contains the conversations made by the user as well as the conversation made by the assistant, which is GPT. So now this OpenAI messages will be all these items appended into one single string. And what we are passing is response is equal to openai.chat.completions.create. And then we pass the model name, then we pass the messages. And then if we just print it, or if we are returning the function, the value of the function, we should hopefully see the full response, not just the lack of knowledge of the LLM. So let's just define the function by running it and just print it. So now this is the first interaction. Hello, my name is Alex. It's nice to meet you. Then hello, Alex. It is nice to meet you too. How can I assist today? And then in the second part of the conversation, this time there is memory. So user input 4 is passed over here, but at the same time, conversation history is also passed into the function. And now when you ask, what is my name? It will know that your name is Alex, right? So this is how ChatGPT works internally. It considers all your previous conversations in the form of a conversation history. But this is the simplest form of memory. I just showed this to demonstrate to you how memory works in principle. So in principle, the way it works is creating enough context for the large language model so that it can become a useful tool for you. Otherwise, it will be a useless one. So now, if memory was not present, every single chat will start from zero. So it will be a very frustrating experience for you. Recently, we were building, as I was telling in the MCP lecture, we are building the MCP framework for utilizing Blender for building our own style 3D models. So the person who is working as animator, his name is Akash. So Akash was basically trying to create using Blender MCP 3D models in his own style. But he noticed that whenever he's using the Blender MCP to create a new model, it's not because he did not explicitly define any memory. He had to redefine the style in every single turn. So whenever he was trying to make a new 3D model or new scene, it was creating like it, unless you explicitly mentioned your style, it was not able to do that. Then what he did was he created a separate file system which served as the memory, which will go into the context of the LLM, so that when LLM makes the MCP server call, not LLM, whenever the MCP client makes the MCP server call, you are feeding the user style and the way in which Akash makes his 3D models also into Blender. And then immediately the Blender started giving amazing output. So it's so important. You will, when you're working on building any kind of application where your styles and preferences need to be followed again and again without having to explicitly define it, you will need to define files which serve as memory. So this obviously starts learning from zero. There is no learning happening, by the way, no consistency or personalization. And this makes the tool a really useless tool if memory is not there. Now, there is one thing we should realize, that there are, even for humans, different types of memory. So we remember things like what happened. We remember things like information, right? Paris is in France. It's some information that we know in our brain. Then we also remember, or we also know things about how to do things, how to cook pasta, or how to ride a bicycle, or how to play football. So we know certain things, we have some knowledge, and we remember some incidents. So in the memory architecture that we construct for LLM also, broadly speaking, there are three types of memory. It's not like we have to explicitly say something is episodic or something is semantic, but the way in which it is stored in file will depend on what type of memory it is. So episodic memory is something like if you are using a coding agent to build something, the coding agent will remember user asked the so and so in the past conversations. It will remember user suggestion that or its own realization that use OAuth 2 over API keys. If it's semantic memory, it stores the vague preferences of the user. So if user says something like, in general, I prefer dark theme over bright theme, you can store it as a semantic memory in a vector database. So the vectors will correspond to, it will be a representation of the user's preferences given in natural language. Or it can be even very specific facts or very specific preferences that user has. For example, if the user always prefers just one page to show every single information on the website without having any hierarchy of pages, that can be stored in a semantic memory. In procedural memory, what is stored is how to do something. So semantics is what is or what I know. This is about how to. And episodic memory is about what happened. It's already written here. We will look at some examples of memory and we'll see how to classify it into episodic, semantic, or procedural in a moment. And when we are retrieving anything from the memory, we are retrieving in one of the following formats. So if the memory is stored in form of text, and you might probably be using keyword searching to find similarity between what is there in the context right now and what is stored in the memory. So text similarity will be purely keyword-based matching. And this is actually not very expensive. You have already seen this when we discussed that from Claude.md, we are not always fetching everything. We are mostly taking only parts of Claude.md into the system prompt using keyword matching. But semantic embeddings, because it involves a RAG almost always, this is slightly more expensive compared to text similarity. You will have to look at vector similarity. You may have to perform some re-ranking, and then only you will fetch from the memory what is required to be passed into the LLM's context. Sometimes, if you are considering the chat history, in many times you will say, I don't care about chats that happened before a certain date, or I only care about the last 30 chats. So in the email tool which I am building, I only care about the last 50 chats, last 50 email threads. I don't care about the threads before that by default. So that is sort of like a temporal memory where the recent items from the interaction has higher preference to be part of the memory. The earlier ones are discarded. It won't be part of the context. Then there are other storages for memory in the form of graph, knowledge graph. So knowledge graph is nothing but something that consists of nodes and edges. So the way it is structured is nodes will have a bunch of information in the form of a JSON format or something. So key value pairs. So key and value. So let's say the node is about information about customers. So the one node could contain things like customer name, preferences, the amount the customer has spent on the platform, etc. And there could be other types of nodes which describe products. And then the edges are nothing but connections between customers and products, which may indicate whether a customer has added a product into the cart, or whether the customer has tried to place an order, but it never went through, or a customer actually purchased, depending on the edge type. So, I mean, this is a big field in itself. Knowledge graphs or graph neural network, where there is edge prediction, node prediction, entire graph classification, etc., or edge classification. There are a lot of tasks associated with the graph. But one of the tasks is from such a graph, fetching the information that we need. So this is also medium complexity, because graph is not a very simple database. It is a complex database. Actually, in one of the recent industry partnerships which we had with a company, we utilize graph-based data only for memory, because it was very complex database with a lot of relationships between the different data points. When we don't need a graph, is when we have rows, database that are in the form of rows, where row 1 and row 2 are sort of independent. In that case, we just can use some SQL database, or we can use some database that are structured like JSON, right? So I won't be able to talk about more details about this graph-based projects because of NDA, but it was not an immediate revelation that came to us that, oh, we have to use graph for this. It came out as a result of so many discussions that actually we realized that the database is so complex that even if we try to simplify it, and if we try to represent it using a simpler structured data set, it would not work. But it's not, out of all the projects that I have worked on, only in 1 or 2 projects we ever ended up using graph. In most of the other cases, we did not use graph. And the most complex out of all of this is using some machine learning or deep learning algorithm to predict what item from the memory we need to fetch. So obviously it will be much more computational intensive, and I have never used it so far in any of the industrial projects. In most of the projects, I have used the first 4. Text similarity is the most commonly used. Semantic embeddings are, even in the email tool which I'm building, I'm already using it. Temporal proximity also is very often used. Graph-based memory is less frequently used, and predicting what aspects of the memory you might need to fetch from ML or deep learning framework, or some ensemble models like XGBoost or something like that, that is even in my opinion rare. So now you can broadly say, from the items that LLM context has interacted with in the recent past, there are 3 types of memory. One is called hot cache. So hot cache is nothing but what the LLM context just recently processed. It is literally there in the API that is just passed into the LLM, or just to be passed into the LLM. And most often this will be in the format of something like a JSON file, because it will have a structure which looks like this. There will be key followed by value. There will be key followed by value, right? So there will be a bunch of key value pairs in a very structured format, which is about to be passed into the LLM's context. So hot cache is something where you don't have to explicitly do anything, but this is the highest or most uh, valuable or most preferable memory that LLM context utilizes, because this is literally the one that we are passing. The second one is called warm storage. It's just a terminology. You don't have to really try to remember it or anything. But warm storage is equivalent to recent session history. So one example of warm storage that we saw just now is this. So this user input 3 was an example of warm storage because we stored it in the conversation history array. And then when we are passing the user input 4, that user input 4 itself is in the hot cache, and user input 3 is in the warm storage. Warm storage meaning something that was really recent, which was part of LLM's context. And this will also be stored in different types of memory formats. I will show you that in a bit. It can be Redis, or it can be even stored in Markdown files or TXT format. It can be stored as a vector in your Supabase vector database, or it can be converted into vector in your file system itself using ChromaDB if you are local hosting some application. It depends on really your application. And cold archive is the least preferred one, or the least important one for the time being. This will involve things about very big vector database consisting of, let's say, 10,000 emails from your past interactions. And almost always, to fetch anything from this, you will require RAG, or you will require keyword matching, right? So RAG is a very powerful technique, which if you are building any kind of serious application, you will almost always use RAG. And cold archive will exist in the form of structured SQL database, or it will occur in the form of vector database or JSON objects. So just remember that memory, when we talk about memory, there are different tiers. Cold archive we did not discuss in this simple example that we just saw. We just saw example of hot cache and warm storage. Let me just check the waiting room, just a second. So now these are the different file formats. If it's a structured fact, as we know, JSON or SQL or SQLite, and this is almost always stored in a structured database. If it is conversation history, we can store it in array. We can even store it as a text document, or in some cases, you can also store it as JSON, because the structure will be user, which is the key. Corresponding value will be the interaction with the, so turn 1, user assistant, turn 2, user assistant, and so on. In vector database, it will be in the form of ChromaDB, Prisma, doesn't matter which framework you use, you will have one vector of 768 dimensions, or whatever dimensionality of your embedding is, and that will those vectors will form your database. And if it is like a memory that has to be always passed into an LLM, which is always persistent, it will almost always be in the form of TXT file or Markdown files, which is now becoming the norm, or even XML files, like what Claude prefers. Where do we store episodic memory contents inside vector database? So when you say episodic memory, you mean something that happened in the past, right? So what has something that has happened in the recent past, it will be stored as JSON if it's a part of a conversation history, or in an SQL database. It need not be converted into vector, but something that happened in the far away past, because in the far away past, a lot of things would have happened. It's very difficult to store everything and fetch something from a document that containing 10,000 entries. So for there, we need some retrieval augmented generation. In that case, almost always it will be a vector database. Amit has a question. Claude.md is more of a warm storage. So Claude, the document Claude.md, yes, it is sort of a warm storage for sure. But sometimes the items that we fetch from Claude.md are sections of Claude.md, right? So from Claude.md, we will decide to fetch information regarding phase 1 or phase 2. In that case, that particular section which is being passed into the context is called as hot cache. But the claw.md file itself, which is being referred to almost always, will be like a warm storage, correct? Now, there are 5 types of memory management strategies broadly, and today we'll be spending a lot of time on this through this Google Colab notebook, which this is a second Google Colab notebook. I'll share this with you in some time, plus through the interactive website. So this is how to manage memory if you have ongoing conversation. So we will take as an example, ongoing conversation between the user and the assistant, and we will see how each of these techniques can be utilized for that. So there are 5 techniques. Details I will go through one by one. Windowing, summarization, key value extraction, priority pruning. Some of these are things you are already familiar with because similar ideas we have discussed in other contexts. But windowing, the basic idea is that you will decide that everything that belongs to the last 5 windows of back and forth conversations between the user and the assistant, or the last 10 windows, they will form part of the memory. The rest of the things will be discarded. So windowing is a little bit like, yeah, exactly like sliding window, and it will slide from whatever is the most recent conversation to back in time. And everything before that will be discarded. Can you tell me what is the positive side about windowing and what is the downside? In windowing, what's the advantage of windowing technique to decide what should be part of memory? Let's first discuss about the pros, then we can come to the cons of this. The pro is that you don't need a separate LLM call, or you don't need any special algorithm to decide what comes in the window. It's clear, right? Whatever is the last 5 conversations, that forms the window. So the definition of what comes into the memory is very straightforward, and it is very easy to implement. The downside, obviously, is that you may have a lot of useful information in these conversations also. Maybe user had mentioned a lot of their preferences in this turn 1 of the conversation, or turn 2. And if you are windowing, those things might be completely lost. It will be somewhere captured in the ongoing conversation to some extent, yes, but this will be lost. A better strategy, as Amit is saying, could be you somehow summarize this whole conversations that happened before using an LLM into few sentences. On top of this, to not lose the details of the ongoing context, use window as such. So the advantage of window is you have everything that the user has said word to word in this window. But in the summary, everything is not captured word to word. It will be an LLM based summary. So it will capture semantics, but not necessarily the nuances. But this is a good trade off. So the pro is it is the simplest possible implementation of what to store in the memory. The con is, of course, losing all the context before. Token cost is very less, because very less, or it's constant, because what you pass as part of the memory into the context is the same set of tokens. So if you say that last 1000 tokens as part of the conversation is part of the memory, that 1000 tokens, so whatever is the API cost for 1000 tokens for that LLM, that will be the cost associated with memory. So if the chatbot that you are building is very simple and you don't need any sophisticated memory, or you just need quick conversational bot, this is the easiest thing to start with. The second and most, I would say, effective one is LLM summarization, because here there is a proper intelligence layer. So if you have large number of turns of conversation between user and the assistant consuming, let's say, 3000 tokens, what the LLM summarization can do is it can summarize, as we were just discussing, it can summarize everything that happened from turn number 1 to recent turns, and the last 5 turns of conversation, or last 15 turns of conversations, which may be very few number of tokens, can be stored as such. So the proper context of what is happening recently is not diluted at all, but what happened in the past is sort of diluted. So this compression will result in some information loss, but that is the trade-off that we make. But this is very efficient in terms of token preservation. This is very efficient, as we will see in one of our exercises. So the pro is that, of course, it captures meaning and semantics from the past conversations. But the con is that to construct this kind of a memory from the past conversations, you will have to make one API call. And maybe this one API call you are making once in every 50 conversations, or once in a while. So that whatever is the cost associated with all the tokens being passed into the API of that LLM call, that will be your extra cost. And token cost will, of course, be whatever is the cost associated with recent 5 turns or recent 10 turns plus the summarized memory. So this will be the total memory size. So the cost associated with your ongoing workflow will be the cost associated with the ongoing workflow. As far as memory is concerned, will be summary plus the recent turn, whatever is the number of tokens for that. So this is not fixed, of course. Then there is another one which is really, really good at compression. It is called key value extraction. So key value extraction is something where the entire conversation, which may be in natural language, where there is no structure, the only structure will be user, whichever is user interaction, whichever is assistance interaction, that will be the only structure. But converting something like this into a pure super compressed key value pair structured format. What might be an advantage of this? If you are compressing your past conversation into a JSON file that looks something like this, what is the advantage of it? Basically, the advantage of a structured format is to get any kind of data from a structured format. It's very easy. So from this memory, if anything needs to be retrieved, it's very easy. This also results in very, very high amount of compression. And this is also done using an LLM, by the way. So we will explicitly ask LLM to extract this into a structure and convert it into a JSON format. The problem is that this extreme compression may result in loss of information, like something like why the user even decided, some semantic meaning like why the user decided to build something like this instead of something else. Because these are like very quantitative information. Language is Python, framework is Fast API, decisions REST over GraphQL. So it's kind of, the more you become structured, the more it is difficult to capture qualitative semantic information, which may be important when you are building an application. So if you need extreme compression, you can go with JSON kind of memory compaction, but you will also lose some information. In my opinion, this is the best LLM summarization, where you kind of decide how much needs to be rolling summary and how much needs to be the recent ones. This is the best option. But if the conversation has itself inherently has a lot of structured items, let's say the conversation between the user and the LLM is already about some structured data or document format or something like that, and not something in natural language necessarily, we can use JSON. I mean, we can use key value extraction. There is something called KV cache used when tuning LLMs. Is it the same? No, KV cache is different. So KV cache is simply something like this. So the attention weights matrix will look something like this. So let's say you have five tokens, cat sat on the mat. And let's say this is your token. So these are your words. And let's say one word is one token. So totally you have 5 tokens here. I don't know how many of you will relate with this unless you know the transformer architecture, but I'll try to make it as brief and simple. So you have 5 tokens here. In transformer, what happens is these tokens are projected into 3 spaces: query space, key space, and value space. And the way this is projected is your incoming tokens are multiplied by a query matrix or key matrix or value matrix, WVX. So X is the input token, W is the matrix. So then it becomes query, it becomes key, the token becomes key, and token becomes value. Now what we do is, if you have 5 keys, you will have 1, 2, 3, 4, 5. So you'll have 5 rows and 5 columns. So this will be corresponding to cat query, sat, cat sat on the mat. And same will be present here. The key corresponding to the token cat, key corresponding to token sat on the mat. And when we construct the attention weights matrix, the way it is done is such that there is masking. So the future tokens are, I'm going through this a little bit fast. So I know that for those of you who are not aware of this, you will not understand, but that's okay. You don't need to understand. I'm just mentioning since KV cache, I don't want you to confuse this with anything else. So this is how the attention weights matrix will look like, where all these numbers are zeros. So this will be 1. Sum of these two will be 1. So let's say this is 0.6 and this is 0.4. Sum of these 3 will be 1. Sum of these 4 will be 1. Sum of these 5 will be 1. Now, to make the next word prediction, what the LLM needs to do is, LLM needs to know what is the, so this is the next word prediction. So query softmax of query times key transpose divided by square root of D multiplied by value. So this is the attention weights matrix. So to predict the next word, essentially, you don't have to calculate this whole matrix again to continue the conversation, because then you are again computing the attention weights between cat as the query and cat as the key. You are again computing attention weights between sat as the query and sat as the key, doing it for on, doing it for the, doing it for mat. You don't have to do it again if you want to predict the next word, because you have already done it once. So what you can do is, these queries and keys you can already store in the cache. So these values you have already available. This you can store in the cache, so that for inferencing, when LLM is trying to make the next word prediction, all these values are again not recomputed. It is taken from the memory cache, and then only the last row needs to be computed. So from a matrix multiplication point of view, having KV cache will make the computation so much faster. This is in the most simple words the way I can explain, but I know that I'm skipping a lot of things here because um you know so correct. KV cache is about multiplication between key and value. That's correct. Yeah. So basically, then when you multiply with value, so you will have query dot key transpose multiply divided by square root of D multiplied by value. The end goal is, in the attention weight matrix, you just need to compute this one. You don't need to compute the whole thing. And then multiply query dot key transpose multiplied by value. So value will be value vector corresponding to whichever is the next token to be predicted. So the basic idea is that for LLM's inference to be fast, you do not recompute the attention weights of the previous corresponding to previous queries again. You keep it in the cache. But when we change the context every time for context management, we destroy this KV cache, right? So if the context is entirely starting from scratch, yes. But if your context is elongating, let's say you have first, right now I have 5 tokens. Let's say your context is now elongating to 6th token, 7th token, 8th token. You can create a cache for all the previous tokens so that the attention weights corresponding to them are not recalculated. They are available to you already. You just need to compute it for the upcoming new tokens. So this saves a lot of computation time during the inference, not during the training, during the inference. But that memory is completely different from what we are discussing right now. KV cache is anyway something which the LLM does for inferencing speed. It only affects the speed. It does not affect the quality of the output. But here we are not talking about speed or anything. Here we are talking purely about quality, right? So for quality output, the context should not be a rotten context. Context should be of value, of high value. So what are we now passing into the context, right? So that decision is about quality, more than about speed. KV cache is more about speed. So the pro of the keyword based memory is, key value based memory is high compression, but the con is you will miss nuances from the past. The token cost is again minimal because the structured data format output is very small. Most often, the number of tokens associated with it will be like few tokens, hundreds of tokens. But this is used in very rare cases where the conversation itself has a very good structure, which means when you are compressing, you can follow a structured format. Then there is another one, priority pruning, which we discussed in some capacity yesterday also. So here, an LLM decides from all the past conversations plus past items which came into the context, what are the most important, like Claude.md, user preferences, etc. They are eternal. if there are conventions with respect to what we are building right now, from a project perspective, they will be stable for months. So if you are building an email response tool, most of the files which describe the user preferences, like idea.md or initial.md, a lot of things will not change. Then if you have things in the related to the phase 1 of implementation or phase 2 of implementation, it will keep evolving from a day-to-day basis or from a week-to-week basis. And if you are having errors, or if you are debugging something, or if your or if your coding agent decides to try something before coming back to what your main implementation was, in that case, whatever is there in your memory will be very short-lived. So these documents which are associated with your hypothesis testing, or documents which are associated with debugging, they will not be used forever. So the quality of those documents will be very low from a context perspective. It will never ever come back to the context once this particular task is done. So the pro and con of this is also very clear. I just want to get into the implementation part. Okay, so we'll come to this in a moment, but let's open a Google Colab notebook to see a quick implementation of all of this. Let me share the link with you. Right, so this is the link. So just open it once. Let's go through this exercise really quickly. So here, all the 5 methods are being implemented: windowing, summarization, key value extraction, priority pruning, and the last one is semantic chunking. Semantic chunking, I have not explicitly mentioned because you already know about it. You create categories into which you want to chunk your conversation, and then chunk the conversation based on those semantics using an LLM call or using some sort of embedding model. Here in this example, we don't have an embedding model. We'll be using a separate LLM call only. So again, please set your API key over here, Gemini or OpenAI. And the first block of code is simply selecting. So I have selected OpenAI here as the API provider. Summarization and semantic chunking are not the same. Summarization, very good question. Summarization summarizes the entire history of conversation. According to this example, I'm speaking from this conversation example perspective. If there are 25 turns of conversations, summarization will simply summarize it into, let's say, 300 tokens. In semantic chunking, the first step that is done is, from the conversation, each turn of the conversation, you will label whether this is technical or whether this is related to some, let's say, product or something else. And then whichever conversations are related to technical, you will group them together, and then you will call an LLM to summarize it. So in semantic chunking, in general, you don't necessarily use an LLM. You may use a language model like the sentence transformer to convert it into vector embedding after you chunk. But in this example, in today's example, I'm going to show you how to implement semantic chunking using LLM only, not using an embedding model. Windowing is done where there is just one LLM call. You pass the entire context into the LLM, ask it to summarize based on what your need is. In semantic chunking, you pass 2 things into multiple LLM calls. One thing is what the chunk is corresponding to. Is it about technical? Is it about customer? And then what are your preferences when it comes to summarizing this whole thing? Is semantic chunking the same as what we used in RAG? Exactly. Semantic chunking is exactly what we used in RAG. Okay, so now this is our data set. Okay, so look at the data set. This is the user. This is the assistant. And there is around 22 or something. Yeah, 22 past conversations that have happened between the user and the assistant. Now you will notice also one more thing here. If you scroll a little bit to the right, there are 2 more fields called high, intro, low, intro, etc. The high and low are about the relevance of this particular conversation for the memory. Intro is about what this particular conversation was about, described in just one word. Okay. So high is about high and low are about relevance, or medium, they are about relevance. Intro, the last item, is about what the topic of this particular conversation was about in just one word. My question is, who created this? Like, who made this high intro, low intro, etc.? Meanwhile, I'll also answer one question. Semantic chunking using LLM only, not embedding. So what's the difference? So in this case, so when I say LLM, I simply mean models like GPT, where the output is in the text format, right? So here in semantic chunking, in this current example, what we are doing is we first chunk the document based on whether it's in the intro category, whether it's in the text stack category or deployment category, then use an LLM to squish it in natural language itself into a small set of sentences. In semantic chunking, actually what is done is the same chunk is passed through an embedding model to convert it into a dense vector format. So that vector will be bunch of numbers. It will not be in natural language. Now we can retrieve that. We can retrieve the vector and retrieve the chunk corresponding to it. But by default, it will not be stored in natural language. By default, it will be stored as a vector. But in the current example, we are showing it is not in the form of a vector, in the form of natural language only. But yeah, coming back to my question, who wrote this? Like, who decided this should be high or intro, or what the nature of this conversation is? Yeah. So this data is synthetic generated by LLM only, no doubt about it. My question is, if a data structure like this is there available to be, let's say, passed into an LLM for summarization, right? So that memory can be created. Like, who will do this job? Is the LLM that is being your main orchestrator? Is LLM going to do this job, or is it done by someone else, or is it through let's say keyword based matching or something like that? Because think about what this is. This is the conversation history that is continuously ongoing between the user and the agent, and this is constantly being developed, right? So you can have a tool which can be something like a keyword based matching tool, which based on the keywords can map the current conversation into a high relevance category or low relevance category in the cheapest way. So keyword based matching is very cheap. No LLM is involved. If you want it to be expensive but so accurate, you can pass this into a smaller LLM and say, hey, you should categorize this particular message into relevance, based on a relevance score. So high, low, medium is like relevance score, and also into a category. Maybe the category you can give already, like the categories that I am interested in is intro, this, and this, or it can also come up with its own categorization. Those are the two ways in which an ongoing conversation between an LLM and an agent can be categorized. So you make a separate LLM API call to categorize this conversation, or you do simple keyword matching, which means it will be much less expensive to convert or to add its relevance score and to add its topic. So these are the 4 items or 5 items: ID of the conversation, speakers, whether it's the user or the agent, content, relevance, and topic. Now, let us just print this. So there are 22 turns of conversations and 1097 tokens. How using keyword matching you get topic? So keyword matching, we have to already define if the conversation involves, hey, so and so, I am so and so. If there are certain keywords, it falls in the category of intro. If the keyword involves something which are from a dictionary of, let's say, web developers, then it can fall into category of, let's say, technical discussion, something like that. So it depends on what keywords exist in your dictionary and how your conversation is compared to your dictionary. But it's not a smart thing. It's a, yeah, exactly, it's like a hard coded logic, which is fine. I mean, you don't need to convert every single conversation happening between the agent and the user into some category by again making an LLM call. That's too expensive. So there are total 1097 tokens. Now the question is, when we compress or when we convert this into a memory format using windowing or using summarization or key value extraction, how much will this 1097 tokens shrink? That is one thing that we are going to see. Plus, how will the output look like when we are compressing this so that it can be passed into the memory of the LLM in the next call? How will this look like? So just scroll down to this section, strategy 1, which is windowing. So in windowing, we are saying the turns we are passing. So the turns are nothing but it's this variable name, conversation converted into turns over here. Where is my turns variable? Okay, I think I'm using a different variable name to be when we are calling this function. It's not turns. Okay, anyways, let's look at the variable that we are passing is conversation itself. The conversation variable is defined as these 22 conversations over here. All right. So, and then when we say n equal to 4, turns of minus n means it will look at all the items from the last item to the fourth last item. So last, then n minus one item, then n minus second item, n minus third item. And then output of windowing is nothing but those four items. And this n equal to 4 is what we are passing. This we can change. So then when we print, obviously you will see the last four items, and last four items are 3 from Jordan, who is the user, and 1 from Task Pilot. So only these four items will be present in the window. And then look at the format in which it is present. This is present as an array, right? So the last four rows of this array are now present in your memory, and this can be passed into the LLM, which we will see in a little bit. And how many tokens are there in the windowing? So 1097 tokens is now compressed into 176 tokens, which is roughly 84% saving. I mean, of course, this will be high amount of saving, and this savings is only going to increase with time because the conversation length is going to increase with time. But this doesn't mean much. This simply means that you are literally discarding most of your conversation, right? So we'll pass along with the speaker name, right? You mean when we call the LLM? Is that what you're asking? When we pass along with the speaker name? Yeah, we will pass along the four things in this case: speaker name, the conversation, the topic, and the relevance. Then let's look at the second strategy, which is LLM based summarization. There was no keyword search applied here. In this case, in the windowing, there is no keyword search. There is literally, you just say the last four windows, last four items you pick from your turns of conversation. You discard everything else. Then in the summarization, you pass your conversation to this variable called turns. So conversation is over here, summarization of conversation. Conversation is the 22 conversations. And you also keep recent 3. Keep recent 3 means the last 3 items will be kept as such. Everything before that will be summarized using an LLM. Okay. So old is everything from conversation number 1 to conversation number n minus 3. And recent is the nth one, n minus 1, n minus 2, those 3 items. And then here we have a function called call LLM. Then the instruction that we are passing to the call LLM is compress this conversation into 2 to 3 sentences. So this conversation here refers to the conversations from 1 to 19. So compress this conversation into 2 to 3 sentences. Keep all decisions and facts. Drop pleasantries. Pleasantry simply means the words that do not carry any decisive or factual information. And then we are passing the old conversations here. So this variable old consists of everything from 1 to n minus 3. And then the return is summary. And then let's look at the call LLM function also. So the call LLM function was defined here. So in the call LLM, whatever the input is passed into the LLM in this way. Chat.completions.create model equal to model, message is equal to role system. Then so it's a system prompt, content equal to system, role user, content prompt. So here one thing is that this role user will remain the same, but inside the content, because at the end of the day, when we are passing something to the LLM, the role is the user. But in the content, there are two things. Some conversations came from the LLM, some conversations came from the user. Okay, so please don't get confused. Here, the reason why role user is mentioned is because we are calling the LLM as a user to provide us the next output, correct? But in the content that we are passing, implicitly, which conversations was made by LLM and which conversation was made by the user is already provided in the prompt over here. So these 22 conversations contain the role. Here, the role is that of the LLM. Here, the role is that of the user. So that is very different. So please don't get confused there. Then there is no meaning you are a helpful assistant in a system prompt. Can system prompt be empty? That is a good question. Let's try that actually. Let's keep system equal to system prompt as null. Let's see what happens now. So now there is nothing that is passed as the system prompt. Probably it will work. Let's try. Okay. And then let's call the LLM summarization. So now the output is, yeah, it worked actually because, yeah, what you said is correct. Just saying you are a helpful assistant, I think it's already embedded in the LLM's instruction tuning. It already knows that it is a helpful assistant and it's supposed to give answers. So it's probably not needed, which is why the output, it doesn't look like the output is any different from when you leave it. So the output looks like this. This summary is that of conversations from 1 to 19. This is the conversation 20, 21, and 22, which is left as such. And this is the best kind of summarization because savings are huge. 78% of tokens you save, but most of the factual information are retained. And the latest context, which is untouched, will be also passed into the next call. Okay, so this is LLM based summarization. Let's look at the next one, key value extraction. Key value extraction is, again, we are doing it using an LLM. We ask an LLM to convert it into a key value format. Okay, can we check if there is any difference if we add that to the system prompt? Of course. So you mean absolutely there is any difference or not? Some difference will be there, of course, because temperature is set to be 0.3. That setting is provided somewhere here. We can try playing with the temperature. Let's keep this as 0. Okay. Or let's keep this as 0.3 and then let's run this once more and see if the sentence, how much the sentence changes. The sentence will change each time little bit. Yeah. So just look at this summary sentence. This will change slightly. Jordan is developing SaaS. That's how it started earlier. Jordan is developing a SaaS project called Collabflow, a team collaboration tool. So I'm just copy pasting this in the chat just to keep it handy. So this was the previous sentence. And run this once more. This is the new output. Let's see if there is even a single difference. Yeah, there is some difference. As you can see, the two outputs are not exactly the same if you read the two chats which I have just pasted, but you can just keep this as 0. And now after this, we'll try with adding the system prompt back. And then run this. I don't think the first thing is yet executed. Okay, so now this is the new summary. Okay, just look at the structure of the summary and let's run this once more. So if you see this, the summary looks pretty much exactly the same. It's word to word the same. There is no difference. So the temperature setting of the LLM allows it to select, because at the end of the day, when it does the next token prediction, there is a softmax probability distribution. So if your token library is of 50,000 tokens, your LLM says, here is the next token with the highest probability from your library. If the temperature is 0, it will pick the highest probable token always, which means the output will be very different. Maybe the last time difference was because of temperature. So because of temperature, of course, there will be difference. But more importantly, the question is, if we keep the temperature the same, so let's keep the temperature the same, but add a system prompt. Okay, so temperature, let's keep it as 0. So that effect is not there, but let's add a system prompt saying you are a helpful assistant. Now let's see how much the output changes or what changes. Qualitatively, nothing much should change, but I'm just curious how much will the exact output will change. Something will change, I'm pretty sure. So this is the new output where I added the system prompt but kept the temperature as 0. So this, if I compare with the previous output, it's different, right? So of course, the system prompt is playing some role, because it's also going into the context, which means the next token prediction will not be exactly like how it was in the absence of system prompt. So it will have some effect, but because this is too generic of a system prompt, I don't think it's adding any value, right? So let's keep the temperature back to zero 0.3 because I don't want deterministic outputs. I want some variability. Oh, even with temperature 0, output is not usually deterministic across calls. They were referring to some hardware entropy. Oh, really? I am not aware of it. From my understanding, next token prediction, you have a probability distribution in the form of softmax. Temperature equal to 0 means you end up almost always picking. I mean, unless you have a some sort of random number generator coming into picture somewhere in the inference pipeline, which I don't think is there. So I don't have an intuition of why, if temperature is 0, the LLM calls can be non-deterministic. But yeah, for now, the example that we just checked, it's of course deterministic. So here, this is one of the best ways of compressing information, because you lose the context for the far away information, far away conversations a little bit, but the recent conversations you retain. Just curious, is there any evaluation metric or benchmark to evaluate the accuracy of summarization? Can we use perplexity method? Yeah, we can use perplexity method, or it can be even simpler. You just, in general, if you want to have some evaluation, just make one API call where you ask an LLM to extract facts and information from the last 25 conversations. So you just make that LLM call once in 25 turns. And then when you have the response, when you have the shortened summary that is constructed, use another judge LLM to check whether that constructed summary has how many facts from the facts which you extracted. So if you extracted 20 facts and the summary retains only 15 facts, this is something that we implemented yesterday also. But yeah, perplexity score is also one way to do that. I mean, but it's a little bit more formal way of saying it, but the most simpler way of doing it is just extract the facts and see in the summary how many of those facts have been retained. When summarizing the older conversations, somehow we should preserve some transitioning context just before the start of the window. Yeah, that is a good question, and I think that can be done by just passing it into the LLM token. I mean LLM context here. So here we can say compress this conversation, and I'm just going to copy your comment. So I'll just paste it here. Okay, so I just literally pasted the same thing here. Keep all decisions. Then when summarizing like this, somehow try to preserve. Then, so this is the sentence. Okay, so I'll just put it back so that the structure is not broken. And now let's see if we run this, how the sentence summary changes. So now this is the new one. Let's see how the new sentence looks. Summary, Jordan is developing SaaS project called Collab Flow, a team collaboration tool using TypeScript. The MVP deadline is set for March 30 with a strict scope of doing so and so, while ensuring integration tests are written for every feature using white test. Is that the same thing that was discussed in the last? Yeah. So in the fourth item from the bottom, it was talking about white test only. So it is somehow providing the context corresponding to the latest conversation. But I think in the normal summary also it was doing the same thing. But in general, the answer is yes, you can do that if you want to preserve the context of the conversation that just happened before the third conversation, so that there is some nice segue from the older summary into the recent conversations. You can do that. Now for key value extraction also, it's pretty much the same thing, where you don't split the data into older conversations and newer ones. You simply call the LLM, where you say extract all key facts as a flat JSON object. Then rules are maximum 20 keys and corresponding values, no sentences, no nested objects. So basically this will preserve the JSON format. And then here you are just removing some characters to strip markdown format notations. And then just to print the conversation in a JSON format. So let's just print this. This part is very easy. You are literally asking the LLM to convert it into a key value format like JSON. So you see the massive compression that has happened, 1097 to 150 tokens, and username, user role, project name, tech stack. So see, testing framework is test. So this came from the fourth last conversation. So here it was mentioned. Noted test integration test is required for every feature. So that is coming in the JSON format. But all the conversation, the qualitative context of the conversation is lost. Only quantitative items are present here. Then the last item is priority pruning. And this is where the fourth field, or rather third field, which we had entered will come into picture. So the third field was that of relevance. And this third field was constructed using a separate LLM call or using keyword matching. So high, low, or medium. So what we are going to do in this pruning is we will keep the high and medium relevant items, and we will drop the low items. So in priority pruning, we will say high. If the priority is high or medium, call it as in the keep array. So if the item is belonging to the high or medium, it is kept. Otherwise, it is pruned. Okay. And then what we do is in the final output, you will simply see that these are the items that are pruned. They are simply dropped. There is no LLM call involved here. The only part where if you want to say LLM call was involved was in deciding what is of high priority and what is of medium priority. But once the priority is decided, you can simply drop the conversations that are of low priority. Here I can also do something like this. So here the compression is from 1097 to 858. But here I can just remove the medium priority items also. Let's see how many tokens are removed extra. See, it went from 800 and something to 539. Only high priority items are kept in the conversation. This is also one thing that can be done. That way, a lot of verbose is removed. A lot of unnecessary information in the conversation is directly removed. And then the last one, semantic chunking. Semantic chunking is the most important one in my opinion, which you should ideally do using vector embedding model. But here I'll show you how it is done. So first we have groups based on the keywords. So I'll just run this and show you what are those keywords. There are, I think, 5 or 6 groups. One group is intro, one is tech stack, then authorization, database, deployment, and I think there are 2 more or something, styling, planning, testing. Okay. Actually, there are 1, 2, 3, 4, 5, 6, 9 groups. Then what is done is look at the summary. LLM is asked to summarize based on the group. So we are passing chunks, where one chunk is all the conversation belonging to intro. Then another chunk is all the conversation belonging to tech stack. Another is all conversation belonging to auth. So here the total number of API calls that we are making into the LLM is 9, because there are 9 chunks. And each chunk is separately summarized by the LLM by getting all the conversations belonging to that chunk into one API call. And here the summarization is again very good. 1097 is summarized into simply 258 tokens. And if this is all again done using a vector database, it is the best, because then you will again save a cost of calling an expensive LLM. who came up with these groups. So the groups, either it can be through an LLM call, as we discussed earlier. An LLM can categorize conversations into groups, or if you already know what kind of conversations are happening in your application, you can already use keyword-based matching to convert your conversation into groups. So for example, Amazon, I know from one of my friends, they were trying to implement for customer care before LLMs came into picture using pure NLP. They were trying to do keyword-based matching, TF-IDF we discussed, right? Keyword-based matching to classify a customer's conversation into complaints, or whether it's to ask information, or whether it's to ask for refund, etc. But if you use an LLM, it is of course an extra call. It's more expensive, which is why almost never you should use an LLM to convert your conversation into a group. That is very, very expensive, which means for every single conversation you make with an agent, you're making one more extra API call to just classify it. Instead, don't make one more extra API call. Just use keyword-based matching to match or map that conversation into one of the predefined groups. Or one of the clusters. You can also use clustering to create new clusters which did not exist, so that you don't have to predefine the groups. So based on user's question, I can find out the topic and then only provide summary of that particular topic only. Exactly. Do we store these chunks in their cluster head in the key value pairs? So this is right now stored as just as a key value pair document. I think in JSON format. This can be in any format. The key is the intro and value is this, or it can be even as an array, a two-dimensional array where you have one item which defines the name of the group, another as a string which defines the summary of what that group was about. But the storage, exact file format of the storage can be dependent on what your preference is. But at the end of the day, when it is being passed into the LLM, it will be all concatenated into one single string. How to make sure that clusters are always unique? You mean this? How to make sure that these are unique? So that is basically by definition of cluster itself. When you are creating new clusters, like 2 times the intro cluster will not be created, because then it will be combined into one single item. When you are naming, but okay, your question might be, how can we make sure that one cluster called intro and another cluster called introduction, how can that not happen? If that is the question, we will have to put some hard rules saying these are the only clusters. And then if there are 2 clusters of similar names, maybe just for renaming and deduplicating the clusters, we can just make use of one LLM call. So if one cluster happened to be named as intro, if another cluster happened to be named as introduction, and like that, let's say you have 15 clusters and maybe 3 or 4 of them are duplicates, simply to rename the clusters, you can just make one LLM call, which is not at all expensive. Do you attach one person's conversation to the group or whole turn? You attach everything that belongs to intro. So look at this. So here, this is intro. This is intro. This is the user's intro. This is the LLM's intro. But both of them are part of intro, right? So here, Jordan and Task Pilot. So both of these conversations, these are 2 different. One is user and one is the agent. Both are passed into the intro bucket. I don't think there is any other conversation belonging to intro. Similarly, see, this is tech stack. This is also tech stack, but this is the first one is from the user, second is from the agent. So as long as if you have 5 conversations here belonging to the category intro, it doesn't matter whether it was made by the user or the agent. All 5 of them are passed into the LLM for summarization, but they are passed as one single chunk. If we are doing actual chunking and actual vector database creation, the definition of the chunk will be all the conversations whose marker says intro, then all those conversations will belong to one chunk, and all those, one such chunk will be converted into one vector. But in this case, for these simple databases or simple 22 conversation long conversation, we don't need a vector database because it's an overkill. Does LLM also provide drag out of the box? When we upload files, they should get converted into an embeddings and stored somewhere. That is a good question, whether ChatGPT provides out of the box RAG. I am pretty sure they have some sort of implementation of RAG. Otherwise, when you are uploading, very big PDF documents of 100, 150 pages, they are clearly able to extract information from specific pages in that PDF. If you ask it some information and in which page this information is found, it can easily find that. So yes, I think it implicitly allows as in it does RAG to some capacity. Do we also store the results from key value extraction into a long-term memory, or are they only stored in the short-term conversational memory? So here the idea is, where do we want to pass this next? We want to pass this information into the ongoing conversation, right? So let's say now Jordan task pilot has to respond item number 23, then item number 24, 25, and so on. It will form part of the hot cache, the item which is summarized, because that is passed into the LLM's context in the immediate next call. The format of its immediate storage may vary. It may be in JSON format, it may be in Markdown format or TXT format, whatever the user uses. But at the end of the day, it is forming part of the hot cache of the LLM because this summary is immediately being used. And when it is being used, it doesn't matter what format it comes from. When it is passed into the LLM, it will be converted into a concatenated string. Clusters are generated user specific, or is it in general for all users? I mean, here there is no concept of user. And I mean, at least here in this example that we are talking about, here the user is simply just one person, whoever is using this app. The agent is the LLM, and then clusters are generated based on the conversation, right? So if for the same person who is using this, if the conversation diverges into some other topics, of course some new clusters, if we are creating a clustering algorithm, of course new clusters can emerge. But if we are using an algorithm where there are predefined 10 or 15 clusters, basically what is done is classification. The conversation will be classified into one of the 10 or 15 clusters. Is the chat history maintained for each user session separately? Actually, in chat GPT, at least from my latest experience, that is not the case. I think between different chats also the memory is maintained. I have many times noticed that because my wife and I use the same chat, sometimes the LLM assumes that I am my wife, and sometimes when she asks the question, it assumes that it's me. And we might be chatting in different chats, not at the same time, at different times. So at least in chat GPT, the way they have constructed it is so that it is ideal for one single user. I'm not talking about API. I'm talking about ChatGPT app. In API, there is no such thing. API is like, it's like completely under your control. Okay, so now priority pruning is done, semantic chunking. These are the chunks, and let's just have a quick comparison between these two, these six or five approaches. What did you achieve by creating the embedding for each chunk in this case? By the way, I did not create embedding. That's what I mentioned. Ideally, I should create embedding. But here what I did is I summarized the each chunks into a small conversation. So here, the chunk which is called intro, which included two conversations between Jordan and the agent, is now compressed into one small sentence. So, and look at the total number of tokens. Total number of tokens, if all these chunks were expanded, the total number of tokens will be 1097. But now, since all these chunks are compressed using an LLM, it is converted into 258. If we are using embedding, the chunks will be converted into vectors. Then the vectors can be used for retrieving the chunk back in natural language. If you embedded this, how would you retrieve and for what? You will retrieve the, okay, the question is, if you are, okay, for what purpose would you retrieve? A good answer for that is, let's say your conversation history is 300 conversations, and let's say there are 30 separate chunks, okay? And now the latest question that the user asks is regarding database and not regarding anything else. Then maybe from the memory, you don't have to pass all of these chunks into your next LLM call. You just need to retrieve the chunk corresponding to database by doing vector database matching, and then find the vector corresponding to the chunk, database chunk. So basically user query will be there, which is the latest conversation that has happened. Convert that into a vector. So let me just draw it somewhere here. So you will have, so let's say user asked a question to the agent regarding database. Now for the LLM to respond, it will get access to this particular query plus some things from the memory. And what are the things from the memory here the LLM needs access? Does it require all the 30 chunks? Probably not. It just needs the chunk corresponding to database. And how is this database chunk found? The question of the user is converted into a vector. Then in the database, maybe there are 100 chunks converted into 100 vectors, right? And then you will see based on cosine similarity or any other metric, how close is this vector to any of these vectors. So if this vector is closest to this vector in terms of cosine similarity, you will retrieve this chunk, and meaning this vector. And then that vector will have an index, and that index will give you the access to the actual chunk, which is the conversation. So that actual chunk will now be passed into LLM along with the recent conversation to produce the next output. But how do I know the user question is about database and not about intro? Yeah, very good question. So in typical RAG, you have to first, one way to do that is the user's question is just converted into an embedding. So you don't have to know whether this is regarding database or this is regarding intro, right? So the same embedding model, whichever embedding model converted your memory into vectors, use the same embedding model to convert this user's question into a vector. So you really don't know whether it is regarding database or not. All you need to know is to which chunk is this the closest. Then if this is closest to the chunk corresponding to database, then that is the proof that this is something related to database. That's the whole idea of RAG, right? In RAG, you don't know what the user is asking. You simply know whether the user is asking, the question that the user is asking is closest to something that is already there in our vector database or not. So just by using the same vector embedding model, you can find whether this vector is closest to one of the chunks in your database or not. How do you decide which strategies you should implement for your app? You mean whether you should use RAG or whether you should use some keyword key value pair based approach or not? If it depends on the seriousness of your app. In my experience, if the app has to be really good in handling the context, you must have RAG. You must have a vector database, because any serious application, you think about it, any serious application will have a long history of conversations with a given user, or a long set of documents which will serve as the knowledge base from which the LLM can get the context. Now, in what format will you store this knowledge base? If it has 3000 lines, are you going to store it as pure JSON? And then are you going to do keyword based matching? Or are you going to store it as markdown file? Because if you have a markdown file with 5000 lines, right, each line will be 10 words, each word is one token, so that is 50,000 tokens. Your LLM might have only 200k tokens as its token window, context window. You're already polluting your context window unnecessarily. So what you have to, in almost all the cases, any serious chatbot will require some sort of RAG to handle its knowledge base and to handle the conversation, to fetch relevant information from the database into your context, into your LLM's context. For application RAG, would FAISS suffice most of the times? Yeah. So Facebook AI semantic search, FAISS is Facebook AI semantic search. It is one of the fastest and most efficient one in terms of fetching the correct vector from your database corresponding to the vector of your user query. It is one of the most commonly used. It is one of the fastest. In my experience, it is the fastest in all the projects that I have implemented so far. It is by far the fastest. Okay, let's look at the last thing in this Google Colab notebook. So last thing is this. How did the compression work when we converted the conversation for memory? So original item was 1097 tokens. Priority pruning was the worst, because in our conversation, very few items were of low priority. So the compression only helped so much. But LLM summarization was very good, very high summarization. Windowing was very good, but also useless. Then the next most useful thing is semantic chunking. So either of these are very useful, windowing, summarization or semantic chunking. But the most useful one is semantic chunking, because as your conversation grows, you need to semantically convert it into vectors, store it in a vector database for your future retrieval. All right. Let's also open this website once. Just have this ready. We can just see this in action in a slightly interactive way. Okay. So here I have again another full conversation. This is a different example here. There is Jordan task pilot, but slightly different example. The conversation might look almost similar, but I think there is slight variability. So if we apply windowing, let's see what happens to the conversation in terms of number of tokens. Tokens went from 1238 to 368. And this is what many of you were asking. How do you know whether the summarization actually worked or not? So here what I have done is I have asked the LLM to make a separate um, list of facts and quantitative data from the conversation. So these are all facts, right? The username is Jordan, project name is Collab Flow, etc. And then you will make another LLM call to check, or you can make another keyword based searching to check whether in the compressed context after windowing, how many of these 24 facts are present. In windowing, very few facts will be present. That is needless to say. The reason is in windowing, you are eliminating all the previous 19 or whatever number of conversations you have before your window, right? So of course, this will be linear. Like whatever facts existed before your window, they are all lost. If it is LLM based summarization, let's see what happens. In terms of facts retention, most of the facts should be retained. So you see, LLM-based summarization was almost as effective as windowing. So windowing resulted in 368 tokens. Some LLM-based summarization only has 280 tokens. So there is more saving in terms of tokens. But look at how many facts are retained by LLM. 21 out of 24 facts are retained by the LLM. So the information retention rate is 88%. Then key value extraction will be also amazing in terms of compression, but let's see how many facts are retained. So in terms of compression, this is the best, 180 tokens only. It's even better compared to LLM-based summarization. But in fact, this key value extraction is also done by an LLM. Retention is checked by checking using an LLM API call, whether in this summary document, how many facts out of these facts. So this is now the facts list. So out of this list of facts, how many of these are actually present in my summary? So I'm making another LLM call internally to check this. This can be done using an LLM call or using keyword matching. Both are fine, right? So that will LLM itself can give a score. Score saying 18 facts were found in the final summary out of 24 facts. And when it comes to pruning is not the best, but here a lot of facts are retained because here if you look at the priority that LLM has assigned, many of these conversations LLM has assigned as low priority. So one thing I want to check is, yeah, so you see this in the first conversation, the priority is not low, it is high because it defines the user's name, the name of the project. I mean, name of the project is Collab Flow, name of the project, my name is Jordan. So all these things are defined in the first conversation. But in the second conversation, look at this. The task pilot's response is just verbose. It's just saying, it's just being nice to the user. So this is given low priority. So this is completely removed. So you can see that many of the responses by task pilot is just mirroring. It's just relaying what the user has said. And then it's saying, this is what I'm going to do. So many of them are given as low priority. And because of that, pruning will eliminate all of that. So most of the things that are retained are Jordan's communication. Very few related to LLM's responses provided. And see, most of the items which are part of the checklist are provided by the user only. And because of that, even after you do pruning, a lot of the things are retained. Only 2 items are missing. So the score is 22 out of 24, even better than LLM summarization. But this is depending on a case-to-case basis. In semantic chunking, these are the chunks that are retained: intro, tech stack, database, deployment, MVP plan, practices, etc. Each chunk is now summarized through 1 or 2 or 3 sentences. And look at the amount of information that are retained. This is very, very high information retention. Look at the compression, 74%. So compression is very good. Memory, this retention of the information is also very good. So semantic chunking, in my opinion, here performed the best, right? So this is just a illustration of what type, and this is exactly what we want, right? When we are passing context into a new LLM call, you don't want to pass some random useless information which are just nice communication between the LLM and the user, but you want to pass facts and quantitative information. And here, this semantic chunking is working to a great extent. Let's check one more thing. We discussed about memory tiers like episodic memory, semantic memory, procedural memory. Okay, there is a question. Semantic chunking using vector DBs. Conversation will be grouped into different categories using RAG by converting conversation into embedding and then comparing similarity against vector search. So conversation is grouped into different categories. That is not using RAG. Okay, I think there are two things to discuss here. First, to create the vector database, how do we create the grouping? Before the vector database is present in the RAG, because when we are performing RAG, we already should have a database, correct? And to that database, we are comparing the upcoming conversation. So to create the database in the first place, there should be some intelligence in the embedding model. So the embedding model will decide what the vectors will look like. And before passing something to the embedding model, if we ourselves are doing the chunking, how do we know which conversation belong to which task? Whether something belongs to intro, whether something belongs to deployment. Because to perform chunking, when we discuss RAG, we did few types of chunking: fixed size chunking, we did windowed chunking, we did semantic chunking. So there were different type of chunkings. So similarly here, to chunk the conversations into different categories, you need one layer of intelligence. That intelligence can be rule based, it can be purely based on keywords, or that can be used on using LLM. Now, once the chunks are created, the chunk is converted into a vector database. So now you have the vector database which stores the information corresponding to the past conversation in the form of chunks, in the form of vectors. Now, when a new conversation happens, how do we know whether these vectors which of the vectors in your embedding is corresponding to your new conversation? For that, the new conversation also is converted into a vector using the same embedding model. And then that vector is compared with all the vectors in your database. And whichever vectors are close to each other, whichever vectors this particular user query vector is closest to, those chunks or those vectors will be retrieved and they will be passed into the context. So this is how RAG works in this conversational chatbot. Okay, so let me ask you a few questions. How about this? Always format API responses as JSON with a consistent envelope. Is this an episodic memory, semantic memory, or procedural? This is about a procedure, right? This is about how to do something. So procedural memory. Last Tuesday, the deployment failed because the Docker image exceeded 10 GB limit. What is this? This is something about something that happened in the past. It's about an episode. This is just exactly like how humans store information. It's an episodic memory. The development team has 4 backend engineers and 2 front-end engineers. This is not episodic. This is about semantic, right? It's about what is the truth, what is that the LLM knows. When debugging production issues, first check the error logs, then metrics, then deployments. This is again about implementation. It's about procedure. So it's about how to do things. The user reported that API returned a 500 error when uploading files larger than 50 MB. Is this episodic or semantic? So this is a little bit confusing. Is this something which happened or is this something which I know? Let's go with episodic because this error which occurred is something that happened and it's just that the user has reported it. Then the user prefers Python over JavaScript. What about this? Is this procedural or semantic? Because is this defining when we are implementing the code, I should use Python? Or is it saying, is it talking about some sort of user preference? So this is about something that the model knows about what users' preference is. It can be about language, it can be about color theme, whatever. So it's semantic. When the conversation gets technical, automatically switch to shorter, more direct responses. This is about how to do something, right? How to implement a certain procedure. So it's procedural. On February 18th, the user asked about pricing for the enterprise plan. What about this? Is this episodic or semantic? This is again a little bit confusing because here is the question about, is it about the fact that user asked something, or is it about the fact that um, um, user had made a request regarding pricing for enterprise plan? So this is a bit confusing. Let's try with episodic. So episodic, it's like what happened. So user asked about something, that is what happened. The project deadline is Q2 2026. What about this? This is a knowledge. This is what I know about the project. So this should be semantic. When the user asks for a code, always include unit tests along with implementation. This is again regarding how to implement something. So this is sort of the memory sort of procedural, how to do. The user decided to switch from MongoDB to PostgreSQL after comparing query performance. So this is not about an incident, right? This is about, I don't think this is episodic. I think this might be semantic. I might be wrong. I'm also equally confused whether this belongs to episodic or semantic. Let me think about it once more. It's about user's decision. User decided to switch from MongoDB to PostgreSQL after comparing query performance. It's about an event. Or is it about what happened? User decided to switch. I'll go with what most of you are saying. Most of you are saying it's episodic, right? Let's see. Okay. This is because it's about a user's decision. It's not about the knowledge that user prefers PostgreSQL over. It's not about the knowledge that user prefers PostgreSQL over MongoDB. It's just that in that moment, user made a decision. API rate limit is set to 100 requests per minute per user. This is about knowledge. Then for this user, use markdown tables instead of bullet lists when comparing options. Is this procedural or semantic? This is about when you are doing something, do this, right? So when you are following a procedure, do this. During the sprint review, the team agreed to delay the payment feature by 2 weeks. What about this? So it feels like it's episodic. Then the user's email is jordan at thisthing.io and they work in the Pacific time zone. This is about the knowledge. Then two more questions. 3 sessions ago, we refactored the auth mode module to use JWT refresh tokens. Episodic. Then before suggesting database schema changes, always ask if migration need to be backward compatible. This is again how to do something, procedural. And last one, company uses AWS for all cloud infrastructure. This is about knowledge. So it is semantic, right? All right. Fairly straightforward. Not fairly straightforward, mostly straightforward. Some of them might be confusing. Let's look at one more thing about memory assembly, like how the memory gets assembled from different. Yeah, very good question. Where there is no user interaction, how the memory is used in agentic application when there is no user interaction. In fact, most of the coding agents are like that only, right? Coding agents have, so Claude Code has to decide by itself, not just based on conversation, but based on other file structure, how to assemble the memory. So let's try a simple, quick exercise on assembling the memory. First is what aspects of the memory is hot, what is warm, what is cold is decided by Claude Code itself because of it has intelligence, right? So now the way it works is you have a token context budget just for memory, and from this the way it is added is if there is a conversational window which is stored in some format, it can be stored in a JSON format, it can be stored in a Markdown format. Cloud Code will decide to add this to the current context window. So here is where the LLM smartness is coming, because Cloud Code. So this LLM context window is different from the context that the agent is using. See, when Cloud Code or any other coding agent is implementing its decisions, it has multiple context window. It will have its own context window to decide whether which files are relevant for the main context window. The main context window will include all the information regarding what the main task is. So if the main task is to produce a response based on all the available context, then that main context window should only be populated with what is relevant. The purpose of the other API calls is probably to decide which among these files should be part of your memory to be passed into the LLM's context. So here, conversation window is added. Then this is the episodic memory. So there are conversations which are or episodes that have happened in the last week and last to last week in the format of JSON. So 150 plus around 100 tokens, so 254 tokens. Then semantic memory, this is about the user profile. So user profile will be stored in some format. So semantic memory can be, again, in vector database format or in any other format. So if an LLM made the compression into a JSON format, it could be in the JSON format, but it can also be in a vector database format. Now I have one question, okay? If I click this, these vectors are getting added. Is the vector getting added directly like this, or is it something else? So if you have a vector document, is it directly getting added or is it something else? So here the way I'm showing it is 267 tokens corresponding to this. These two vectors are getting added. See, vectors are just numbers. If you look at a vector, it will look like an array of numbers, minus 1.2, 1.3, etc. If you just add that vector directly, it will not make any sense to the LLM. What you are actually passing is, when we say you are passing certain item from the vector database, what you are actually passing is the chunks corresponding to the vector, right? Those chunks are sentences. They are being passed. If an entire vector database is passed, it simply means the entire chunks corresponding to that database is passed. If only some vectors from the database is passed, it means only some chunks from that database is passed. So now this is how different files are assembled. And these tokens corresponding to are, now one more question, this 124 token, 267 tokens, are these the tokens corresponding to the .vec file, or are these the tokens corresponding to the chunks corresponding to the vector? They are always corresponding to the chunks corresponding to the vector. Why? Because at the end of the day, tokens are about what the LLM is seeing. If LLM is not directly seeing the vector array, if it is directly seeing the chunks, then the tokens are calculated based on the chunks, not based on the vector, the numerical vectors, right? So these are based on the chunks which are in the format of, which are in the format of natural language sentences. So, and then all these tokens will be added to contribute to the context budget. And now all these will form part of the context, and these are from the memory. For the question in this exercise, do we need all these contexts? For this one, yeah, I mean, it is constructed in such a way that we have to select everything to construct a really, really good context to get an answer. I did not walk through the question. I just wanted to show you, if you had a certain folder structure or file structure, how are things assembled to be part of the context? At the end of the day, context is about concatenation of different items in natural language to be passed. Here, one token is not equal to one chunk. One chunk is equal to multiple sentences. Multiple sentences equal to multiple words. One word can be one token or multiple tokens. So here, if there are 124 tokens, it doesn't mean there are 124 chunks. It means there are some sentences in which maybe, let's say, on an average, each sentence is 10 words, which roughly approximates to 10 tokens. There are around 12-ish sentences here. There are around 26-ish sentences here corresponding to all the chunks that are passed here. But one chunk is not equal to one token. Typically, one chunk is a longer sentence. Otherwise, it doesn't make sense to just store one word as one vector, right? Because one word does not carry too much semantic meaning, but a sentence carries a lot of meaning. So usually chunks are multiple sentences converted into one vector using sentence transformer or similar vector embedding models. Okay, so this also we have covered. I have a few more questions to ask you in the form of quiz. So let's go there. Okay, so let's go through a few questions just to test your understanding so far. Why do LLMs need an external memory system? You can just say ABCD. The LLMs need external memory because LLMs have no state. The API, each API call is unique, right? So LLMs are stateless. That's the reason. Then, what happens when a multi-session agent has no memory? So what happens is if this agent has no memory and if it is configured to ask some questions while onboarding a user, it will keep on asking the same things. It will not remember anything from the past sessions. The past context is not will not be there. A user tells the agent their project deadline is Q2 2026. In session 5, the user asks, what's our deadline? But there is no memory. What does the agent do? So in this case, what does the agent reply? So what will most likely happen if it's just an agent? I mean, if it's not an LLM, if it's an agent, is because you would have put some sort of framework for agents information absorption, right? Because agent has to absorb some information, and typically agent gets information from the user. So agent is usually trained to ask questions to the user rather than directly give an answer. Unlike LLMs may directly give an answer, but even in the case where I asked what is your name to the LLM, it did not hallucinate a name and gave a random name. uh, it said that I don't know your name, right? Because it's not provided. So typically it asks for information which it does not know instead of directly hallucinating. Why does human memory differ from LLM memory in a how does human memory differ in a fundamental way? Fundamentally, does not have memory. Fundamentally, LLM has its weights and biases to produce a response during inference. So humans, however, we have persistent memory which is maintained automatically or whatnot. But LLM memory is explicitly engineered. LLM itself is like a RAM, right? It does not have storage. Which memory tier stores learned behavior rules like always include tests with code? Whenever we say always do this, always do that, it's about some implementation of procedure. So it's procedural memory. Then a user tells the agent, I prefer Python over JavaScript. This we already discussed. Which memory should this be? This is user's preference. So what should it be? Semantic memory. Then which memory best fits? 3 sessions ago, we refactored the auth into JWT refresh tokens. So this also you guys answered very nicely earlier. It's about what happened. So episode. For this user, use markdown tables instead of bullet lists when comparing options. This is best classified as dash type of memory. It might be a bit confusing, semantic versus procedural. So this is a command that is given to the LLM. So it's like when you do this, do that. When you do something else. So it's like procedure. What is the main disadvantage of windowing? Fairly straightforward. Windowing simply eliminates all the information which came in the context early. Then which memory strategy achieves the highest compression out of all the strategies we discussed? So in general, the highest compression strategy, the best compression strategy is key value extraction, because it is storing everything in just few key value pairs. Look at the key value pairs. They are just words. They will look like they are long, but it's mostly empty space. It's few words. So the number of tokens in key value pairs, although the way it is printed, it feels like there is a lot of, it occupies a lot of space. The actual number of tokens it consumes is very less. What is summary drift and why is it dangerous? Summary drift is, as we keep on summarizing, what happens to the summary or after some time. So what may happen is, after a few rounds of summarization, you will start losing information, because each summarization is loss of information, right? It's like any compression algorithm. There is always a loss of information, so it will keep accumulating. A coding assistant needs to remember project facts and specific debugging sessions. Which strategy combination is the best? So project facts will be stored as what? It's like what I know, what is the tech stack, and uh, what kind of architecture should I use, etc. So I think it is semantic chunking plus key value extraction. Then in the 3-tier storage model, hot, warm, cold storage, what does warm storage contain? So warm storage is everything about the things which LLM did very recently, not stuff in the current context window. So compressed summaries and recent history that can be quickly loaded. Then which stability tier should a temporary debugging hypothesis be assigned to? Temporary debugging hypothesis is when the agent decides to spin maybe a sub agent or something to test a temporary debugging hypothesis, perhaps. So this is, we did not explicitly discuss about stability tier, but I think it should be some sort of experimental, in the sense that debugging is almost always the moment the bug is fixed, you don't care about that, whatever debugging hypothesis is. So it's sort of experimental. You don't even have to store it the moment it is done. A memory's access count drops to 0 over 30 days. What should the decay system do? Basically, there is a concept of memory decay, in the sense like you assign lower and lower priority. An LLM or keyword based mapping will assign lower and lower priority to items that are too old, right? So what typically happens is, after 30 days, if the number of times this particular memory is accessed is 0, you can literally reduce its priority, because if something is not used in a 1 month, its priority is very low. It can be kept in cold storage. You don't have to delete it. Why should memories include a confidence score alongside the stored information? So we did not discuss the confidence score of the memory. What we discussed was the score, not the score of the memory. The relevance of the raw item is what we discussed. We never discussed once we convert it into a memory where we put a confidence score or something. So low confidence memories are useful when in some later point of time, if you are ever utilizing something from a low confidence memory, you can have a you can err on the side of caution, right? Because let's say in your memory something is stored that the user always prefers JSON format for structured documents, something like that, and then later this has changed. So if there is a low confidence memory that is referred to, that score will help the agent ask a question like, is this still true? Something like that. So But this is something which we did not discuss, so don't worry about it. ACE framework we can skip for now. The production coding agent starts giving advice that contradicts the decisions it made 3 months ago. The user is frustrated. What's the root cause? This can very much happen when you're working on something. So what happens is the files which are stored earlier, the LLM will assign, or whatever the coding agent's framework is, framework for annotating the memory, it will keep on assigning older and older ones with lesser and lesser priority. So the past documents will have lesser and lesser relevance. Cloud Code's Cloud.md is an example of which memory architecture concept. So Cloud.md is loaded in almost every single API call, if not fully, parts of it, right? So it should be something like hot storage, because it's not warm. It's working memory temporary instruction. It's not temporary at all. Cloud.md is like always, see, it's literally consisting of bunch of system prompts. So items from Cloud.md will form part of your system prompt. So Cloud.md is always loaded, not the entire file, parts of it, depending on whether you use RAG or you use keyword based matching. What is the recommended memory strategy combination for a production multi-session agent? I mean, this is very simple. I mean, when you have a production agent, you have to use um, all the tiers, episodic, semantic, and procedural. All everything will be there. Then, so it's very straightforward. In production chatbot, who or what is responsible for deciding which past messages to include in the next API call? So think about it. It's a chatbot, and in the chatbot, who will who will decide what comes into the context in the next API call? Of course, it's not user. User is not repasting or anything, because that is going to be very difficult. If I am using a chatbot of a company, LLM cannot manage its context window. Context window is managed elsewhere. API gateway, it caches recent messages and injects them transparently into each request. Or application developer, they write the code to select, compress, inject history into. So we have to, whoever is designing the system to make the API call to the LLM, we have to decide it. It's our decision, right? So we have to decide how the past messages are being passed into the LLM. It's not decided by the LLM. Um, you are building an AI tutor. Between sessions 3 and 4, the student's context window is completely cleared. What does this mean for session 4? If context window is completely cleared, there is pretty much no knowledge existing from previous sessions. If it is completely cleared, so then session 4 starts just like a fresh API call. What is the fundamental difference between context window and persistent memory? So persistent memory, context window is like short-lived. Context window, short-lived, or it's dynamic. Once it exists for one API call, so the current context window exists for one API call. For the next API call, we need to fill the context. So, but persistent memory is depending on external actual stored files. Jordan told the agent, my company uses monorepo setup. Then 3 months later, the agent recommends setting up a separate standalone repo. What type of memory failure has caused this? So this is some sort of knowledge, right? So my company uses monorepo setup with this is like it's like a knowledge. So it's not about implementation. The agent recommends setting up a. So I think it's a failure of semantic memory failure because it's about knowledge. Then an agent observes that the user always asks to explain like I am 5 year old whenever they are confused. Should this be stored as episode or procedural memory and why? It's about procedure. When an LLM produces a response, when you are doing this, do like this, right? So it is about procedure. Then the minimum viable prototype deadline is March 30, 2026. Which memory tier should store this fact and why? So this is semantic because it's about, oh, this is not semantic. MVP, I think this is semantic. It's not about, uh, wow, which memory tier should this store? I think it's semantic because this has not yet happened. I'm just confused because this is too crystal clear instruction. Okay, this is the deadline. I think it should be semantic. This might be a mistake. Then let's go to the next one. You compress a 30 turn conversation into 3 sentences. The user asks, "Why did we choose TRPC over REST?" The agent says, It doesn't know what happened." So summarizer usually, as you know, it keeps facts, it keeps uh, solid quantitative things, but not the why behind certain decisions. KV store has auth clerk. The user says, "I'm considering switching to auth.js. What do you think?" The agent enthusiastically agrees without hesitation. What went wrong? KV store has no context. Then priority pruning drops all turns scored below 3. A turn scores 2 and says, "Quick side note. The client is based in Germany, so we'll need GDPR compliance. What is the consequence?" So what may happen is just because the user said it's a quick side note, maybe the LLM or keyword based matching might have given it a low score, and because of it, priority pruning will drop it. In priority pruning, low score items are dropped. But the problem is GDPR compliance is very important. So maybe this constraint is lost just because we in the pruning it got dropped. A memory user prefers Vim key bindings hasn't been accessed in 6 months. The DK system triggers. What's the best action? Move it to the cold storage and no need to delete it. Then semantic memory says users prefer PostgreSQL. A new session contains I have migrated everything to MongoDB last month. What should the memory system do? This is a little bit confusing, right? Should we keep the PostgreSQL semantic memory, or because this episode has happened, should we also update semantic store? I think we should keep the older preference, but still update the semantic store. That is what I would do. because otherwise there will be again conflict later. If one part of memory says user prefers PostgreSQL, the other part says factually that MongoDB is what is being used right now. In the hot, warm, cold storage, which of the following belongs in the cold storage? This belongs in the cold storage. It's too old. It's not deleted, but it will be in some sort of markdown files or txt files or JSON files, which are barely referred to. This we can skip. After deploying a production agent, users report it keeps recommending add an index to the users table even after they have already done it. What's likely the memory failure? Basically, there is no memory which says something was already done, and because of that, LLM will keep on referring to the same thing again and again. Why is a well-engineered memory system considered a competitive moat for AI products? I mean, this is more like a qualitative question. The main thing is that, see, why do we care about AI, chatbot, and all? It's like highly scalable and highly personalizable. So if something is highly personalized, it means it has a strong memory behind it. It knows the user preference in and out. So you have to be able to somehow store the user preferences to be utilized. We will do this when we are building the application 2 days from now, 2 days or on weekend. I'll confirm it in some time. But this is about memory. You should know how to explicitly give instructions to the LLM. We will explore that a little bit in the building stage, but we should give explicit instruction to the LLM, how to store, in what format to store, where to store, etc. If you are utilizing coding agents, not LLM, I meant coding agents. If you are using Cloud Code inherently does bunch of these things without you having to explicitly define it. Okay, based on query, how does the agent decide whether to retrieve information from episodic or procedural memory? Does it perform this retrieval for every query? Yeah, so in coding agents like Cloud Code, in every single call that you are making or every single action that you are taking, things are coming into the context from various different places. Some are coming from memory, some are coming from the immediate user instruction. So Cloud Code, through its API call, a separate API call, it can decide from where to query the latest information to be passed into the context. So whenever you think of Cloud Code, you should not say, okay, I am using Cloud Code, which is making one API call to Opus 4.6 to implement this task. It's not like that. It has multiple agents. Some agents are good at handling file system on your local computer. So if you ask it to create a file or delete something, move things, rearrange it, it's good at doing that. And how do you do it? It has access to maybe your file system MCP. It also has access to LLM. So there, one set of LLM API calls are being handled. Another set of calls this Cloud Code might be making to fetch the relevant information from the memory. And then finally, all of this will be compiled into your final or your main task API call. So if the main task is to reply to your user or to implement a certain line of code, for that, the LLM would fetch the information using other set of API calls, fetch the information and pass it to the context. So it's like Claude codes or codex operation is like a series, not series. It's like bunch of LLM calls happen in parallel towards constructing your context window for your main API call, right? So we'll wind up today's lecture here. Tomorrow we'll come back and see some sort of patterns that we have to follow in production. I have uploaded the yesterday's lecture, but it will be live by only today 3 p.m. IST. So it will be available at that time. And please get ready for the implementation session. So I have discussed the dates of implementation for Dr. Raj and Rijit's session. So I'll upload that in the portal. Then second thing is, please be ready with some sort of coding setup. So please install Visual Studio Code. That's the first thing. I will put all the prerequisites. So just be ready with it. And if you can manage, I would highly recommend at least for 1 month. This 1 month, just take Cloud Code subscription once. There is a separate course on modern software development where Cloud Code will be extensively used, but in our build sessions also we'll be using Cloud Code extensively. So at least for 1 month, if you can just take the Cloud subscription, so that the pro subscription, so that you can use Cloud Code. It will truly change your life. Once you use it, I think if you use it seriously, you will get addicted. It's very empowering. The dates I will upload on the portal. I'll let you know. So we'll meet again tomorrow, same time, 9:30 a.m. Thank you so much, everyone. Implementation session. So this course has 3 implementation sessions. One will be handled by me, one by Raj, and one by Rajat. So that will be separate. But other than that, there is a separate course of for 5 days, which Dr. Raj is handling. It's called Modern Software Engineering. This is the link. So this will start next Monday. It will run till Friday. So it will happen around the same time, I think slightly earlier, 9 a.m. to 11 a.m. IST or something like that. So just check this link. So in this, it will be purely building, like you will be entirely building various applications using Cloud Code framework. You will learn how we internally use the framework for building initial document files, initial instructions for Cloud Code for building proper softwares. Put coding session class with the software course. There will be separate coding sessions. Yeah. Is there a free version for modern software developer course? I don't see. I'm not sure if it exists or not. I'm not 100% sure. Probably it's not there. All right, guys. Let's meet again next tomorrow, and then tomorrow I'll let you know regarding the schedule for my build session as well as Raj and Rajat's build session for this course. Thank you so much. Take care. See you tomorrow. So today's lecture is about setting up a very nice workflow for everyone, so that in future, whatever you are building, this workflow can be utilized. You can, of course, modify and you can identify a workflow that works really well for you. But today, what I'm going to teach is my own workflow, which I use for building any sort of projects. So in today's lecture, it will be an overall, we won't be building anything complex yet from scratch. That we are reserving for the next lecture, where it will be purely building. But today's lecture will set up the prerequisites for that in terms of what the workflow can look like when you are building. So these are the items that we'll be discussing today. First is setting up Cloud Code itself, which I'm assuming that many of you might have tried, some of you might not have tried. So it's depending on what platform you use. I primarily use Cloud Code. So when I'm talking about my workflow, I'll be talking about it from the perspective of a Cloud Code user. I will also go into a little bit of detail about the CCO GitHub. CCO GitHub I had shown briefly in one of the first or second lectures, but today I'll talk about why do we need it and how it is helpful. For setting up a workflow in a remote instance, I will talk a little bit about how can you set up your own AWS EC2 instance. This will help you tremendously control whatever you are building remotely. You don't have to be sitting in front of a computer. I'll also discuss briefly about how to control your EC2 instance from your computer using VS Code SSH extension. I'm sure many of you are familiar about this, but let's discuss through the entire workflow once, where all of these tools are involved. Then I will also discuss about how to install OpenClaw and how to use OpenClaw for kind of orchestrating what Cloud Code is already able to automate to a great extent. Then I'll talk about how to use Telegram, so that from Telegram app on your mobile phone, you can control whatever is happening with the help of OpenClaw on your AWS EC2 instance. This will give you a lot of freedom to sort of give feedback and let things happen overnight, even when you are sleeping. So it's as if you are hiring a worker or something for you, where even when you sleep, that worker does not sleep. We'll discuss a little bit about tmux for terminal multiplexer. Basically, from the same terminal, you can operate multiple terminal, you can open multiple terminal sessions. This will also help you conduct some parallel workflows if your computer has decent RAM and decent computing. And then we'll talk a bit about /commands/skills and how can you set up your own custom commands Custom commands are where you can automate a repeating operation which you may want to do in your project again and again. And this operation, whatever it is, you define in a markdown file and you can convert it into a custom command. So we'll discuss that. And global versus local skills. So global versus local skills are user level skills that are global, irrespective of what you as a user you are building. Global skills will be applied. Local skills will be applied at a project level. So a same user might have 10 different projects. Some skills the user requires are global. It applies for all the projects. Some skills are local. It applies only for specific projects. So we'll discuss that. Yeah, so we'll also talk about adding API keys where we can provide. Those parts are now very easy. So CCO, if CCO is constantly asking you to log in, it won't ask you constantly to log in, but next day it will ask you to log in. If one day the session has timed out or something, next day it will ask you to log in. So in my experience, whenever I use CCO or whenever I use Cloud Code, I have to log in once in a day, which is not much big of a deal. So first is we can start with Cloud Code itself. The installation part is fairly straightforward. So, okay, there is also a question, is CCO safe to use since it's a third-party GitHub repo? Yeah. So I don't use CCO primarily on my computer that much. Sometimes I use, of course, but I have almost always used it on my EC2 instance where I don't have any sort of personal stuff there except for API keys. And API keys anyway I have good control over. So I'm not too much worried about giving CCO access to my AWS EC2 instance. I am a little bit concerned about yes, we will discuss what CCO is. Let's go step by step. All right, so let's start with Cloud Code. So for those of you who have not installed Cloud Code, just search Cloud Code and then its documentation website will come. But then this is the primary website. Just go to cloud.ai, not cloud.ai, code.cloud.ai. So code.cloud.com. Just use this. And regarding the next lecture will not be tomorrow. Next lecture will be on Saturday. Start timing is either 9 a.m. or 9:30 a.m. I'm yet to finalize it. I'll let you guys know. So the build session, which was supposed to happen tomorrow, will be happening on Saturday. Then there are 2 more build sessions with Dr. Raj and Rajat. I have made an announcement regarding the timing for that also. So to install Cloud Code, all you need to do is like run this on your terminal. The command will vary slightly depending on whether you use Mac OS or Windows, but you can find the command from the Cloud Code website. So just go to this and just install it using your terminal. This will take you hardly 5 minutes. All right. Now, one thing Cloud Code does is it is a very good coding agent, right? So it has access to different LLMs built by Anthropic. But at the end of the day, Cloud Code is an coding agent which has access to different large language models built by Anthropic. So what it does is if you are, let's say, building something which involves making changes in your root folder or working directory, it will almost always will keep on asking you permission to do something. And then you have to give permission by saying yes or no, or you have to say, yes, it's okay for this session. And that is a little bit annoying because it will make you sit in front of your computer throughout the building process because you don't know when your agent is going to ask you a question and you have to sit. Question regarding permission, you have to sit. So CCO, this is definitely not built by official, Claude or any other team, but this is from a third party. But what they have built is it allows you to run Cloud Code with this dangerously skip permissions option, but at the same time, containerizing it such that the environment in which agent is running is kind of safe. Now, I personally am not vouching for the safety of this or anything because I have no idea. And I have been using this maybe for the last 5-6-ish weeks, mostly for projects where I'm not exposing too much of my personal data. But this is the GitHub repo of CCO. To install CCO, you can just scroll down and here is this command. So just copy this command and run it on your terminal. I have noticed that some Windows users have found some hiccups while installing this. I mean, of course, the command is different for Windows, but I have noticed that there is some hiccup associated with it. For Mac users, I have not seen any issue being encountered. But you can, I mean, for today's purpose, you can still run your building process without CCO. And if you have OpenClaw can take care of continuously monitoring Cloud Code, and it can keep giving permissions to Cloud Code. So that is one reason why I'm also going to talk about OpenClaw today. The second thing is, where do you want to run your building? Where are you going to run your code, or in which computer are you going to give your coding agent or your OpenClaw agent access? You might have seen many people purchasing Mac Mini. So Mac Mini is just this piece of computer, which is slightly less expensive than MacBook Pro. So it just comes just as a box. And if you want, you can connect a monitor to it. If you don't want, if you just want to use it as a remote computer on which you want everything to run, so that you are not exposing anything personal, you start with a fresh computer. And the only purpose for this is to act as your coding agent and your personalized agent. You can do that. So this is one option. The problem that I find with Mac Mini is that you have to make sure that it is plugged in always. If there is any power disruption or anything like that, it's going to shut down, and then you have to figure out rebooting it and stuff like that. In my mind, the quickest solution is going with an Amazon AWS EC2 instance. So EC2 instance is nothing but, Amazon allows you to create virtual computers. For those of you who don't know, I'm sure most of you know what it is, but Amazon allows you to create virtual computers which are run on the cloud. So you don't have to maintain it. It can be technically on 24/7, and there is no constraint with respect to physical hardware. And purchasing this is almost instantaneous. You just go to AWS website and purchase it, or you also pay based on the usage. It's not like you purchase an entire computer or something like that. You pay per use. And also the other good thing is you can go from very low end to very high end. Yeah, you can go with Azure or GCP. Anything does not matter. I mean, at the end of the day, it's all the same. But I use Amazon AWS, and we have to talk about one thing, right? So that's the reason. But if you prefer Azure or GCP, go ahead. No worries. Anything is fine. But at the end of the day, I find having a remote computer remote computer on cloud better than having a physical hardware like Mac Mini. Maybe if I feel the need for running some robot inferencing, so we are training some robotic hardware kit where inference has to run a little bit fast. And I have noticed that there, if we use SSH to connect our local computer or this particular hardware into, let's say, run pod GPU and communicate back, that SSH tunneling causes a little bit of delay. So I don't want, for robotics inferencing, I don't necessarily want the computation to happen on a remote server because it causes a lot of delay. Inference needs to be fast. In that case, I can make use of Mac Mini. So that's the only case in which I feel like I may end up buying a Mac Mini. Other than that, I prefer a cloud virtual machine. So let's see how to set up a AWS EC2 instance. This to reach a level where you can see this dashboard, you will have to first fill your information. They might ask for some details because we have a company account. They were asking for our, I think, company PAN card or something like that. But I'm not sure if for you are taking it on an individual capacity, whether they will ask that or not. So for us, this took me about 5 minutes to set up. Just search AWS or GCP or Azure on Google, and then just follow the instructions that their website gives. Basically, the goal is set up any kind of virtual machine to which you can connect your computer, right? So that you can command it from your computer, and then later everything can be run on that local machine. So in EC2, the easiest way to do that is just from this page, give whatever name and decide the operating system. I almost always go with Ubuntu. I think this is well maintained and it's very, very reliable. So go with Ubuntu operating system. And here is the instance type, which shows you what kind of memory, what kind of storage, etc. you get. So there are actually many variants here. You might even get confused. If you start scrolling down, you will see that there are endless options, starting from low pricing to high pricing. For my current EC2 instance, I have taken one with 32 gigabytes of RAM. And storage, I forgot actually, it's not that high. Storage, I don't need anyway that much. So, but I forgot which name, what the name was. But what you can do is you can just click here, compare instance types, and then a table will show up with the memory and the pricing. The pricing is per usage. Okay, I don't think the pricing is shown in this table. But the best thing to find what instance fits your particular use case is just ask ChatGPT or Claude or Gemini itself that this is my requirement and these are the kind of projects that I'm going to run. If it is a very lightweight agent, maybe 1 gigabytes of RAM or 2 GB of RAM might be sufficient. In my case, I was pretty sure from my past experience that even 8 GB is not sufficient. So I went with 32 gigabytes of RAM. I did not go with T2 2X large. It was something else. I can check the name because in all of these different variants, there are different RAMs, and I'm sure the processor is also different. So this is something which you can experiment and figure out because closing an instance once it is created is not a difficult thing. If you don't want it, you can terminate it and close it, so it's not charging you anymore. In any case, if you go with the lowest one, even T2 Micro, my understanding is that AWS gives you 750 free hours or something. So AWS T2 Micro free usage. Micro free tier offers up to 750 hours per month for Linux or Windows. Okay, for Ubuntu, I'm not sure whether this applies or not. But the point being, without spending any money from your pocket, you can get started. And then when you are launching the instance, let me go back. Okay, this is my current instance which is running. And yeah, so this is the instance type which I have used, C5.4X large. I'll just paste the name here. But let me just launch a new one. I'll just show you the full process. And I will go with T3 Micro. It's very cheap relatively. And here they will ask for a key pair. So key pair, we can just ask it to create a new key pair. And my screen is freezing a little bit, but yeah. And it will allow you to download a file called .pem file, .pem. It's a file in which there will be some sort of key or token, which will allow you to connect your local computer to AWS. So here, let me just name it as something. So it will get automatically downloaded. So the most recommended practice is this .pem file because it is containing the key to access your EC2 instance remotely. Just store it somewhere else also, apart from your downloads. Right now, it is there in my downloads. I'll show you where to use it. One more information that you would need is, okay, this you can keep allow SSH traffic from anywhere for the time being, and later you can change if you want. Rest of the things I'll keep as such. So 8 gigabytes of storage, which is more than enough for now. And number of instances, 1. And here, one more thing is this location. So location I had changed to Asia Pacific Mumbai because because I am situated near Mumbai right now. It's better if I have something which is from here, but depending on your location, choose your location to launch the instance from, and then just click launch instance. And this will hardly take like 2 or 3 or 4 minutes. Okay, so the instance is launched and you can see that over here. Just click this instances and you will see both of the instance. So I should have now 2 instances, one which I already had and one which I just created. I chose 8 gigabytes at the end. I chose whatever was default. Actually, if you guys want to do something serious, my recommendation is go with at least 16 gigabytes of RAM and some storage. 8 gigabytes, it's too less, right? So just go with something higher. Here I'm just using it for demonstration purpose. The one which is named as Visuara, I have I think good enough storage and 32 gigabytes of RAM. Anyways, and then yeah. So CCO, I'm yet to come to CCO in detail, but basically CCO, it's when you run Cloud Code will keep asking you permission to execute actions because it is making changes in your folder structure. It is probably accessing something which, unless your permission is there, it should not automatically access. But you can run Cloud Code with a command called dangerously skip permissions. It's not related to CCO at all. It is already there in Cloud Code. But then when you do that, you want to make sure that Cloud Code is only able to access something in a containerized environment. Without going into detail of that, CCO basically provides you some sort of containerized environment, which is a bare level of protection so that Cloud Code will not access something which is outside of your working directory or something like that, unless you explicitly say otherwise. Plus, you can keep running it without having to encounter asking of permission each and every 2 minutes. So this basically makes your workflow much faster. But as we discussed, CCO is something which is created by third party. But until if there is any official implementation of something similar, you can try this on your EC2 instance or on your remote system. But on your personal computer, it's your choice. I have installed it right now to show a few things, but I don't extensively use it. All right. So now let me see if my new EC2 instance is ready or not. Okay, it says it's initializing, so maybe it will take some time. Now let's discuss how to connect your local computer Visual Studio Code to your AWS EC2 instance. So first thing, what we need is, so this is my local computer. What you see right now, the folder name, the working folder directory name is called setting up remote EC2. This is on my computer. Okay. This one, on the other hand, which is saying workflow demo. And here you can see an SSH with an IP. This is on AWS EC2 instance, which I already had, not the new one, the one which I already had. So let me not show you this directly. Let me go back to my VS Code. So right now, this VS Code, let's see how to connect this to my latest, the EC2 instance, which I just created. So first thing what I need here is the .pem file. So I had downloaded it into my downloads folder. So let me just find the .pem file. So this is my PEM file, and where is my folder setting up remote EC2? So find your working directory and just put your PEM file there. Of course, this is not the ideal practice. There are better ways in which PM can be managed, but since this is my computer, nobody is going to access this file. Now, if you have installed CCO, what you can do is this is your terminal, right? So on VS Code, on the left-hand side, you can see all the folders in your current working directory. If you don't know what is your current working directory, just type pwd. It will show the full path. So pwd stands for present working directory. So this is my full path. So this is my present working directory, which is same as this folder, setting up remote EC2. Now, one thing you might want to install is go to extensions in VS Code. So this is the extensions icon, and search for remote EC2. Not remote EC2, remote SSH. So this is from Microsoft, and this is an extension which will allow you to connect to your EC2 instance remotely from your local Visual Studio Code itself. Okay. So just install this. I have already installed this, which is why here it says uninstall or disable. It's already there in my system, but you can just click and install it in 1 minute. Then next thing is, once it is installed, you can go here and okay, let me go back to remote SSH and look at its instructions on how to connect. Okay, so here we just need to type the command. Let me enter some students from the waiting room. Yeah. Yeah, so PEM file would have been automatically downloaded to whatever is your default downloads folder from when you created the EC2 instance. So they ask for a key, right? So create the key and then give it a name. And then by default, it will have the option .pem. So you don't have to do anything extra. But then the moment you save, it will automatically download the .pem file to your computer. And then you just store it somewhere else also apart from your downloads because you might need it later. Okay, so here what I need to do is like search remote SSH. So what you need to do is go to your this top search bar on the VS Code. And when you click it, you will see an option called show and run commands, or you can use the shortcut command shift P. So then it will enter this mode and there you should see remote SSH connect to host, or you can just manually type it. If you don't see it, just type remote SSH connect to host. I'll just paste this command on chat. And then here you will see the host IP. This is because I had already connected to this remote EC2 instance before. But if you want to configure something new, just click here, add new SSH host. One thing we can do here, which will make our life so much more easier, is CCO. So yeah, so one more thing. Now we are entering Cloud Code. So just go to the terminal below. So to open the terminal on Mac, the command is command plus J. So if you press command J, it will open. If you press again, it will close. Okay. So just type either Claude. If you type Claude and press enter, it will open Cloud Code if it is installed already. But then Cloud Code will be opened in the normal mode where it will keep on asking you permissions. So if you want to skip the permissions, what you can do is, so I'm exiting it. And instead of typing Claude on your terminal, just type CCO. So now Cloud Code will be open, but with dangerously skip permissions enabled, but also containerized in a containerized environment. Now here we can ask Cloud Code to set up the remote SSH connection. So connect to my remote EC2 instance that I have recently created. The PEM file is pasted in the working directory. Then Claude will also ask you for the most likely the public IP. So let me just check what is the status of this by refreshing. So Claude on the remote, so I have not even connected to remote yet, right? So I'm about to connect to my remote. So Cloud Code right now, what I have shown is on my own computer. So Cloud Code is pretty Yeah, you should install it on the remote also for sure. Yes, you should install it on both, because at the end of the day, you're going to run Cloud Code on your remote. So I'm about to show you that. But before that, I had to make use of Cloud to, or I am making use of Cloud to connect my computer to the EC2 instance. So this is my new EC2 instance. I just click this to open and it should show me a public IP. So this I can just copy. And then most likely Cloud Code will ask it here. Key permissions are set. Once you share the IP and OS, command will be this. Okay, so then I'll say this is my public IP. And the OS that I'm using is Ubuntu. So I'll just answer that question. It's also asking if I know the username. My username is basically, I think it was just Sridath, Sridath's EC2, or I can also provide the instance ID, I guess, but let's see. Wrong username. Wrong key pair, or SSH might not be open to your IP. Check the inbound rules in the instances security group. Okay, so let me go to the security group. So that you can find here itself in this page. Go to security, and in the inbound rules, these are the inbound rules which we will have to edit. So and edit inbound rules. And I think it's already set up. So let me just make sure that this is all right. You can, so one more thing you can do in Cloud Code is you can just take a screenshot and drag and drop the screenshot here, okay, in this terminal itself, and then it will show like image one here on the top. It will show up in a moment. So see image one. So it creates a local temporary storage, and then in that storage, from that storage, this image can be accessed. So just because it is terminal, don't worry that you cannot give it visual commands. You can. This is what I see on my instance. Can Cloud Code read files present on the remote directly from my host machine? I think it can read as long as the SSH connection is set up. That's what I'm going to show you right now. Yeah, I can repeat whichever step you are at. I can just repeat what is the next step. Security looks like issue is the key pair, but I don't think key pair is wrong. I think the key pair is correct. What AMI instance is it using? Let me check. Yeah, we can provide username or even instance ID directly. Instance name is, no need to add another volume right now. It can be you know uh, whatever is the default. The Claude command to bypass permissions on is this dangerously skip permissions. It's also mentioned here, this one. So if you don't want to use CCO, you can just use this command, dangerously skip permissions. I mean, there is a reason why it's named as dangerously skip permission, because it's not the recommended practice. Okay, now select your instance detail tab, look for the key pair name field. I'll tell you which key was assigned when the instance was launched. Okay. This is the AMI name. This is the key pair. Yeah, I'm also still in the step of connecting this particular instance to uh, my VS Code. Let's see what's the issue. Oh, okay. So maybe by accident, I did not end up selecting Ubuntu as the OS. Maybe I ended up selecting Amazon Linux, which is the default now. So perhaps that was the issue. So when it asked what was my operating system, I ended up giving Ubuntu. But although I had selected Ubuntu once, when I went back and came back again, it defaulted to Amazon Linux. So that was the reason why it could not connect. Yeah, you can have just one key for all virtual machines for sure. I just created a new key just to show you the idea of using the key. Right now there is no MCP tool or anything. Right now we are just, this has got nothing to do with Cloud Code. Although I have used Cloud Code to help me with these steps, technically I can just not use Cloud Code, and this is just connecting one computer to your remote cloud computer, right? That's it. This is nothing to do with Cloud Code. Everyone has been doing this for the last many years or decades. But right now the connection is set up. There is a minor warning about hosts. The file exists in permission look. Okay. Um, Now what we need is now open the instance. Actually, if it is connected, it should show up here in the SSH command section. Let me just check. Remote. Connect to host. Add new host. And now how do I open it on my VS Code so that I can access the files on the remote instance? So whatever issues you guys are facing, different people will be facing different issues. It'll be unique. So just keep pasting the issue. Somebody will already know the solution. All right. Okay. So now Cloud Code has given me the next steps, what to do. So new SSH host, and then just paste this command. So basically, you just ask Cloud Code what is the next step, provided you have this key in the form of a PEM file. So then I just enter the command here, which Cloud Code has provided, and SSH config. So now I have been connected to the remote EC2 instance, which was just created. So the steps are very simple. Just have the PEM file in your working directory, then ask the Cloud Code to connect. All the other information that you need, Cloud Code itself will ask you. But there are more straightforward ways. If you already are familiar with using the commands, there are much more familiar ways to, easier ways to do this. So now this is my remote instance. It is getting opened up, setting up SSH host. It's taking a little bit of time. But meanwhile, now tell me, so far what I have done is the following. Let me go back to Miro. This is my computer. And this is AWS EC2. So here I install the following: Cloud Code, CCO, this was already installed. Then the extension for remote SSH. Okay, so these three things are there on my computer, and I also managed to connect through SSH with the AWS EC2 instance. But do I have Cloud Code on this yet? Not yet. I have to install it. Do I have CCO here? Not yet. So that I'm going to install. Do I have OpenClaw here? Not yet. I don't have anything set up yet. Okay, so now we can do that. Now somebody was asking, can Cloud Code, if through SSH, if the connection is made with the AWS EC2 instance, can the Cloud Code which is installed on your computer, can it make changes over here? Can it control the files here? So we can see something like that. Okay, this is getting connected. Okay, I don't know why this is taking time. In the meanwhile, I'll use the other instance. I have another instance already running. So this is my other instance. Okay. So on this instance, which I had already set up, I ran the same commands which I got from the CCO's GitHub repo and the Cloud Code landing page, which can be run on terminal to install Cloud Code and to install CCO. So when I'm using this terminal, you can assume that the Cloud Code is installed on my EC2 instance. CCO is also installed on my EC2 instance. Okay. And what you can do is, once you are connected to your instance, you will see your folder structure. So you can just see what is the present working directory. It's workflow demo. Then if you do cd ... you will go back. So this is the agents folder. If you again do cd ... you will again go back. And now these are all the folders existing on my EC2 instance now, in which I had created a folder called agents. This agents folder you can create. So now whenever you see this blue color SSH, assume that, understand that this is the instance. It's not my computer, what you're seeing. Right now, what you're seeing is the files from the, you're not seeing any file yet, but when you see, what you're seeing is the EC2 instance files. But this Visual Studio Code, where is it installed? Is it installed here or here? Can you tell me? VS Code is on my local machine. I just have VS Code on my local machine with remote SSH to connect to this, okay? So the VS Code that you are seeing is not on the AWS EC2 instance. Please understand that. So all of this, what you see, this VS Code, of course, it is on my machine. However, on the left panel, on the left panel, if you want to see any directory, just Control O and then set up the working directory. So if I search agents, I have a bunch of directories, which are like different agents that I had built. So see, these are all the different agents that I have been building. And then out of which one of the folders is this agents called agents. And then I think it was called workflow demo. So this is my working directory, and that working directory is fully empty, which is the reason why on the left-hand side, you don't see anything. If you create, you will see. Then, so what are we trying to achieve in today's session? In today's session, we are trying to achieve setting up of a specific workflow so that you can communicate with your agent to build anything, even if you are sleeping. That is the agenda of today's session. And for that, you need Cloud Code, you need a remote instance or a Mac Mini, anything. And then an ability to communicate with that through maybe your phone, right? So we first set up the EC2 instance. We connected the EC2 instance with our local machine. Now what we are going to do is we are going to install OpenClaw. So now to install OpenClaw, so my instance is this. I'll just I uninstalled OpenClaw before starting this session already, although I had it before, just to show you how to do it from scratch. So this is the OpenClaw website, openclaw.ai, and so this is the command for Mac OS or Linux. So this you can directly use here if you are using Linux. So far on this remote, so I have two remotes, right? One is which is called Visuara, which was already created. One which I just created. So one which I just created, it was taking time to load. So I decided to just close it because a lot of things are open. I don't know why it's taking time to load, or my network is slow. I don't know what the issue is. So I just closed the instance which I just created and I opened the instance. So this 3.108 250.4.3 is the instance which I already had before this lecture even started. So I just connected to it. So on that, Cloud Code and CCO were both installed. So right now, if we go back here, we are at the stage where Cloud Code is there, CCO is there. Okay. So just ignore this. But on the new EC2 instance, I did not install it yet. But anyways, I don't have to show you how to install Cloud Code and install CCO. It's just running one command. But I now the status, I have these two things. I don't have OpenClaw yet. OpenClaw, I just started installing, and then it will ask me for a few few questions, including API key, what model to use, etc. Oh, I think it defaulted to my previous settings. So let me just uninstall OpenClaw once more. I just want to show you the default settings once, just so that your usage of OpenClaw is very straightforward. So I'm just asking Cloud Code itself to remove whatever folders and preferences related to OpenClaw that is there on this computer, because I want to start from scratch. OpenClaw onboard again. Okay, okay. So OpenClaw onboard will ask me for my permissions. Is it Dishant? Will it ask me for my not permissions? Like, will it ask me for API key, and will it ask me for the which provider am I using, etc. Okay, okay, fine. You could do that. So right now I'm just removing everything with respect to OpenClaw, which was there on this computer from before, plus what I installed just now, so that I can do a fresh installation. All right, pretty much it is done. So now I'll reinstall OpenClaw. And for that, I will go back to my terminal instead of running it in cloud. So /exit. Yeah. So right now I'm just about to install OpenClaw. So open the terminal, just paste the command which you get from the OpenClaw website. So this command I got from openclaw.ai. So just go to that website and it will give you the command. Just run it here. Okay, so now these are the defaults. Okay, I understand this is personal by default and share. So continue, yes. Then onboarding mode, quick start and manual. We can do quick start. Later things, if anything else is to be set up, we can do that later. Model/auth provider. Actually, here I will go with Google because I have Gemini API. I can use that. OpenAI is also there. Anything is fine, but let me go with Google for now. Then Google Gemini API, that is the auth method. Paste the API key now because I have the API key handy. This you can set up later also, but I hope that by now you have one of the API keys. So my API key is um, and I don't want Gemini 3.1 Pro preview because this is extremely expensive model. I don't want it at all. I would rather use Gemini 2.5 Flash or even 2.5 Flash Lite. But this is what I want to be my default model, because if you keep this current the default option, which is thrown by OpenClaw for Gemini, it will be like in no time you will end up acquiring $9, $10 of bill. Then bot. Okay, so this is one thing which many of you might have questioned. You might have seen people connect Telegram to OpenClaw. For OpenClaw, OpenAI, which you're asking Dishant regarding the model? Model, it can be for GPT-4o mini or any model which is, so for now, this is just for demonstration purpose. You can change the model later if you want. So anything which is less expensive, go with that. 4o mini or turbo, any option is fine. Don't go with the highest model. The next thing is Telegram. So the good thing about connecting with Telegram is that Telegram has a lot of inbuilt provisions to create bots. So it's a very nice platform, better than Slack or WhatsApp, to communicate with your EC2 instance. I mean, communicate with OpenClaw and that thereby communicating with EC2 instance. So let's go with Telegram. I will show you the setup in a moment. Then how do you want to provide this Telegram bot token? Enter the Telegram bot token or use external secret provider. So here I can say enter Telegram bot token. Then what we want to do is in Telegram, we have to set up the bot. So in OpenClaw, when you're trying to connect it with Telegram, you have to first have a bot in Telegram. So what you need to do is open Telegram. You should have an account. You have to create it with your phone number. I think email is not needed, just phone number. And then you can search here for bot father. Then this will show up. So this is the official bot father account. And here you can type like /new bot. So I know that I'm going a little bit fast. There are a few commands, but if I will repeat it, if you want me to say that again, otherwise I'll be waiting for everyone to finish and the lecture will go on for 5 hours. But the command is just /new bot in bot father. So first you will have to connect your connect your phone number with Telegram so that you can have a Telegram account. Telegram can be operated. The good thing is on phone, on the app, as well as on your desktop. So this, on Chrome. So you will, I think, for you to connect Telegram with your computer, you will have to first install the app, if I'm not wrong. Then Telegram is asking, all right, a new bot, how are we going to call it? Please choose a name for your bot. So here I can call it as test claw. test claw or something. Maybe it will have to end with bot. Okay, so test claw bot. Oh, this is already taken. So see that test claw bot. Then it'll give me an access token. Just copy that and paste that access token over here. And of course, I'll be destroying this later. Then search provider, for structured result, I can go with Gemini and Google search instead of Brave search. So we are now continuing with the rest of the configurations of OpenClaw. Then Gemini API key for search. For this, I can use the same API key which I used before. So configure skills now. I can configure the skills later. So I'm just going with no. Enable hooks. This also I will skip this, and this can be done later. Maybe session memory I can enable. So to enable it, just select it and press spacebar key. Command logger, bootstrap extra file, boot md. Sure, maybe I can do boot md also. Skip for now. Actually, I entirely skipped it. That's what it happened. So search is, I think, when there is search. So Brave search, I know that Brave search API helps us find results similar to Google search. I just don't know why they don't simply say Google search. Why we are asked to provide Gemini API key? I'm not 100% sure. Okay, now here is the other important thing. Okay, so this step is very important. How do you want to hatch your bot? So this is like, how would you want to control it? So although they are recommending it in terminal UI, I prefer the web UI. So this web UI is much better. I will show you how it works. So just go with this, open the web UI option. Onboarding complete, use the dashboard link above to control OpenClaw. So now the OpenClaw, setup process is complete. Now what we can do is, if you want to open OpenClaw, you can just type OpenClaw space dashboard. And then it will throw a localhost link, okay, with the access token. And when you click it, it will open the OpenClaw chat dashboard, chat plus many other configurations. It will show you everything. So let me just go to bright mode so that you can see better. So now here, I don't have the, I don't think the Telegram bot is set up yet. Let me just check. So I just created a bot called Sridhar test claw bot, right? So to communicate with it, you just need to search test claw bot. I did not include any skills actually. I went with default. Then no message. So this is my test bot which I just created. So I need to start communicating with the bot. The bot setup is not yet done. So OpenClaw access not configured. So the bot is still not connected with OpenClaw. So ask the bot owner to approve with OpenClaw pairing approve Telegram. So I can just copy this, then go back to terminal and then run it. So this will pair the Telegram bot with my OpenClaw on the remote EC2 instance. So approve Telegram sender this. So now Telegram should be connected to OpenClaw. So let me just check this. Are you now connected? I just came online. Who am I? Who are you? So now the connection is fully done. So now where we are at is the following. We installed, we had AWS EC2. Then we installed OpenClaw on that. Then we installed Telegram. We connected Telegram. Yeah, I will show once again. Yes. I'll just repeat what I just did once more. Okay. How do you use the key to connect to the virtual machine? Yes. So I'll go one or few steps behind. So the key was here on Visual Studio Code. This is my working directory. I just pasted the pem.pem file here. Okay. And then I opened Cloud Code and I asked Cloud Code itself to perform the connection. To help with the connection in the later part of the step, also install this extension called remote SSH. So just install remote SSH. Then after that, ask Cloud Code to look for the key, .pem file in the working directory, and now connect to SSH. Then while connecting to SSH, it may ask you for what operating system you have on your EC2 instance or whatever virtual machine you are using. It will probably ask you for its name, whatever information is needed. You go to the dashboard of AWS or whichever one you're using, copy and paste provide the information to Cloud Code. And then finally, Cloud Code will provide you a command like this, SSH-I users, this. And then that you can run over here in the search bar, click show and run commands. Then if you have already installed the remote SSH extension, you will see this option, remote SSH connect to host, then add a new SSH host, and then just paste the command which Cloud Code has provided here, and then connection will automatically happen. Then after that, what I did is on the EC2 instance, I installed Cloud Code, I installed CCO, then I installed OpenClaw. In OpenClaw, in the preferences, one of the most important preferences is the last one, where instead of going with the terminal user interface, I went with the web user interface. So web user interface will open something like this. So this is now web user interface through which I can talk to my OpenClaw, which is installed on the EC2 instance. Okay. And to open it, I just ran the command OpenClaw space dashboard. So if you run this, it will show you the link with the access token. So just click this link with the access token, then it should automatically open. So for those of you who are struggling with this, just go type OpenClaw space dashboard on terminal, and then how come localhost is working? Because I think it's because of the access token. If you did not provide the access token, if you just went to this localhost, it will not work probably. But yeah, how to install OpenClaw inside VS Code. So OpenClaw, we are not installing on VS Code. OpenClaw, we are installing, we have VS Code open, but OpenClaw, we are installing from using this command. Go to OpenClaw website, copy this command, paste it in terminal, and then it will install OpenClaw automatically. I used Gemini, Google search with Gemini as the search provider. Then what else? Yeah, Telegram. So now Telegram, this is how it is done. So you have to first install Telegram on your computer or your mobile app. Then in Telegram, first you have to create a bot. The bot creation channel for Telegram is called Bot Father. So first you have to search for Bot Father. Don't mistake the spelling, B-O-T, capital F, T-H-E-R, F-A-T-H-E-R. So search on the search bar for Bot Father. You don't have to have Telegram on your computer. You can have it on your mobile phone also. There also you search for Bot Father. And inside Bot Father, search, type /new bot. Then it will ask you for a bot name. There you have to type something which ends with bot. So here I typed it as Sridhar test bot or something. So I just typed this name. Telegram says OpenClaw access not configured. Yeah, correct. So I'll come to that. So once your test bot is ready, so if Sridhar test bot is your test bot name, just copy that and search for that here. And then once that appears, this is my test bot now. It's called Sridhar test bot, or it's, I think alternate name is test claw. It will say OpenClaw access not configured, right? So from this message, look at the last line, OpenClaw pairing approve Telegram with some code. Copy that last line, go back to your instance, remote EC2 instance, find your terminal, paste it there and run it. Then OpenClaw will be connected with Telegram. So then if you just ask, are you connected? Hi, I just came online. Who are you? Who am I? Who are you? And then here you can just search. You can just ask for anything like, okay, first let me set up some things. You are my assistant called maybe Wiz. I am Sridhar. To install Cloud Code is fairly straightforward. Go to Cloud Code website. You will find the installation command. Just copy this and paste it on terminal, VS Code terminal. Then okay, so now let's go back to our Telegram. I have not used open models. Yeah, that's something which I want to try. Yeah. All right. So I'm Viz, your assistant. Good to meet you. Help me understand myself better. How can I best assist you? Assist you? Could you tell me a bit about my vibe? Then I will say, you are my assist. You will help me to control Cloud Code for building. You will never build anything directly, but you will act as the orchestrator. So this same now to communicate with my EC2 instance, I hope you understand what the beauty of this is. The beauty of this is I have the same Telegram app on my mobile phone. Let me just open it. See, I have the same Telegram app on my on my phone, and I can literally now control my EC2 instance over here, right? How did you open dashboard on local browser? Just type OpenClaw space dashboard, and the one with access token, the link with access token will show up. Just click the one with access token. Just the local host. This I don't think it will work. You need the access token. Now let me do one more thing. Let's go to OpenClaw. Okay, so same chat we can make here also. If I refresh. So here you will see two things in this. The main is this using OpenClaw using Chrome GUI. This Telegram is the other channel. This channel is the channel of my communication with OpenClaw through Telegram, right? So here it is on the main. And here you can see in overview, what is the cost so far? See, so far my cost has been $0.03. 95K tokens have been consumed. So let me chat and ask a few things. Instead of Telegram, I'll go with the main channel. Tell me what is your default model. OpenClaw dashboard command I ran on my remote. So now I'm not touching my local VS Code. I'm only running it in EC2 instance. Everything is now in the EC2 instance. So my default model is Gemini 2.5 Flash. Can you tell me the cost? Yeah, can I directly provide instructions from OpenClaw dashboard as well? When you say OpenClaw dashboard, you mean this one? Is this the OpenClaw dashboard? Yeah. Can anyone, if you know the solution, can you help Satyajit with where he is stuck at? I'll appreciate it, because if I pause it right now, I will have to come back to this all over again. But yeah, so basically this is there are actually three ways in which you can communicate with OpenClaw. One is from this terminal itself. Here you can type OpenClaw space. It has bunch of commands, so you can follow that. But that is not very straightforward, right? That is very difficult. The other thing is you can run it on, if you are sitting in front of your computer and if you want to operate OpenClaw, the best thing to do is try, the Chrome GUI. That is the second best thing. I mean, second best thing. The first best thing, if you are completely away from your computer, if you don't want to touch, open your laptop, you are about to sleep, and you want to give some commands to OpenClaw, the best thing is Telegram app on your phone, right? So that is the beauty of this. Now, let me ask OpenClaw a question. Okay, first of all, can you tell me the cost per 100K tokens? So it will show you the real-time token consumption. It's very, very expensive actually. See, such simple questions are costing so many tokens. I cannot provide directly. I recommend checking. No, you can provide. You can provide the approximate cost. So you see this token count, just keep track of it. Okay. So even for simple questions, I'm encountering a lot of token cost. So from 11.3K, this simple search cost me around 1,000 tokens. So 1,000 tokens is, 1/100th of $0.03. So my cost for asking this question was 0. And there are some output tokens also. So probably it would be on the order of somewhere between $0.02 and $0.0003. My cost was somewhere between that for my just this one question. Then now what we can do is ask it one more question. I want to start a process and not sit in front of computer. Can you control cloud code, and can I switch off my laptop and go away? So basically, this I know it works, but I'm just asking OpenClaw itself to give me an answer. Basically, this is the issue, right? I have my computer remote EC2 instances somewhere else, and I want to be able to switch off my laptop and go away. And if there is anything, I want OpenClaw to be able to communicate with me through Telegram. And here it can definitely allow me to do that. Now, for those of you who are really concerned with OpenClaw, yeah, are these tokens built to Gemini account? Did you provide login or provide? I provided the API key. It is, yes, it is charged with the Gemini API. So here you can see the overview. The charge so far which I incurred is $0.064 for just this whatever I asked so far. And that is because of Gemini. I'm using Gemini 2.5 Flash. If this was Gemini 3.0 Pro, this would have been like $2 or something, because it's like so expensive. Now, one more thing. What if you don't want to use OpenClaw? You still want to, you don't want to control anything remotely, but this is your requirement. You want to run some building session, let's say auto research by Andre Karpathy or something, which will automatically perform everything. So when I recently ran the auto research, I did not use OpenClaw. So let's say you want to run something continuously on Cloud Code by providing the instruction that unless I explicitly ask you to stop, don't stop. Now the problem is this you are running on your EC2 instance. And the moment you disconnect your terminal, this process stops, right? And let's say you are not comfortable installing OpenClaw. Then what is the solution? The solution is something called TMUX, TMUX or Terminal Multiplexer. So TMUX, I'll show you how to use that. So all you need to do is, let me search what is the TMUX activate command. TMUX command in Linux. Yeah. So my question is, let's say you are not comfortable using OpenClaw, and you don't care about controlling what your code is doing from Telegram or something, but all you care about is the Claude code should continue building even when you go to sleep. So if you are building a very complex website and you have given detailed instructions in your markdown files, okay, or if you are running auto research, the Claude you have instructed Claude code to keep on running continuously and never stop. What is the solution? Either you run a Mac Mini and don't switch it off. You keep it in your office or wherever, and then you go home and sleep. That is one solution. But that you are relying on power outage, or not having power outage and stuff like that. But it will run. It will keep on running unless you switch it off. On a EC2 instance, right? Right now you are connected through SSH. The terminal is active. But when you close that, if by accident the terminal session got disconnected, whatever you are executing will be gone. The Cloud code will stop, and then you will have to come back and you will have to run it again. So what you can do is you can use something called tmux. So tmux stands for terminal multiplexer, and it's a very simple one-line command. I'll just show you how to do that. Yeah. So tmux. So recently, when I was running my auto research, so this is what I wanted. I wanted to work on a research problem statement on vision language action models. All right. And I asked Andre Karpathy's auto research kind of workflow. I mean, I asked it to execute a workflow like this. And all of this was done by Cloud Code. Now, the problem was I did not want this to stop. I wanted it to be completely non-stop running for 48 hours during the weekend when I'm not sitting in my computer and working. So what I did was I first ran this in a tmux terminal multiplexer session, which I will show you in a moment how to do. Then I asked Cloud Code. I connected the Cloud Code to my GitHub. This also you can easily do by constructing a GitHub access token from GitHub. That access token you can give to Cloud Code, and Cloud Code can continuously push to GitHub. Then all I need to do is from my phone, just once in a while, check my GitHub repo to see what are the latest changes that are being pushed, or if it is even working. I can see that it's working if it is like if the latest push thing was 2 minutes ago or 5 minutes ago. I know that in the weekend, if something is pushed 5 minutes ago, this tmux session is keeping on running, right? So this is how I was tracking. Here, I did not use OpenClaw. OpenClaw also can be used. That way, you can even actively give changes. You can tell through Telegram that, hey, what you're doing currently is not correct. You have to stop doing it and do something else. But here I'm talking about if you don't want to use OpenClaw, what is the cleaner solution? The cleaner solution is this. So now the tmux command is tmux new -s session name. So what you need to do is go to your terminal on your remote EC2 instance, type tmux new -s, and let's say the session name is demo_session. Then this will start a new session, and you see this green color bar underneath. It means this session will be active even if I close my terminal. So if I delete this, okay, now my terminal is closed. And then when I open it, I can get that session back by typing tmux attach, I think, and then demo session. What was the name? I forgot. Okay, not demo session. Tmux attach -t session name. And list all session is tmux ls. So let me just first find my session name. So tmux ls. So there are actually one session running, which is demo session, and then another session running that is called VLA. So this VLA was my previous session where I was running that I have not killed yet. So basically what we are doing now is the same terminal, we are splitting into two different terminals. So one terminal has the name demo session, another terminal has the name VLA. So if I go to VLA, it will be an active terminal, which will be continuously, if I have asked it to continuously run something, it will be continuously running it. But now I'll go to this demo session. So tmux attach -t demo_session. So now see, I'm back into my session. Now let's try something. All of this tmux I'm doing on EC2. Yes, exactly. So now we are not doing anything on VS Code on our computer. Everything is on EC2. And why is that? Because our whole idea is this. We want to set up a workflow where something will happen even when you are sleeping. Let's say you want to build a complex website. It'll be great, so great that by the time you wake up in the morning, something is ready for you, right? That way you're like, you are sleeping, but at the same time working. So that is the goal here. So for that to happen, something has to run on a computer which never switches off. You have two options, Mac Mini, something like that, or buying a virtual machine like EC2. Now in EC2, when you are having a terminal, accidentally when you close it, your activity might stop. So to not have that happen, you can use tmux. That is one way. So terminal multiplexer, or you can use OpenClaw itself. OpenClaw can manage the terminal session without making it close, right? So this tmux, let me now go back to OpenClaw. In OpenClaw, now I'm going to give a command. I want to build a very simple personal portfolio website for me. And but I don't want you to build. Instead, instruct Claude Code to do the execution. Otherwise, what will happen is I will incur a lot of charge on my Gemini. I have already paid for Cloud Code, so Cloud Code should take the most responsibility. But there is a limit to number of tokens that can be consumed in a day. Yes, that is a very good question, Saurabh. I was also concerned with the same thing when I was running my code. I thought it will consume my tokens and it will stop the execution. But you know why it did not stop? Because Cloud Code was writing the code, but the code was actually run on RunPod. Because RunPod has GPU, I need GPU access to run my code fast. So as long as RunPod credits are not run out, so I had put some $100 or something on RunPod. So RunPod credits were not running out, and because of that, my code was continuously running. The only thing Cloud Code was doing was writing the code, which is not that expensive, right? If you to write one single Python file, which is defining a neural network architecture, that's fine. That it can do. But to execute it and do more complex stuff, you need not more complex stuff, more complex calculations on GPU. You rely on RunPod. Why execution will consume tokens? Execution on RunPod will not consume token, but writing the code itself will consume tokens. Okay, Sriharsha is saying ACP runtime is not set, so it can't use Cloud Code. When you say it, what do you mean? Your OpenClaw cannot control Cloud Code. Is that what you're saying? It's a bit weird. I'm not sure. Can you ask this issue to? It's not configured on the system. Can you ask Cloud Code itself to fix this? That's the best solution. I mean, it will figure it out. Okay. Anyways, let me. I will give you a few info. Refer to my past website. This is old and poorly formatted. So I have a portfolio website which I built a few years ago, very bad, using Google Sites. So I'll just paste this here. Then refer to LinkedIn. I'll just provide my LinkedIn link. Yeah, I can provide the same instructions via Telegram also for sure. So this is my LinkedIn. And then third thing which I will provide is Google Scholar. Make it a simple, static, modern website and host it or deploy it on Vercel. So now we'll have to give you access to Vercel, access of Vercel to Cloud Code, which I will do later. Deploy on Vercel later. So now this is the command. Let's see if I also face the issue. OpenClaw access not configured, Telegram user ID. Yeah. So for Dishant, what you need to do is look at the last line. OpenClaw pairing approved Telegram with that LHXXX, that thing, right? Just copy that, copy this thing and run it on terminal. I'm just pasting it. So this thing which I have pasted, just run that on your terminal. Then OpenClaw will be connected to Telegram. So now what is happening is, now I have not started a tmux explicitly, terminal multiplexer I have not started. However, now my OpenClaw will control the Cloud Code on my remote EC2 instance. And now this website building would have started, I presume. We'll see that. So now what can I do? Technically, I can just close the computer and go home. And to know the status, I can just open my Telegram app and just ask is tell me what are you building now. So I can just ask Telegram on my phone or on computer. Let me know what you would like to work on. Okay, I don't think the Telegram has yet. I mean, this part is a little bit slow, but let's see. OpenClaw will also use CCO command or Cloud command to start Cloud Code. That is a good question. I don't think OpenClaw will use CCO, and because CCO is something that we are doing, right? OpenClaw will directly open Cloud and run, and it will keep giving permission. So OpenClaw is like your agent, right? It's a replacement of you. So just like how you will provide permissions to Cloud Code, OpenClaw will do the same. Look at your current process. So one annoying thing I don't like on this Telegram on desktop is it doesn't show me anything that something is being worked on. Okay, let me just check what's the deal. Right now, my Telegram is saying nothing is happening, but something is definitely happening, right? Let me say process running in the background. So you are free to switch off your laptop and go about your day. I will notify you once Cloud Code has finished building the website. So let me ask, I don't know why this is hallucinating. I had asked to build a portfolio website via browser GUI or browser gateway. So everything, whatever we are asking in Telegram, we can also ask in the chatbot in Chrome. The thing is, the Chrome session, you will need access token, and it's a local host session. But Telegram is like an app, so you can technically see that on your mobile phone, right? So see, now if I close my laptop after the Zoom call is over, I close my laptop, it will still be running. And to know the status, I just need to talk to my EC2 instance, which is executing, I mean, on which Cloud Code is building, which OpenClaw is controlling, to which I am talking through Telegram on my phone. So basically, the workflow is this: uh, I have Telegram. This is for my communication with OpenClaw. I have OpenClaw as an orchestrator for Cloud Code, and Cloud Code is installed on my EC2. Right? So I will use this if I want communication from me to whatever the process is happening. This is the workflow. But let's say I don't want anything to communicate. I just want the status update once in a while. Then the workflow can be, let the Cloud Code control the, sorry, my Wacom tablet is having some issue. That's why my handwriting is coming so bad. Not that it's great, but yeah. So Cloud Code is running on EC2, and I can just run tmux session, and whatever the project is, connect it with GitHub. So then I can see on GitHub what are the latest changes that have been pushed. So just by looking at GitHub, I'll see the status. But I won't be able to communicate. If I want to communicate, I'll have to open my laptop, open the tmux session, and then instruct the Cloud Code. But if I want two-way communication where I want to see the updates, plus also tell Cloud Code something to do, this is the better workflow. Connect OpenClaw with Telegram, ask OpenClaw to execute the workflow using Cloud Code, let Cloud Code handle the heavyweight. OpenClaw will be using Gemini. This will consume some tokens because Orchestrator will also require some tokens, but this will be minimum. Your maximum expense will be on Cloud Code, but this anyway you are spending on a monthly basis. So it's not like, unless you explicitly recharge for another $50 or something, you will not be charged extra. So this way you minimize your expenses. Can you also let OpenClaw to keep updating you about the progress? Absolutely. So what you can also do is you can say update once in 5 minutes or something, or you can say tell me the latest status update. No work has begun. I'm waiting for your instruction. What do you mean? How does it know about your background to build your website? I had given 3 links. I had given my LinkedIn profile and one of my old personal portfolio website links, this one. Plus, I also gave my Google Scholar. So I'm hoping that with those 3 things, it will find information. Even in the absence of all of that, it will do something. Oh, so some error had happened. My apologies on the previous error. I have reinitiated Cloud Code. Okay, so maybe something was paused or something. Okay, anyways, tell me your plan and the stat plan, milestones, and periodic progress. Also, send the same to my Telegram app. And meanwhile, let's check the usage. $0.142, not too bad. And unexpected, also send me the same too. Limitations with session spawn mode equal to session. First, I received the session requiring ACP. Okay, I'm also receiving the same error, I think. Thread bindings are unavailable. Okay, let me do one thing. Can ask send the status to another person via Telegram? Great question. I think so. I mean, technically we can instruct a Telegram bot to send message to another person, right? So by that logic, I think it should be possible. I have not tried it. Great question, but I think it's possible. I don't see why it is difficult. Okay. Okay, this is the third time it's saying I have restarted, but let's see. This usually works, but I have no idea what's going on right now. My OpenClaw was perfectly set up earlier, but now because I reinstalled it, I think some issue might have happened. When operated via Telegram after instructing Claude, does OpenClaw receive back the response from Cloud Code and report on Telegram, or just trigger the run and forget? You mean, is there a communication? Is there some way in which OpenClaw can get something explicitly from Cloud Code? I don't think Cloud Code directly communicates with OpenClaw. It's more like just by looking at the changes happening in the folder structure and what the Cloud Code is performing, just like our human knows what the Cloud Code is performing, OpenClaw can tell you what is happening. But it's not like Cloud Code is explicitly communicating, hey, I'm doing this to OpenClaw. I'm not sure that can happen if we explicitly set it up, but by default, I don't think it's happening. And here, please understand, Telegram bot and this GUI, which you are currently seeing on Chrome, they are literally the 2 gateways to communicate with OpenClaw. The third gateway sort of is the terminal itself. For terminal itself, you can run commands, but that is very difficult. So that's the reason why the gateway can be anything. It can be WhatsApp, it can be Slack or Discord or Telegram, any app. But Telegram has this very nice, easy way of creating the bot. That's the reason why I went with Telegram. But you can do this for pretty much any app. There is great connectivity with multiple apps. Please provide session key for your Telegram account. If Claude Code is waiting for any feedback, does OpenClaw handle this? Yes, absolutely. That's the whole reason. So I think even if you did not install CCO, OpenClaw can handle the feedback providing process, because OpenClaw is just like a human agent. It knows your preferences. It will act on behalf of you. Session key for your Telegram account. Where can I get session key? In the OpenClaw gateways configuration or status page. let's see, I don't need it directly here. I can directly ask here. So now look at the process that is happening. I'll show you one more thing. On Telegram, on my computer, I have a folder called AI Context Engineering Bootcamp. From that, from the day one session, can you share the first figure which I had created as part of the session one notes? You can send me the PNG here directly. So I'm just asking a random thing, right? So on my computer, there is a very specific folder in which there is something. I'm giving vague instructions here. This is probably not the exact exact folder name, but I understand you're looking for specific figure. However, I cannot directly access files on your computer. My environment is sandboxed. I only have access to your workspace. Oh, really? Um, I wanted to have access to my. It is in the folder called agents. Maybe that is the issue. Maybe this is in a sandbox environment. So let me open a new terminal and another Cloud Code session, and I will ask it to fix this issue. Give open claw full access to my EC2 to fix the below issue. The lecture videos and stuff upload after session. No, I I have an automatic pipeline for it using MCP, but it's not fully set up yet. So that I have to manually upload. I had constructed a MCP server for the Firebase database where all the website data is stored. And technically, yes, to even create a course, modify a course, upload something, download something, I can use the MCP. But this time I did not use it because I noticed that some function which I had written are having some issues. Not I did not write it, Cloud Code wrote it, but there are some issues which is not giving me the exact output that I'm expecting. So that I need to fix once. But that we can fix. So by the way, for the build session, what I'm planning is to build an email chat. So everyone should be able to build that email AI chat with me. So for that, one thing is just try to understand. Can you guys tell me in the chat like how often, like how many times in a day you might be replying to someone on email? Like roughly, is it 10? Is it 5 or 3, 1 or 100? Okay. So on the order of, let's say 10 maximum, right? 10, 20-ish. Okay. I'm sure someone else might be doing it many more number of times. So I personally, I have at least 200 emails at any given point to reply. So I do need a proper chatbot. So one thing that we will build is um, we will figure out how to create a vector database of your past email responses and how to craft a response very much like you and how to set it up, how to set up that pipeline. You probably won't need it now if you have only 1, 2, 3 emails to reply to, but when you have 200 emails, you will not be operating it like that. Um, so I'll just show you that, but that same pipeline can be extended to pretty much any tool. instead of email, if you want to extend it to Slack or something like that, that same pipeline can be set up. But anyways, let me see what Cloud Code is trying to do here. Okay, now restart OpenClaw gateway so that the change takes effect. So, okay, how do we ensure our email info is not exposed to OpenAI or Gemini? Do we have to run local LLM? That is a good question. So email info will definitely be exposed to whichever LLM we are using, right? So if we use OpenAI or Gemini, we are giving it access to that particular email thread. So it will, so otherwise the other option is um, you can have an LLM set up on your own cloud server. And yeah, if it is Gmail, then Gmail and Gemini, not a problem. If you're using Gemini and then if you're also using Gmail anyway, they have the information with you. But if your email provider is like Outlook web app or something like that, and you want to use Gemini, yeah, that's when you might need on the cloud something. Okay, gateway has been restarted and healthy. OpenClaw has now access to entire home directory. Okay, now let's see. Now I have provided you the full access. Please try now. So see here, the context of this full conversation is available to OpenClaw. So I operate within a remote sandboxed. What is this? So this is one process which we are doing on the side, okay? But meanwhile, OpenClaw is definitely continuing with the building. This is just to show you one use case where I can show you how even the Telegram can fetch files from your remote. I just want to show you that. That's my purpose. But let me see where the current process is at. So tell me the status of website building. Because we started Cloud Code with CCO. So when I, sincere apologies for previous failures, created the website directory, restarted Cloud Code. I think my OpenClaw is not able to probably access Cloud Code because of the restricted environment, but let's see. I think this issue some of you might have been facing, right? Just let me know if you had, if you managed to connect Cloud Code and OpenClaw and get something to work yet. This can be fixed very soon, I hope. What is the path to this directory? Can we directly use OpenClaw without paying? Yeah, I mean, OpenClaw is free. It's open source, but you will need some API, some LLM. The LLM can be open source LLM. So if you have access to an LLM where you don't have to pay, of course you can set it up. So you're not paying anything to OpenClaw. Right now I'm paying because I'm using Gemini. Home Ubuntu portfolio website. So this is the directory now. So this is the directory in which OpenClaw has asked Cloud Code to build. But I just want to verify that in fact something is getting built, because if something is getting built, we will see the files here, right? But I doubt something is happening here yet. Yeah. So use OpenClaw if you want an agentic personal agent for doing your task, and use any open source LLM. That will be a best workflow. Okay, so I don't see anything happening here, which means I think OpenClaw is still failing to connect with this particular either outside the sandbox environment. So let me just see. So let me ask Cloud Code, can OpenClaw access this folder? So today, as soon as the portfolio website is kind of working, I think we can wrap up today's lecture. So roughly half an hour probably will be remaining. As soon as I can show you the workflow where OpenClaw has connected with Cloud Code and something is getting built. And building part will be very fast because this is a static website. It's not a dynamic website. So that part will be very fast. Yes, I wanted to cover skills as well, but I realized that this part is taking too much time. What I will do is I will record a separate video on skills and commands, and then I will post it on the course dashboard. That part is anyway very easy. It won't take any too much effort, but it will take some time to go through it. OpenClaw can access this heads up config expose secrets. That is fine for now. I'll delete it anyways. Now let me just close this and start a new OpenClaw gateway. Now, can you ask Cloud Code to start building the website in this directory? First, check the connection to Cloud Code. If it is not working, let me know that first. Okay, one thing I have noticed is OpenClaw is definitely hallucinating when it says it has reinitiated the Claude session, but then it's not notifying me when there is an issue. It's making me wait and ask whether something is running or not. And I don't see any files or anything in this, in this folder yet, which makes me think the process is somehow not getting started. How to see the session progress? Okay, now something is getting built. So seems like it's working. So some CSS, JavaScript assets. So assets are probably scraped from the website, right? Now, meanwhile, while this is going on, let us do one more thing. Let's go to Vercel. For deployment. Vercel access token. So the way in which you can connect pretty much any application like Railway for backend or Supabase when you are having something on your database, which we will be using on this Saturday's lecture, or so you can connect GitHub for pushing your versions, then Vercel for pure frontend, Railway if there is a backend. Of course, there are many other platforms. I'm just saying the default easy ones. Supabase for a very basic database. If you want to quickly build, by default these agents default to Supabase. So all of these you can easily connect using creating its own access tokens. So that access token creation process is different for different platforms. Process meaning you just go to a particular location on your account and it will provide you provision to create access token either at a project level or at a user account level. Okay. And then once the access token is there, automatically Cloud Code can keep pushing to GitHub or keep pushing to deploying on Vercel. How does Cloud on EC2 get information from LinkedIn or Scholar unless it's authenticated? I mean, the LinkedIn profile itself is public, so I think it can get access. Scholar is also, it's like a public link. It's not like you have to log in or something. But if we ask it to get some data about something where an authentication layer is there, then I don't think it will work. But in general, what I have noticed is for social media, scraping from LinkedIn is very hard. Scraping from Reddit is the easiest because they provide API. So I think that's also one of the reasons why many LLMs have been trained a lot on Reddit data. As a social media, they make the scraping part very easy. But yeah, I think LinkedIn, I hope it can find some information from LinkedIn from the public profile. Let's see. Okay, index.html. So some things are working. And now if I ask the Telegram to find my image, can you try now? So Railway is a very nice backend deployment. So when we implemented the YouTube MCP last time, that MCP server was running on Railway. You guys remember we fetched the YouTube URL. From that, we found the transcript. From transcript, we created the lecture notes or summary. There, a Python script was running, and that script was basically um, running on the Railway backend. LinkedIn personal info. I mean, LinkedIn, all the personal info, whatever I have in public, I don't care if Cloud Code gets access to it because that's the whole reason. It's a public profile. But yeah, if there is something private which I don't want Cloud Code to get access to, that's where you just simply don't give it authentication. Okay, for example, if it is in, however, I don't see a folder named. Can you list the folders inside the agents folder? Okay, I see. Okay, so now it has found the folder. Yes, this is the one. It's so stupid. It's not able to get the result in one shot. How many times should I give? It's not that smart actually. You can see that. I think what is missing right now is I have not given any background information, anything, right? So maybe that's why. Yeah. Gemini 2.5. I'm trying to save cost and I'm expecting world-class performance. Uh, Sridhar, I have located. No, I need the PNG file. And meanwhile, let us check on our website task. Give me a status update. Session completed. Okay. Can you local host or let us deploy on Vercel? Index.html. Here's the plan. Install Vercel CLI. Log into Vercel. All right. So I can just run this. So yeah, either it can be through access token or just install Vercel here and then log into Vercel. Yeah. If you are not using OpenClaw or anything, if you're just using Cloud Code, the best thing to do is for simple tasks, switch to a cheaper model. Okay, now this is done. Now we just need to do login. Okay, so Vercel authentication is done. So this time, instead of creating the access token, I use this command line interface. And now I can go to CCO, uh, deploy this website on Vercel. Yeah, so using cheaper model is basically switching the model. If you're using a coding agent, I'll just show you, once this is done, I'll show you how to switch. Very easy. On OpenClaw also, you can assign pretty much any model. You can give that instruction in the text itself. But let's see first if this Vercel thing, once it is done, I just want to show you the website. I have no idea because my instructions were very crude. I have no idea what it has built so far. Okay, so this is the link. And eliminate the need for Vercel authentication to see the website. I don't like this so much because, I mean, these things are fine, details are correct, but I don't see a single image that are used here. I don't think the Cloud Code has very nicely fetched images. Yeah, not a great website, but this is what I deserve because of the very poor instructions I gave just to save time. But with proper instructions, but you can already see that the structure is 10 times better than what Google Sites had provided, right? So it's very nicely. Yeah, so today's content is different. So in the production patterns, what I plan to cover, JIT, I realized that we have already discussed in lecture number 4 or 5. So JIT, I entirely decided to skip. The only thing which I planned to cover from PRP workflow was setting up the workflow with initial.md files, setting up it with slash commands and slash skill. So that I will record a separate video. But I thought this will be much more useful to you when you go ahead and build something. So yes, session 7, some things have changed. But you see the value of this in the sense that this website is entirely done using OpenClaw plus Cloud Code workflow. And let's see if in Telegram, this guy has been able to access any PNG yet or not. It's still finding it very difficult to find the .png files. There are clearly PNG files in the folder. You can also instruct Cloud Code to create using Gemini thumbnails. It knows how to use NanoBanana. Yeah, of course it can. How many of you have heard of this one, Auto Research Claw? It's a recent GitHub repo that just came out. Not the auto research from Andre Karpathy, but another one. It's from, I think, University of North Carolina, Chapel Hill. And this is kind of getting popular. Yeah, it's in this lab only. So just have a look at, oh my God. So yesterday, you know how many stars this had? Only 1.8K stars. So in one day, it has gathered almost 3K stars. Basically, this repo is amazing. Whatever idea you have, you can just describe it in few lines and it will run an end-to-end pipeline of running the experiments and even writing the paper. It's crazy where the direction of research is going, in the sense like there is a lot of debate also happening in the research community. One thing which I today morning only I read on LinkedIn is that um, if let's say you are reviewing for a journal or conference, and let's say you are using an AI tool to create a review, automatically, if you as a reviewer, you will be flagged, and if you submit something, your thing will be auto rejected, desk rejected. But then the discussion that was going on was, if the review comments are actually good, if it is actually relevant, useful comments, why do you care if it came from a human or whether it came from AI? Same dialogue is happening when some conferences and some journals allow AI based submissions. So there the question is, if the paper is entirely written by AI, experiments are entirely done, the code is entirely written by AI, and the execution is done by AI, the figures are created using paper banana or nano banana, then what is the role of human in other than setting up the hypothesis and other than giving the initial instructions and kind of overseeing the workflow? And if that is the case, what is the value of the paper? Then the other side of the debate is, um, if whatever is presented in the paper is legit, if a new hypothesis is formed and if it is tested and if the scientific methodology is correct, should you as a journal or should you as a conference organizer, should you care whether the paper came as a result of AI's experiments or whether it came out as a result of humans experiment? Because for science only cares about knowledge. Whether it came from an experiment executed by AI or by humans should not matter. So it's like a very hot subject of debate these days. And there are professors on both sides of the debate. But yeah, just check this website. I mean, this GitHub repo once. I think some of you at least might, find it useful. So my Telegram is kind of failing, probably because my model is very weak. It's not that smart to look at the entire context of my, workflow, my folder working directory. But let me go back, and here now I can give whatever instructions, right? I can say, um, the style looks very old. You have not added any images from the sources I provided. And then I can just continue to ask. And if I run this on Tmux, so right now I'm not using OpenClaw. I'm just using directly. I'm putting it in terminal. But if I use Tmux and if I give proper instructions with so here, we have violated every single principles which we were discussing throughout the course. Cloud.md, where is cloud.md? Where is .cloud folder? Where are skill.md? Where is agents.md? Nothing is there because we did not explicitly say any of that to my OpenClaw. OpenClaw just executed the task in the most crude way. And for that reason, you can already see that it's not very good. Build examples of good portfolio website, which you think you want to mimic. Then what all sections should be there? What framework should you use? React.js, Next.js, or something else? So that we can, we'll have to set up in cloud.md file or some other markdown files using which you can create the cloud.md file. So yeah, just to reiterate on the plan. So I deliberately changed the plan for session 7 because I realized that for session 8, when we are building, we'll be directly building. We'll not be spending 2 hours on setting up the workflow. So to set up the workflow, we had to spend some proper amount of time. So by today's lecture, you should have the workflow ready so that by Saturday you can build. Now, few things which I wanted to cover today, which I will not be covering because of lack of time, is setting up / commands. That part is easy to do, but I will need some time to teach it. So I will create a recorded video and I'll put it so that it's available to all of you. Second thing is skill.md, how to set it up. And at the beginning, what does a template of a cloud.md, what does a template of a initial.md, etc. look like? For Saturday, we won't need it. The reason is on Saturday, our focus primarily will be on some other things. To create proper MD files, we'll be asking Claude Code itself to do it. And I'll show you how good it looks. But on Saturday, we'll be using the following. We'll be using memory, RAG. We will be creating proper system prompts. And then we'll be using Railwave, I think most likely for backend. Vercel, we'll be using Supabase for database. Then we will be using Gmail authentication, because if you want to connect your AI reply agent, I mean, it will be a separate website, whatever you build, but it has to have information from Gmail. So connecting with Gmail, then what else? Feedback system. When you are giving feedback to your application or to your email reply agent, how is that feedback stored in the Supabase database, and how is it fetched back to create a proper email in the next round? So the same mistake should not be repeated twice. And hard coded rules. If there are some specific rules which you want to enforce, how do you enforce that? So all of that we will see. Other than that, the only prerequisites are having Python, having Cloud Code, because my workflow is based on Cloud Code. You can use any coding agent, but you need to have access to some coding agent. One discussion that I wanted to make was regarding the Pro plan, which is, I think, $20 versus Max plan. I think Pro plan will allow you to implement something as long as it is one project, like as long as the number of tokens are in the scope of one project, but it will not allow you to conduct. And I don't know whether it refreshes every session. Maybe it does. I have to check. But I have Max plan. Time will be from 9:30 a.m. most likely. I'll finalize it. Currently, I have announced it as 9 a.m., but 9:30 a.m. on Saturday. It will mostly go for 2.5 hours, maybe 3 hours. For Saturday session, you will not require EC2 instance. EC2 instance was my way of showing you, hey, if you want to control your workflow remotely, this is what you can do. But on Saturday, we will be using OpenClaw is optional. We will use Tmux, because in case, what if your app building is taking time? So for those of you who want to properly build a nice app, which may take 4 hours, 5 hours of build, and you want to move away from your computer and do your stuff, I recommend you go with EC2 on Saturday. CCO, yeah, there is one question about CCO on Windows. I actually don't know the solution, in the sense, like, I have seen this being a recurrent issue, that CCO, when you are installing on Windows, it's not working. I don't know. I don't know whether CCO is meant for OS or just for Windows. I don't know. So that you will have to figure out yourself. But other than that, for those of you who want to do a serious building, which will take several hours, even after the session, go with EC2 instance, and there either use OpenClaw or Tmux. That's the first thing. Second thing is, you will need some coding agent. I don't care what it is, but whatever works for you. I strongly prefer Cloud Code, because it's really good with Opus 4.6. And once you use it, you will truly realize the productivity gains, and you will probably not go back. And it's worth the investment if you truly want to do something amazing with it, amazing with coding agents. Apart from that, everything else you need, we will be covering in the session itself. And we run everything in local. Initially, we'll do everything in local, but we will also deploy, because ultimately you want a deployed app. Otherwise, you will have to run everything on local each and every time. So we'll have a deployed app, hopefully by the end of the session. It will probably not be the greatest of the apps. You will have to take a lot more effort to make it great. In 2.5 hours, you can't build a great app, but it will be a decent app that will work according to your preferences. And in the project, yes, we can discuss about context window, which LLM is using for that particular application. Because at the end of the day, when you are building, when you learn about context window and context engineering, you at the end of the day, you want to use it to build something. And while building, you will realize that, oh, my LLM has a token window of like 150K tokens or 200K tokens, which means if I have a markdown file or JSON file which consumes 20K tokens, which was the case recently for one of our projects, the entire system prompt was 20K tokens. And because of that reason, too much latency was there in the application. So then we decided, actually the system prompt should not be like a dumping ground for everything. It should just have very basic instructions. Everything should be in a hierarchical folder structure plus RAG on top of it. So we will discuss those things. We will try to minimize as less context as possible and try to get as best output. All right. I think we'll wind up the lecture here. There's a question from Roshan, content later on this: evaluation methods, ground truth, LLM as a judge, user simulation, production anti-pattern, post-mortem diagnosis. Yeah, we can have a brief discussion about production anti-pattern, but I have some interesting material on LLM as a judge, evaluation methods, etc., which I plan to. So there are few more material which I have not released because I have not finished fully making it and compiling it. So there are some PDF notes which I want to share with you. So that will be compiled sometime end of this week or early next week, and I'll be posting it on the website dashboard. So thank you so much, everyone. I know that for many of you in today's session, I'm not 100% sure how many of you managed to create EC2 instance, or how many of you even managed to reach the level where OpenClaw is installed, because each of you have a different computer, a different configuration, and there are n number of roadblocks you can encounter. What I suggest is go through the recording of this session once you are done with the session, once I post the recording, and then sit on it once, and then fix each issues one by one. To fix all the issues, at the very first step, install Cloud Code. It will tell you what exactly to do, whatever your technical issue is, right? Even if you are facing issues in AWS, there also you can solve it with the help of Cloud Code. You just provide it screenshots. It will tell you exactly what to do. So use Cloud Code wisely as somebody like someone who's smarter than most of the humans on the planet, and somebody who knows everything, and that person is sitting right next to you. That is Cloud Code. So use it like that and build things fast. So after this session, even if you have not managed to reach the final stage of some website outcome, don't worry, just go through the recording once, and by Saturday, just be ready with everything. So see you next on Saturday at most likely 9:30 a.m. Um, Currently, the announcement is that it is 9 a.m., but I will most likely push it to 9:30 a.m. because there is a slight overlap with another session with Dr. Rajat is conducting separately. So we'll mostly start in 9:30 a.m. so that there is only half an hour overlap. Some students in this course is also taking that course on VLA and world models for robotics. So just to minimize the overlap. Anyways, it's just for one lecture. So yeah, I know many of you are attending that. So I will ask Rajat also, should the first session go for 8 to 10 a.m. IST, or should it finish in by 9:30? In that case, there will be no overlap. So I'll talk with him. So thank you so much, everyone. We will meet again on Saturday. Please be prepared with everything: Cloud Code or any coding agent, Python, and some brief review of today's session so that you know the workflow kind of. Previous sessions, even if you have missed something, it's okay in my opinion. It's just that you will probably not have a great sense of where things fit in the theory, but that's okay. You can still build. So thank you so much. See you in 3 days. Bye.